All right, good morning, everyone. Thanks for joining us today for the structural module of the training week. Today we have Brad Baumgarten from here in Central Alberta. He is a safety codes officer, and he's going to be teaching us the structural and the exterior portions. So we're going to start off with the structural module, and I'm going to let Brad kind of give himself a quick little intro about his background, and then we will start. So take it away there, Brad.
Yeah, okay. Good morning, everybody. Like Alex mentioned, I'm a safety code officer. I have a construction background, journeyman carpenter by trade, been through some technology training, obviously the courses to become an inspector. A lot of my work experience was with commercial and crossover commercial residential. Did a lot of work with extended care homes, a lot of it in a supervisory role. Moved into safety codes, probably 15, 20 years ago. It was around 2020, I guess. Worked for the city of Red Deer for a while. I was with Alberta Municipal Affairs for about 8 years. Red Deer County for 5 years. And yeah, now I'm working for another company called Park Enterprises. They're located in Southern Alberta, but I'm working out of the Central Alberta, doing mostly commercial plan reviews and stuff for them on that level. So yeah, this will be interesting, and hopefully we can everybody learn a little bit of something here today. It'd be great. So I guess this is my first time doing one of these for you guys, and I understand that there's a time frame. Usually you start around 8 o'clock, and then I think a coffee around 10, it sounds like, and then maybe we'll be looking at a lunch break around 12 to 12:30 kind of thing, and then I guess we'll see how the afternoon rolls out. Alex can jump in wherever, because it's a little different audience. I did back in my days with the province. I did do a fair amount of training, code related stuff when there'd be a code change or new. Mostly that was mainly what it was when there was something new came in the code or a change to the code or something. And I was also involved in some investigations, and so some of this stuff is, I'm a little more versed on than others. With regards to your industry, the after the fact, looking at existing homes and things like that, probably not my forte. I'm more involved with, new construction. Although, like I say, I did spend some time looking into some issues. We'll talk about that probably this afternoon when we get into the building envelope stuff, stucco problems and things like that. So, again, I'm hoping Alex can help me out here and there. I'm not sure your guys' format or the pace you want to go. I assume Alex can help me out with this. If people have questions, are we verbalize them or chat questions, or what's the, if I'm going too fast, I want to go over something again?
Yeah, typically what happens, Brad, is either the attendees will speak up or they'll just put something in the chat box. And obviously, if it's in the chat box, I typically just answer it. If it's something that is relatable to the class, if you will, I'll just maybe ask you after you finish the point. Other than that, they'll just speak up typically as they go.
Okay, I guess with that we can start moving along. So like Alex mentioned, we'll do the structural module here. So let's move on with the slides. So I think here was just basically some examples of bare land footing, and then we get into the actual foundation. So this is stuff as a building inspector we usually come in over at the complete side. Not too often, not too many municipalities will do a footing inspection. There's things like really you can see most of what you have to see to reasonably determine code compliance prior to backfill. So things we look at that time would be like, that the soil's it's undisturbed, it isn't unfilled, or organic material, the dam proofing. This example I see on the right here, it looks like they've put in some strips in here which are they have a window well, so this should have been, prior to backfill, this would have been dam proof to grade, things like that. Window well, here's an example. Like if you have weeping tile around the building, there should be weeping tile in this window well that'll run down to that perimeter drainage rock, things like that. So
maybe I'll pop in there too, Brad. So folks, the structural and foundation aspect of a home inspection is typically can be the one that's going to be the hardest for you to see, because generally the structural members will be covered up. If you have an unfinished basement, that's obviously going to expose a lot of things like the interior side of the foundation wall. You might be able to see the joists, whether it's wood eye joists or dimensional. And besides that, right, maybe the attic space, if there's an access, you can see the rafters and trusses, but it's going to be really, really hard. So generally it's hard to see what's actually going on from a structural aspect. Like you will generally not be able to see any sort of footings unless there's a crawl space that's accessible. So a lot of this stuff is kind of, I don't want to say theory, but more knowledge for you to understand. And we will be starting to see quite a few defects here later on once we get past the, the theory here.
Yeah, okay. No, that's great stuff. Okay, we'll move on. So here we go. Yeah, this is Alex alluded to. There's different defects, which again, these are things that, boy, if we see that early on in a house, it's problematic. The vertical cracks, I don't know if they're as big an issue as the horizontal cracks. If concrete shrinks, I mean, that's a fact. I mean, that's why you're required to put dam proofing, on the exterior to keep any of these hairline cracks from letting too much in the way of moisture in. The thinking is the concrete should be laterally supported at the top and at the bottom. The slab holds it at the floor level, and the floor joists, if they're properly attached to the top of the foundation walls. So that really isn't a big giant concern. When you have a horizontal crack, though, that is really starting to say there's a problem, because the top isn't moving, the bottom isn't moving. Is this a shrinkage crack? Probably not. That's probably an issue with backfill pressure or something along those lines. Never say 100% so, but definitely more concerned with horizontal crack. And diagonal cracks are kind of, I don't know, they're kind of in the middle from my thoughts and my experience. Often these cracks will occur around the window wells too. You'll see, because it's a weak spot in the wall. So when you cast a concrete foundation wall, you got a 40-foot long wall or what have you, and you put some windows in there. Well, when the concrete's going to cure, it shrinks a little bit, and it's likely to crack anywhere that's a weaker spot, which would be around a window or an opening in that wall. And again, yeah, these are things that from your perspective, I mean, it'll be after the fact. You'll have no idea if there's been rebar reinforcing in here or not. Code doesn't actually require reinforcing. Most people, my experience has been, they'll at least put a couple of horizontal bars in the top and the bottom of the wall. Some builders will put some vertical bars in there, more so with the, because it's not a code requirement for the cast in place walls. You'll see the way higher level of reinforcing like in ICF type foundations, but we'll just move on from there.
With cracks, folks, you'll always want to indicate them in your report and let your clients know, just because if you see a small hairline crack, you might think it's just a settlement crack, like a typical vertical crack or maybe around a window. If you don't point it out and say after a heavy rainstorm there's about a bunch of water intrusion inside the dwelling, that can cause a lot of concern for the homeowner. So it's best to indicate that they're there. Again, if it's a small shrinkage crack, vertical crack, you don't need to make a huge fuss out of it. But when you start to see these horizontal and diagonal cracks, that's more of a possible structural concern. Whether, like Brad said, if it's lateral forces from the soil with hydrostatic pressure, maybe big tree roots. Even if you have a parking pad right by the exterior of the structure or the dwelling, and you have big trucks or RVs or anything that can cause a lot of vibration to the soil, they can actually also cause these sort of cracks. I mean, I've seen it during my my times.
Yeah, good points. And I guess, if we get back to if there is moisture, part of it is a hydrostatic pressure thing too. There might be staining on the concrete, right? Like you might see signs of moisture ingress and things like that. But
so yeah, the image on the right, you can actually see, the watermarks with that diagonal crack. So I mean, I just go back one slide there, Brad. There you go.
Yeah, it's starting to seep down, leak a little bit through there. So you got something that's not quite right there. Okay, I guess more details on the cracks in the foundation. So there is an example, yeah, coming off a window. That's probably, nothing to get too excited about. If it's an older home and everything else looks like it's pretty good and nothing's really moving around or looking too out of place, it could be something that may be just for moisture purposes. It should be patched or sealed, but ties, yeah, these should be removed and patched and sealed. So hopefully you don't see a lot of this kind of stuff around. That's just kind of a lazy workmanship, I would say, or something that maybe in a really older home. That style of tie goes back a long ways. It's probably 60s or 70s. So I guess just something to be aware of.
Another thing, folks, so when you're doing the exterior portion of the inspection, if you can just go back one slide there, Brad. So just be careful if you see hairline cracks in the parging. So the parging is not, the concrete, but it's just this little masonry covering that you would put against the foundation wall. If you see small cracks in that, again, that's typically not the foundation. If it's completely blocking it to the soil, you don't know unless you dig a little bit below the actual earth just to see if it actually continues through the foundation wall. But just be careful not to call out a small hairline crack in parging, because that's not really a concern at all. So just be mindful of that.
Yeah, you don't want to kill a house sale over that. I don't think you're right. So I guess there's some more examples. Yeah, okay, here we have a shrinkage crack. So again, off that window, that seems to be not uncommon whatsoever. Looks like somebody may have tried to kind of patch that up a little bit or what have you. Cold joint, yeah, it could be they ran out of concrete and for whatever reason, or had a problem with the pour, and they had some time between. It wasn't continuous, I guess. This looks like something where they had to wait for another concrete truck or something. So the bottom half of this wall set up a little faster than the top. And again, is it an issue or not? This one doesn't look like there's any kind of structural stuff, but it's not a desirable thing to have. Again, it helps if there's reinforcing in the wall. It's something you won't be able to tell with an inspection on your end. But I mean, if there's rebar in this wall, vertical bars along there, and they got a little bit of a cold joint in there, and the house is 40 years old and no other issues, it might not be a problem. But it could be if there's a cold joint and you've got signs of moisture coming in or any kind of deflection in the wall, something I would want to pay attention to.
Exactly. But again, guys, you want to make sure you point that out in your inspection report.
Yeah, this one here looks a little more concerning a little bit, but I guess we're getting into honeycombing now. So this is just a lack of, maybe the concrete was a little too dry, the water to cement ratio wasn't where it should be optimally, or they didn't vibrate, when you place concrete. Typically you have a concrete vibrator, which is to get the air bubbles out of the concrete and make it nice and smooth and proper. Again, if it's a little bit in a here and there and the odd corner, sometimes you'll see the honeycombing more so in a corner where it might be hard to get the vibrator into, or as they're pouring the concrete, it kind of gets, it can't really flow smoothly around that corner because of there being a turn or something. But when it's a big long wall like this, I mean, it kind of makes you wonder what's going on. I don't want to speak out of turn, but I mean, this seems like a fairly large amount of honeycombing. Again, though, I don't know if you look at the age of the house and everything else, it might not be an issue per se. You really can't tell. Like, I mean, is it something is this honeycombing / cold joint that goes right through to the outside and it's created a bunch of moisture issues? This looks like maybe a crawl space. Again, I think it was something to notice and maybe monitor, keep an eye on, but I mean, again, I don't want to get too far out of my code world here. I don't know how far you would, what level of concern you would raise with honeycombing. It's not uncommon. You'll see a little bit here and there. And like I say, usually it's isolated, a small little, like something the size of a dinner plate, in a corner or something like that. But big long section like that isn't great, but it might not be an actual problem.
Part of your guys' interior and exterior inspections, if you can go back one slide there, Brad, what you want to be aware is if you're on the outside portion of the structure and you notice that the grading is just going right towards the foundation wall, perhaps when this was initially built, it was nice and a nice and smooth wall. But if you have lots of water intrusion over time, it can actually cause the moisture to go through the foundation wall and actually may have exacerbated any sort of honeycombing or any sort of spalling. So the things to be looking out for, of course, as you can see here, is you have actual watermarks here. So this means that this is likely an ongoing concern. Of course, any sort of deterioration of the aggregate. So if you just take a scratch awl and you start picking away at the foundation, if it starts crumbling, then this is a possibly serious thing. Repairs are fairly simple. You can just get a cementous or like a mortar mix. Again, typically you want to make sure you refer to a professional for quotes and any other remediation or repairs that may be required.
Water intrusion. Well, yeah, I mean, this is one where you can actually see what's going on. You have a little bit of a better idea. I'm just trying to get a handle on this. What's going, well, I mean, obviously there's water is finding its way into the home. I'm trying to see what this, if it's a concrete floor, I can't say for sure.
Yeah, it looks like
Obviously,
that's just the slab and the exterior wall. So one thing, the best time to do inspections, I always tell people, is during a rainstorm or a few hours after a rainstorm. And that's typically because you have the water, coming off the roof line, gutters, downspouts, and whatnot. And then as the soil makes its way in, the water makes its way into the soil, once you start getting that hydrostatic pressure where the pressure of the water actually gets exerted, it starts to push its way into any sort of little cracks through the foundation and footing and the slab. So here on the image on the left, you can see you actually have active moisture seeping through that opening. And then the image on the right as well, it's hard to see, but kind of above the coat hanger, if you will, maybe 2/5 down from the top, you'll actually see a horizontal crack, and you'll be able to see water as well coming down. So I mean, these are active leaks that definitely should be further looked at. If you see, there's a little green flag right by that gas line. Looks like, yeah, you bet, right around there. That's where you actually can see the horizontal crack and the water streaking down.
oh, I see. Okay. Yeah, it's the enemy. The host enemy is the water. Okay, well, it looks like some examples of some repairs that have gone on here. So, yeah, I guess just to speak to this, there are ways to fix cracks. I have some personal experience with the epoxy because some of my background, I did some industrial work for a while, and we did tanks, like out at Union Carbide, Dow Chemicals, I think it's called now, and they were needing to be watertight, and of course we poured a big concrete tank, and it was not unusual to have some cracks when some moisture got in. But boy, oh boy, the application of these products is the tricky part of it. The stuff we were using, I think, was a healthy product, and we had to actually drill holes along the crack. My situation was more of a vertical crack, so it was a little more just linear A to B. And then you pound the stuff in there. They have a special gun to inject the stuff to the point where it comes out of the next hole above, and then you kind of work your way up the crack. And I guess the point being, there's quite a bit of direction and a system to doing these things properly. And I don't know, as an inspector in your guys' world, if you come out and see this, you think, okay, it's fixed, but it may have not been done properly. Like, I mean, it looks like it's patched, but boy, that's a kind of a crapshoot. Foam, I don't think it's personally, this would be it'll work, I think, but I don't know if it would be the Cadillac way to fly. It might be a quick fix kind of thing, but foundations, hydrostatic pressure, stuff like that, that doesn't sleep. There's a lot of pressure over a lot of time. The epoxy, I think, if done right, it's going to work. The foam, I would be a little bit reluctant to want to say that's great, but that's just my thoughts.
I'll make some notes here, Brad. So a lot of times, guys, you're going to come across structures, dwellings where the homeowner just bought a tube of $10 silicone, and they'll just do their own fix, right? And I mean, I wouldn't recommend using silicone, but to the other, more preferred options, when you're using epoxy injection, or when the technician's using epoxy injection, generally they'll have to actually score the hairline crack or the crack to make it bigger. They'll typically want to make sure the crack is nice and clean and dry, because the epoxy won't settle properly. The epoxy is a structural based sealant, meaning that if you were to seal that area with epoxy, it's actually stronger than the actual concrete. And there's been cases where they will do a seal with epoxy, and next season, next freeze thaw season, they'll actually get a second crack down the road, or up the line, because the epoxy actually is such a better bond than your concrete foundation. With the polyurethane foam, this is, I guess it's a different application in the sense that, unlike epoxy, the cracks, they don't have to be clean, they don't have to be dry. You can actually apply them if there's water intrusion coming in, but it's just not a structural based sealant. So it just basically seals any sort of cracks, but doesn't provide any structural support.
Right. Yeah, the epoxy stuff's pretty amazing. Okay, additions, visual in the cracks. Let's see here. Sorry, just checking on some of these reading notes as well. Yeah, this is tricky. I mean, what do you're right. I mean, hopefully you can have access is one thing. Like some of these little additions, they're on the crawl space, and that doesn't help. I know from our end of it, we do see lots of house additions, and getting back to the epoxy, it's not actually written in the code, but most reputable contractors will actually drill and epoxy in dowels into a situation like you see on the left. Again, it's nothing you'll be able to see, after the fact. It's nice for us to have it on the drawings, noted on the drawings. You can contact the builder and make sure they're going to do it. And like I say, most reputable guys are conscious of that and will do that. And it can make a big difference. I guess what you might find here, is if you can see along the joint of the house, if this thing did fall away, if you will, or have any movement, it would be assumed to be port tight. You could get a little bit of a wedge shaped crack in here or something. And that would be a big trigger for alarm at that point, right? That would tell you that that this part is settling or what have you and falling apart from the house, or there's movement of any kind, right? So that junction, I think, would be something you'd want to focus on. And and hopefully also you can actually get inside and have a look and see what's going on. From a structural perspective. I am at a little bit of a loss on this right slide. What's the point of that? Do you know, Alex? Or?
Yeah, absolutely, no worries. So I'll just kind of speak on to the image on the right, and I'll kind of add some more notes. So if you notice too, if you look at the image on the right, you'll notice that right kind of where the gutters end, yeah, where the cursor is, thanks, Brad. You'll notice you have a nice long vertical crack. And that again is likely due to an addition that was installed with inadequate footings. So, your footings are meant to actually support the weight of the structure. They're the ones that actually are supposed to be adequately sized, strong enough, deep enough to prevent any sort of movement of any sort of structure, whether it be an addition, a garage, a deck, what have you. So when you start seeing these long vertical cracks inside, possibly outside as well, that is a pretty big red flag. So you will want to let your clients know. You'll want to put it in your report to say that it looks like there may be a possible addition. Recommend to inquire, who did the work? If there are any sort of permits obtained. Some clues as well that may indicate that there's been an addition, because sometimes the exterior cladding may be homogeneous. As you see in this photo, it's all stucco. We don't know when it was applied, but if you're in the basement and the whole area is exposed, you may notice that there's a difference in the sheathing, the subfloor sheathing. So it may go from plywood to OSB. It may be diagonal planks, which we'll talk about here pretty quick. If you're going up the attic space, you notice that you go from rafters to trusses to factory built trusses versus site built trusses. Those may be some additional clues. A lot of times the roof decking will also have a year stamp on it as well that might say 1999 versus 2021, whatever it is. So those are some clues that may kind of help you infer that there was an addition done as well.
Yeah, no, that's good. I had my little window thing covering that crack, but yeah, you make a good point. All of them good points. The roof line changes here too, it looks like, right? So it looks like this is an intersecting gable, I'm thinking. So that's kind of a sign that there's been an addition or something, the roof line. But yeah, cracks, concrete, the drywall on the inside. A little trick, well, just on the side note here, we used to do for, it's kind of off track slightly here, but there was a code change at one point to deal with secondary suites. And, you had to figure out kind of roughly when the suite was built. And windows too, often you'll have a date stamp inside, not even at the newer ones, but probably anything prior to 2000. Usually there's a little date stamp inside if you look around the inside of the frame between the glass panes, there's often a date in there. So, I mean, if those don't align with the main house, if you will, it's just another little indicator there's been a renovation or an addition or what have you to it. But anyways, yeah, no, that's interesting that they restuccoed. Oh yeah, so here's some more uglies.
I'll make one last note as well, guys, with the with additions. Again, unless you're a structural engineer, which I think we have one engineer in the crowd actually today, the vast majority of us are not. So again, you may want to have a clause in your report to say that we don't provide a opinion of any sort of structural adequacy for any developments, any additions, and whatnot. And that way, again, that can kind of cover your butt, unless of course you're a engineer or a red seal framer or a carpenter.
Yeah. So again, more signs of to maybe raise a little bit of concern or something that requires further investigation. Yeah, this looks like that old stucco where they threw the broken glass on. I'm not sure, but anyways, this is sort of telling you there's something been added on to. The finishing here looks just first time I've seen this slide, but this doesn't look the same as this quite, right? Like, and nor does the stucco. I don't think it's as weathered, or just not quite the same. So those are kind of obvious signs that there's been an addition, and it's probably not been done quite up to snuff, or something's failed somewhere. Yeah, this one here is tricky. I mean, yeah, it could be a sign of an issue too, but this could be these tend to be problematic even on a well-built house. But you know, again, it's something, if you see that, you should probably investigate further and to see if there has been an addition, or you know, was it re-stuccoed at some point or something, or somebody renovated and did a crappy job and didn't properly wire this in behind here, you know, because that is a spot that can crack. But yeah, it's definitely all areas of concern. Okay, looks like we're getting into some older homes with some board forms. Just trying to see what's going on here. Older building practices with horizontal forms. Okay, well, I don't know if this is just more of an educational or awareness type of thing, but yeah, it wasn't uncommon for back probably more in the 50s. You'd see this kind of a foundation. We didn't have plywood, or plywood wasn't as readily available. So guess what? They use boards for forms, and then often these boards that get stripped off, and that's going to be your exterior plywood or sheathing. So I don't think it's a thing to be alarmed about. Like, this actually doesn't look too bad, the one on the left. Again, I think it's more of an awareness item, possibly.
You bet, Brad. Yeah, exactly. So again, guys, you might come across foundations that have a horizontal look to them. And like Brad said, it's just the way that they were designed at that specific area in time. And like Brad said, a lot of times they'll actually strip the 1x6s that they use to actually form up the foundation, and they'll use it either for the subfloors or possibly the exterior sheathing. So if you're in a dwelling constructed in this area and you notice this sort of foundation, again, it's nothing to be alarmed about. It's just the practice that they did at that time. And again, if you're observant and if you're lucky enough, you might actually see in the basement, if the ceiling isn't developed, you'll actually see concrete on the subfloor as well. So that's gonna, show you where the building material was reused to save time and cost as well.
It was green before its time. We were recycling. But yeah, just a side note, my old house, I live in Woodley, and I ripped all my siding off years ago. It was half stucco and half wood, and they had boards on the front and back for sheathing, and the side was plywood. So they were just using whatever they had, and I mean, it's fine if it's done right. Okay, yeah, sulfite. So you get into high sulfite soils, it's the enemy of concrete, and I think now anything probably in the last 20 years, I'm hoping the concrete mixtures are such now that they are what we call sulfate resistant. Most concrete suppliers won't sell you anything, but I mean, if they know it's going to be in contact with ground or for foundation stuff as well. Sulfate levels, they vary all over the province. It seems like you get further down towards like Hannah, that part of the world, way higher sulfate. You can actually get your soil tested before you build your house to see what the sulfate levels are. My understanding is Central Alberta is just kind of a borderline, not terrible type situation, but yeah, it can do this. It can just eat away basically. It just kind of is rot, I guess, if you want to call it that, for lack of a better way to describe it. But yeah, it's a concerning thing. If you've once you see it. This one on the left is confusing me a little bit here. Alex, do you know? Because it looks like that's a floor and then something on top of the floor, or?
Yeah, you bet. So basically, this image on the left is like you taken in a basement. So like Brad mentioned, you have that small opening between the two pieces of flooring, and that's like the concrete slab. And where you see the insulation, that's the exterior foundation wall. And this is just an interior image of what sulfide decay looks like. So basically, if depending on your area, your jurisdiction, sorry. So like Brad mentioned, some areas will have more acidic soils that will actually eat away at the foundation. So a lot of times before building a structure, there will be soil tests done just to see how much retardants need to be added to the mix. And again, typically pre-60s, there wasn't a whole lot of engineering done, so they wouldn't add these additives that would reduce or mitigate the decay. So if you're inspecting older dwellings, just be extra vigilant of sulfide decay. So again, typically we'll start at the exterior areas like below the deck or on windows, window wells. You'll notice the crumbling of the actual foundation. That's where you want to take a scratch awl and just kind of pick away at it. And you'll come across areas where you can literally just start peeling the foundation apart by your hand, right? And again, the image on the left is just an interior photo where it shows that actually you can see all that little mountain of foundation that is starting to accumulate right in between the two sections of the fiberglass insulation. And that again is just the foundation wall rotting away. So when you're inspecting these older structures, be extra vigilant of water intrusion, because with the degradation of the foundation wall, the chance of water going inside it is a lot higher. And we're going to see in the exterior portion later this afternoon ways to look for water intrusion, and any sort of signs telltale signs that may indicate that there could be some possible issues inside the house. To repair sulfide decay, I'm sure some of you guys are asking how to do that. It's pretty darn difficult. You're basically talking about excavating around the exterior of the foundation wall, because likely there's no damp proofing that was installed, and we'll talk about these here shortly in a few slides. It all starts with surface mitigation, surface water mitigation. So making sure, the gutters are nice and clean, making sure the downspouts are extended far enough away from the structure. And of course, making sure the grading is sloped away from the structure as well, whether it's, garage or the house. So it all starts with proper surface water mitigation, but then of course, it'll be up to you guys to make sure that there has been no water intrusion inside a dwelling, because, most homeowners, they will run away, because once you start getting water inside structures, you're talking raw decay, mold, a lot of really bad things. So
Yeah, that's a bad one. That's something that's hard to deal with. ICFs. Okay, well, they seem to come and go popularity wise, and my experience has been you see more of these in the rural setting than you do in the municipal setting. Not saying it's that slanted, but I would just sort of guess that maybe you're at the 5 or 10% in a municipal setting. In the country, maybe 20%, 30%. The advantages people think, so a lot of homeowners want to use these systems because they can take a weekend course, or they can figure it out, or they know somebody. You don't have the expense of going out and buying all the the form ply and the forming systems and the ties and all that kind of stuff. So there's an advantage to it, I think, cost wise, and you do end up with not a bad product if it's a good product, if it's done right. It's good thermal value to it, and some people will take these foundations up to their above ground exterior walls. Warm house, very soundproof, very solid. Tough for an inspector to go look at after the fact, because a lot of them are from our end of it, from the building code perspective. Again, in a perfect world, the builder is supposed to identify which system they're using. There's different manufacturers, obviously. Superior, there's ARCs, there's a whole bunch of them. There's probably a dozen people that are making these kinds of forming systems. Usually it'll be a 6-inch concrete wall as opposed to our cast in place 8-inch. Again, not a problem, but they all have requirements for reinforcing. Like we talked about earlier, your conventional cast in place concrete wall 8 inches wide. Code doesn't really want reinforcing, unless it's a window more than 4 feet kind of thing. So yeah, it's very important. Again, not that's going to help you guys out, but the people that are doing the installation are familiar with the reinforcing. There are some generic tables in the code to cover the reinforcing for these, so you can follow those, or the manufacturer's recommendations. And of course, the obvious problems with these are you aren't going to be able to see honeycombs or any voids in the concrete, things like that, because the concrete is visible. The other thing, just kind of winging it here when we're talking, but to pay attention to is if you've got large openings, and more so like garage door, like if somebody goes above the main floor. And I know that's not foundation at that point, but like from our perspectives, there's limitations on what the manufacturer's details will have for reinforcing and use and application of these systems. And once they want to, an owner or builder wants to go beyond those, usually we have to engage some site-specific engineering. So, again, if you do have a question on these or something that's kind of funky, you could always see if there was an engineer's report or anything like that. Uh, these guys on the corner here, yeah, there's some stuff here. So these little octagon anchors, my experience, if this is what I'm thinking it is, these actually, they punch through and they actually, I think they remove, it creates a void in the form so that it's like an octagon box for electrical light, if you want to imagine it that way. But you basically stuff that in there, you remove the foam, and then when they pour the wall, that's actually concrete will wind up in here. So it's a good solid way to provide a good solid connection for your floor system. So that's a good thing when you see stuff like that. There's several different types of anchoring systems, but we get some guys that they'll put an ICF foundation in and it's like, oh, I want to go add a deck onto it. And they haven't had provisions like this in there. So I don't want to speak for all inspectors, but it isn't really great to just bolt a ledger board through that foam into the concrete. I mean, you end up with a hinge point there. They should really be cutting the foam out or doing something to provide a little better connection there. And there are details that most of these guys have. The nice thing is all these systems, if they're, you should be able to go on the internet and find out if you know the product or manufacturer to see if there's anything you need to know that would relate to the particular product. They should all be CCMC approved, but I can't say that they all are. That's another topic. I should look at the notes here before I
Oh, yeah, I'll just jump in here too, give you a sec there, Brad. So again,
Yeah.
when you are inspecting ICS, or if you get a chance to come across them, you'll see some more slides here of actual inspection photos, but you'll notice the image on the left, you actually have both vertical and horizontal reinforcing rebar. Again, you guys won't be able to see this unless, of course, you come across it while they're in the middle of constructing a structure with ICFs. But you also have, again, depending on the manufacturer, it could be plastic webbing, could be metal webbing, whatever they choose. But those webbings not only keep the styrofoam in place, to allow the concrete to have a structural form, but some of them, as you'll see on the image on the right, can actually also allow for the attachment of, say, drywall, because here you already have insulation, and also the styrofoam insulation acts as vapor barrier, so you don't need to put polyethylene sheathing on it. So it kind of provides a nice base for your interior finishes. And we'll talk about notching here as well. And there's a comment here from Gary saying proper vibration needs to happen when pouring the concrete for these systems.
Yep.
While the webbing
That's,
foam. Absolutely. And I think we have an image here coming up. You probably saw this last time, Gary, just with actual adding of the concrete. And we don't have any images of any blowouts, but I hear it's a good time when that happens.
yeah, so yeah, if you go back to the manufacturers, the proprietary directions, whatever you want to call it, the CCMC evaluation, they will, like the point about vibration was good. They talk about, like 1 meter lifts. Like, don't just sit there and fill that thing right to the top. Like, you should go, or whatever the manufacturer suggests. But usually it's a 3-foot lift. And yeah, you got to vibrate it because there's a lot of crap inside your form now with all these webs and rebar and everything. So you want to get that concrete going. Sometimes they'll specify a smaller aggregate, like usually like the conventional, we're using a 3/4 rock in there. They might go to a, more 10 M, depending on the manufacturer. But yeah, they're a little trickier for sure. Nice product, I think, if it's done right. And of course, I mean, we'll get into it, or you'll get into it, but I mean, there's always the issues with the interior finishing with the, having to router in for your plugs and things like that. But so, yeah, so here we go. Here's an example. So yeah, that's a pencil vibrator, you would call that. These guys look like they've got a pretty nice setup here. It's interesting when you see these guys set up to pour these too. The forming systems have come a long ways. They've got some pretty sophisticated ways to set up bracing, because it's always tricky on these things, because you have all these Lego blocks essentially, and they're usually only like 16 inches high or what have you. And so to keep those things straight until you get the concrete poured. So they've got wall bracings, temporary wall bracing systems that incorporate scaffolding on them and such, so you can walk around and do your work. And don't want to get maybe ahead of myself, but just kind of blurting stuff out as we go through. But another thing here is the anchoring of the floor system, and usually anchor bolts, and they'll put like an LVL plate on top or something like that. Not a really a foundation thing, but they are a little bit special as opposed to the conventional cast in place concrete systems. So then it looks like we're getting into some damp proofing, I'm thinking. So this is like a Dimplex or product like that. It's a high quality damp proofing system. I don't know, maybe the point of the slide. Usually what I see is a membrane type damp proofing, like Blue Skin is just one manufacturer, but a lot of the block people that sell the ICF systems will have a damp proofing product that they'll sell as well. But it's like a peel and stick, a membrane rubberized peel and stick membrane. Should be installed according to the manufacturer specs, which should be up and down usually, but you'll see every once in a while someone will put the thing on sideways. I don't know what the big issue would be, but it's just something you see.
As Brad mentioned, guys, depending on your area, a lot of times that these are used in rural settings where it may be harder to for whatever reason. I'm not going to speculate why they use ICFs, but a lot of times it is DIY stuff. So you may want to pack around a 2-foot level, 3 foot level, and that way you can actually check for any sort of deflections in the walls, because in the image on the left, they're not using any interior bracing for the foundation wall for the ICF, right? So I mean, there's a chance that it actually may settle inwards. So that's why you want to pack around that level should you choose to. But I'd strongly recommend you do. And like Brad mentioned, some manufacturers of ICF forms, they will require a special type of damp proofing, and you guys won't be able to know it generally. Sometimes you'll actually see a label. I think we have an image on the next slide or so that actually shows the manufacturer's details, if you will. And a lot of times you won't be able to know what the damp proofing material is. But again, as we've kind of alluded to last couple days, the more you start spending time seeing what is being used around your area, the more versed you will become to see what the requirements are from the manufacturers. And the image on the right just basically talks about the lack of protection to the actual styrofoam. So usually there's a time frame that the manufacturers will allow that to be exposed to the elements, but over time, you can get mechanical damage, people damaging the styrofoam, or you can get degradation from the UV rays. So just kind of be mindful of that. ICFs are great foundation styles, just because you have they start from both inside and outside of the actual form, and that will actually allow the concrete to hydrate, meaning cure for longer than your typical poured in place foundation with your forms. So the longer the water stays in the actual form, the stronger of the bond, and the harder the material will be, despite using less of it.
Yeah, no, that's great. My screen isn't that very detailed here. I couldn't make out these are actual ICF blocks that are exposed. So yeah, there's the same thing. You go back to the manufacturer's specs, and they usually give you a time frame of, I forget, whatever, maybe 6 months max, 3 months or something. And UV is hard on these things too, the sun. But that being said, you drive around some of these do-it-yourself projects out in the country, and they sit there for 5 years and seem to be not falling down. But I see metal going over here. Sometimes they'll do an acrylic stucco or parging on top of here. There's a couple builders around Red Deer that have a nice little setup here where they don't usually get too far out of the ground with their ICF foundations, and then they'll clad this with a metal strip, that junction. Usually they won't use this type of damp proofing. They'll use the membrane type because it's a little easier to tie into. And then, and then their siding or whatever cladding would come on top of that. Again, works pretty good. Maybe one other little thing just blurred out here is, these are 6-inch concrete walls. So, and if it's all done to code and proper, you got to be careful in the backfill heights. Usually these things are no problem, 8 foot, maybe even 9 feet possibly, but you could get some homes where you may want to scratch your head, take a look, and not to be alarmist or create an issue that might not exist, but they do have these blocks. They do come in an 8-inch concrete setup as well. And those are for higher backfill heights and things like that. So you might get on a sloping site or something, or a walkout, and it just maybe raise an eyebrow if you go in, you got a 9-foot basement, and you'd have to go to a window or something like that pretty much to tell how thick that wall is. It's kind of tricky, but just some food for thought. Okay, so we're getting the, water lines. Anything you do with these ICF on the inside, I guess that's the drawback, is trying to finish that basement or that inside wall, and everything has to be routed in. I don't know what, is this just more of an information piece? I'm not sure, Alex, what the,
Yeah, you bet. So the image on the right, guys, just shows you an interior photo, in a basement or a crawl space, either one of what these are. A couple items here to know. Typically, those little black vertical lines you see indicate where the actual webbing is. Sorry. So if you guys recall, you had those little plastic webs or wedges, if you will. Again, that's a bit of a placement marker for interior finishing. And with any sort of styrofoam, I think we're going to talk about this in the building science portion. You want to make sure that styrofoam insulation is also covered on the interior, not from the UV rays, of course, but mechanical damage. And of course, if there was a fire in the structure, the dwelling, if that styrofoam catches fire, it will make a pretty toxic fume that will knock everybody out pretty darn quick. So if you see the exposed styrofoam insulation, just recommend that it be covered up, sooner than later.
yeah, well, it is a code requirement. We have to thermally protect all foam plastics in a house, whether it be spray foam or the ICF. And yeah, I think that's enforced pretty well, or at least identified, like it might end up being a deficiency, and a little tougher with the homeowners to try to, people run out of money or whatever. So we wouldn't ask for it in a crawl space. So a crawl space isn't, crawl spaces and attics, you don't have to thermally protect it, but if it's a basement, yeah, by all means. The other one that's debated a little more is if you put a mechanical, like a furnace down here, because now it's technically not a crawl space, it becomes a big mechanical room. And most places will either have the mechanical room isolated, or they will thermally protect this. It doesn't have to be drywall, like in a crawl space. You can actually thermal protect this stuff with plywood. I mean, there's a few options in the code. Drywall, seems to be pretty cheap, but depending on the market and the cost of materials, you might find somebody's got a crawl space with a furnace in it, and they just went and shot plywood around the outside. Even OSB, you can put OSB over this. So back when OSB was $8 a sheet, yeah, you might come across that, and which is fine. It's not a problem.
And maybe we'll just speak about the flooring system here. So if you recall from the previous slide where we had the, that hanger that was actually incorporated into the form. Yeah, just one more slide. We don't really need to go back, but yeah, the image on the right there, right? So you can see that they have the joists basically installed vertically, I guess, into the form. And if you just go forward 2 slides there, the image on the right, it almost looks like the joists are actually resting on top of the foundation, likely on a sill. So again, just different manufacturers will have different systems for the flooring. So again, just be aware that there are different styles out there, as we have different technologies.
So this one here is odd. I don't think they detailed this very well, because why would you do this if you're going to put a sill plate? But that looks like rebar to me. So you'd see this more if it's going to be an above grade and they're carrying this concrete up to the underside of the rafters or up to the second floor. So this is when you see this ledger thing more often, is when the foundation extends above the floor, because it would be just more easier to go on top, right? Like this one here, like Alex said, this is what I see all the time. If it's just a foundation, makes sense.
You may come across ICFs, from footings to the trusses, right? So just be aware of that.
Oh, joy. Okay. Well, yeah, I don't think I've ever seen a cinder block foundation in my goings around the last 20 years, but they're still allowed by code. Their code still references, has parameters for putting them together. Because I haven't seen them, I probably don't know much about what the code would require, but I'm sure, the fact is that they were allowed and were used. You guys probably come across them. I don't know if I have pearls of wisdom on this one, Alex, a whole bunch.
Yeah, no worries. I think this is more alluding to concrete block foundations. So, I guess the novice inspectors, or possibly the unaware inspectors, may call these, cinder blocks. You can use cinder blocks above grade, but you actually can't use cinder blocks below grade. Typically, they're much smaller blocks than your concrete blocks. They incorporate fly ash. They're typically lighter in color as well. But going back to concrete block foundations, just be extra vigilant. We're kind of getting into the nasty foundations here in the next few slides. I would say concrete blocks start at the top of that list. All these mortar points, all these little connections between the blocks, these are water intrusion points. So, you may want to let your clients know, the potential buyer know, that they have to be extra vigilant when, if they're looking at buying a home with concrete block foundations, just because, again, the chance of water intrusion is that much higher, because you have a lot more surface area for any sort of water intrusion through these cracks. So again, it all starts with properly, clean gutters, good downspouts, and surface water mitigation through grading. So, and of course, damp proofing is definitely required for this as well. In older installations, typically commercial, but you will come across it in residential settings as well. Again, this is 60s and earlier. If you have any areas of exposed concrete blocks where, maybe they're punching a hole for exhaust systems or what have you, you may come across vermiculite insulation, which we'll talk about here, I think tomorrow. But again, it's possibly a hazardous substance that may have been used to, increase the R value of the foundation.
Yeah, Zonalite was a product. Like, I do have a little more experience with above grade, like with firewalls and some commercial projects where they would use not the concrete blocks, but perhaps cinder blocks for the firewall type application. But yeah, that vermiculite, it's almost, or Zonalite, or whatever the percentage of it having asbestos is, something like usually about 80% of the time you test it, it's got asbestos in it. But yeah, not my favorite foundation. But
you'll notice as well, right? If you go just back one slide, thanks, Brad. You'll actually see, well, you won't see, but in this image, you can see they have rebar sticking out through the tops of the blocks vertically. So again, I don't actually know if it's required by code. I think it's really good building practice that they've installed for additional reinforcement.
yeah, like I say, it's not something we see, so I'm not really well versed on it, but I do know just from my past experience, often from the engineer design and above freight. Like, I used to do a lot of schools and things, and they would still do, like, in the hallways and stuff. And so we'd have things like bond beams, above the openings, and often the top one, they would use a different type of block up here. So this is what they call this, running bond, as opposed to stack bond. This is when the blocks are offset from the top to the bottom, but you can actually see them all line up the same. And there's different configurations. Usually there's some wire reinforcing that goes course to course in these. It's just not a very heavy gauge, but it's actually shaped like the block. So if the block is 8 inches, the wires are, like 7.5. And there's little grooves in these blocks that they do provide some horizontal reinforcing. It's kind of light duty, from my opinion, but I mean, I'm not really up on this, other than I do know, like, usually they'll fill these cores around the windows. Usually the top one gets what we call a bond beam, that's going to carry the load of the house. And then it transfers that load from the house, throughout these blocks, because these may or may not be solid filled. I'm not 100% on this, but I have some experience with the above grade ones. But yeah, they're a little tricky, and probably, you might want to pay a little better attention for sure. Okay, yeah, well, there's some good examples. This is some horizontal earth pressure on here, which is, I think that would be pretty obvious. So we talked about the horizontal cracks in the cast in place foundations. Well, yeah, your slab's holding it here, your floor is holding it here. There likely isn't reinforcing or adequate reinforcing throughout the vertical span of this block, and you've got a problem. Same thing over here. Looks like we've got some earth pressure on this wall as well. These are fairly obvious things that you would hope most anybody could figure this one out, that it's a problem. But yeah, these are concerns.
Like ICS, it is quite common to find concrete block foundations in rural settings, in case concrete was difficult to reach. You may also find them in older structures as well. So I wouldn't, it's pretty hard to give a date when these units were used, because they are still common as well in current construction.
Well, I haven't seen any, Alex, for a long time, but the ICS have definitely the market share in the do-it-yourself market, but it's an option for sure. Yeah, you might come across it. I would think, like anything that's kind of like this, if I was a do-it-yourself guy, and some of the ICFs usually like houses with crawl spaces, not very big backfill heights. So you've only got a 4-foot wall. Hopefully that's what you're seeing. People aren't trying to do these kind of projects with 8 or 9 foot basements, but yeah, it could be out there. Okay, so this is just some concerns, I guess, that you may come across with the block. So yeah, something's moving along here. Obviously, there's cracks throughout this, so that's not a good sign. Uh, Doesn't look like there's deflection per se in here. Hard to tell from the drawing. Looks more like a crack thing, and whether it's just maybe these were done. Temperature is another thing, if it's these like with any foundation involving any concrete or any cementitious type project. I mean, if it's winter construction or getting into any kind of cold weather and it's not properly ordered and heated, I mean, it weakens the ability for the concrete to cure. Can be quite problematic. I'm not saying that's the problem here, but it does seem to correlate with problems. I know from being in the construction world and having to go back and warranty things and stuff like that. Lots of times it was some bad hoarding or winter construction or some problem like that. Yeah, this one here, I don't know, but again, it's something to be concerned about for sure. This is actually split a block, so that's telling you there's some stress, right? This isn't the normal joint in the concrete block here. So something's going on here and it's not good. So there's some pressure has decided this is the weak point in the wall and is pushing on it. So it's likely to get worse, or it's something that needs attention, I think.
Yeah, we'll just look at the image on the left. So about halfway down the image, guys, so there's actually quite a few things going on in these images. So the image on the left, you'll actually notice in the top left corner, you actually have a step crack going on, a pretty big one, where the mortar is actually split, probably maybe even an eighth of an inch of a gap. So step cracks generally indicate settling, right? If you have really small, cracks in the mortar joints, fairly common. You still want to, point them out in your inspection report. You still want to recommend they be sealed because again, it's just opening up already a water intrusion point. And then still on that image on the left, if you actually look 3 blocks down from the top, you'll actually notice you have a pretty big gap. So that's actually a horizontal crack that is, running across the foundation wall. So I mean, that again is lateral forces. It could be from a lot of things. It's likely from hydrostatic pressure from the soil. So possibly they didn't do any sort of damp proofing, and now in the wintertime, maybe the soil froze and actually started push laterally into the foundation, and it is causing it to buckle. And then the image on the right, like Brad said, when you actually see cracks through the blocks, that's pretty significant because that takes quite a bit of pressure. And again, you can see bottom left of that image on the right, you can see efflorescence, so that white chalky substance we're going to talk about here pretty quick. And then above that area, you actually can see, looks like seepage possibly or active moisture. So, a lot of issues going on here. And again, that's why you want to be extra vigilant for your inspections when you're seeing concrete block foundations, just because they're, in my opinion, they're an inferior compared to your cast in place foundations poured concrete.
Yeah, it's interesting, the step cracks, like you say. I always kind of, just my thing, you drive around some old main streets in a lot of towns and you see brick facades or brick buildings, and you'll see some, anywhere Red Deer's got them, you can go and you'll see some step cracks in the brick, and that's a pretty good sign that that one corner of that building is starting to drop or whatever. And it might not be much, right? But I mean, you've got a rigid facade on there. It's not flexible in any way, and it doesn't take much to cause that to happen. But it is it's definitely a sign of concern. Yeah, well, yeah, that's a failure, I would say. Something's not very happy over here. I think that should be fairly obvious that there's something's moving or shifted, or maybe this lower below, I don't know if this is a full basement or not, or what have you, if this wall is moving in and the top is now moving out, or there's force on here and that's not, the building isn't taking it. Not going very well. Another one, yeah, these horizontal ones and then moisture on top of it, whether it's just something with the damp proofing not being correct or what have you, or if there's a bit of a movement there that's caused this crack, right? Like maybe it was, the damp proofing was installed or what have you, but now that the block wall is moved, it may have cracked the damp proofing or caused a tear or ripped it or what have you, or who knows what, but it's not a good thing.
Like the cracks we discussed earlier today, guys, the horizontal, diagonal, and vertical for your solid concrete foundation walls. When you start to see cracks like this in the masonry block, the concrete block foundations, that's when you want to start pulling out the structural engineer card as well. So again, small step cracks, not a massive concern. You still want to point them out, but when you start to see that 1/8 of an inch gaps in the cracks, whether it's step, horizontal, or any sort of vertical cracks, you want to start, saying that you recommend further analysis by a structural engineer. And of course, if you see something like the image on the left where you see the massive cracks, likely on the interior you have a complete failure of a footing or the foundation wall. So again, that's a pretty big red flag you want to be aware of.
Yeah. Ooh, okay. Where was that engineer's card? You need to pull that out again, I think. But what is this, stone foundations? Oh, wow. Now we're getting back there. Well, I can guarantee you I haven't seen any of these. Not in new construction anyways, but we do come across the odd house that's been added onto or renovated, or someone's trying to determine whether or not it's worth fixing up. But I don't have a lot of comments on the stone foundations. I mean, I don't see a bunch, like I say. You're gonna have to help me out, Alex. I
Yeah,
don't
no
know
worries,
what
I'll
to tell
jump
you.
in. So basically, guys, if you come across stone foundations or rubble rock foundations, as they're also known as, pretty big concern. So I would say this is probably the least desirable foundation you can have out there. Like Brad mentioned, typically these are pre-1930s. Again, depending on your area, right? They may have been used sooner or later than that date. A lot of times there was absolutely no damp proofing done, and again, we'll talk about this method here pretty darn quick. But no footings generally, so a lot of shifting with the structure, with the foundation. So some telltale signs would be if you're on the exterior portion of the dwelling or the structure, if you notice a lot of cracks in windows and even newer windows, that may indicate that the structure is shifting. So you're seeing these cracks, doors not opening, windows not opening, or just really difficult to open and close. If you notice the chimneys are leaning, again, that is likely an indication of significant movement in the foundation. As you see in the image on the left, they got a bunch of spray foam where they're trying to stop the moisture intrusion. A lot of times in these structures, you won't have a completed basement because it's basically a money pit, because you're gonna have so much water coming in. A lot of times you can actually literally start taking apart the foundation by hand, just because it's, the mortar is basically 100 years old, if not older, then it's just completely deteriorating. So again, if you see these sort of foundations, you want to be extra vigilant for any sort of water intrusion, failure of the actual foundation wall. Again, you may want to recommend an engineer look into it further if you see any, significant signs of your foundation deterioration or any sort of deflection where you can see the actual walls are moving. Yeah, I think that's basically it. A lot of times, like I said, people will call them rubble rock foundations just because they were built just from rocks that were found in fields and rivers and whatnot. They were just kind of slapped together with some mortar. Obviously very primitive foundation, so no retarders for any of the soil conditions that may exist in the area where the structure was built.
Okay. PWF, permanent wood foundations. Yeah, okay. Well, these are out there and about, and not heavy, super prevalent, but again, more of a rural thing. Like Alex alluded to earlier, might be difficulties with cost to get concrete into some areas and things like that. I did some worked on a school up in northern Alberta for 1.5 years. We were doing the school, and there's another company up there. That's what they did. They were building houses for the Aboriginal population, and all wood foundations, and just kind of interesting. It was a remote location, and the concrete was hard to come by and things like that, materials. So I don't think these are, in my opinion, necessarily a problem, but if they're done right. So like from our end of it, if somebody comes in and wants to build PWF foundation, there's a couple options. There's a CSA standard. I don't have the exact number on top of my tongue. And if they were to come in and indicate that they're going to follow that standard to the letter, and we had some confidence that they knew what they were doing, they can certainly do that. The other way to go is it'd be an engineer's design. And it can be an engineer's design, and the inspector on our end can come out and have a look at it, confirm it was built, if it's fairly simple, and or have an engineer's design and a sign-off letter. A lot of municipalities will want that, and it's kind of a liability thing, if you will. So So, I mean, if I'm in your world, if I see one of these foundations, you may want to see, this is just my thought, if the owner has a copy or any evidence of an engineer's report for the foundation. That is kind of nice to have. It gives you a level of confidence that, yeah, A, it was designed correctly and there was some sort of field review done. Not to say there can't be problems like anything, right? Like, I mean, everybody's human and things happen and there's other factors in the world, but there's quite a bit of stuff here. Like we have to look at, it's a lot more intensive when than doing a cast in place concrete foundation. I mean, it's the nailing patterns, the size and spacing of the studs. There's the the dam proofing requirements, blocking between the joints. You have to have all the joints blocked. There's special requirements for bracing on, like you have an interior corner here. You're supposed to put straps. I forget what they are. I'd have to look it up. But I think every 12 inches, galvanized straps horizontally up this inside corner because it's going to experience more pressure than an outside corner, if you can imagine. This is quite strong, an outside corner. Try to push that in, pretty tough. You got both walls working for you. Inside corner, not so strong. So there's that standard has a lot of detail in it. Might be a worthwhile. I don't know if you come across a lot of them. I don't think it's big money to buy it, but again, if the basement's finished and everything, and you can't see anything, it makes it pretty tough. But they're, I think they're not a bad foundation. If done right, it's like anything, I suppose. So a little bit going on here. I don't know what.
Yeah, I'll just jump in here, Brad. So
Yeah.
again, guys, so the last three foundations we discussed are more prone to problems, if you will. So again, in my opinion, you have the rubble rock foundation will be at the bottom. You have your concrete block foundation, which would be above it, and the PWFs. And like Brad alluded to, when done properly, they are a great foundation. I believe these were actually experimented and designed by the Canadian military in the 50s and 60s for typically the northern climates, where, and again, you have a much reduced season for building foundations. So a lot of times you won't actually know that there's a wood foundation. Well, I should say the sellers may not know. I know I did an inspection, I think a couple of weeks ago, where the house has been listed and sold multiple times, and I came across the structure and I knew pretty darn quick that it was a PWF. And I'll speak to those clues here in a few moments. But a few other items, like Brad said, you want to, if you come across a structure that you feel is a PWF, you want to inform your client, the potential buyer, that you have inclinations that it's a PWF, because a lot of mortgage providers, usually the B lenders, if you will, not the big banks, but the B lenders may not even provide a mortgage for PWFs, just because they can be problematic. Some insurance providers may not provide insurance for PWFs. As I mentioned to you as well, it's typically cheaper and quicker to build PWFs. So if you were to have identical houses, same block, on the same block, I should say, sorry, that were built, one with a solid foundation wall, one with a PWF. The PWF is generally a lot cheaper. Again, depending on your area, I don't want to start spending numbers, but it could be tens of thousands of dollars. Again, I did a house couple months ago. It was $1 million plus home, which is very expensive in my area, and the addition was all PWF, and of course nobody knew about it. So both my clients ended up walking away from both homes just because they're PWFs. When built, they're very nice. They typically have a much more balanced climate in the basement. The wood actually is a bit better, reducing the thermal bridge from the outside to the inside. They're often usually drier as well. So when built properly, they're really, really nice, but a lot of times they're not. So now I'll just kind of speak to some clues that may allude to the fact that there is a PWF for the structure. It all starts with the exterior, guys. So image on the right, you'll actually see some of that pressure treated plywood, the sheathing. Don't assume that if you see that it is a PWF, because this may be a border that was installed for, say, a flower bed, but this is typically a good red flag. If you're underneath the deck as well, if you see parging all the way around and the weather permits, the season permits, you may want to dig down a couple inches just to see whether it's wood foundation or possibly solid concrete. Some guys, and I've actually used this as well, you can actually tap the foundation, not the wall structure above grade, but if you're able to actually tap around below the area below the actual the floor joist, if you kind of feel that hollow sound, that often indicates it may be a PWF. On the inside, if you're doing your interior inspection or even the exterior, but primarily the interior, if you're doing your inspection and you just notice that everything is drywalled up, I'm talking around the panel board, the mechanical room, below the stairs, that is usually a good indication as well that it may be a PWF, that the sellers came across a renovation project and then they found out, oh my goodness, we have a wood foundation. A lot of people actually go to the extent to cover it, just because, again, usually your value of the structure will decrease significantly. So people try to mask it. Another sign, like I said, if it's not covered up, sometimes you'll be able to see the foundation around the panel board, the electrical panel. If you really want to go that far, you can actually take off the receptacle cover plates, and you may see as well down the line that it is a PWF. And like Brad said, the municipality may have records of it as well. So
Yeah, oh, that all makes sense. Yeah, okay, we'll carry on. No, I haven't seen one of these for a long time. Sometimes if there's an addition and the house has a PWF, they might just do the addition with the PWF. And that's usually because the owner has been happy with what they've got and they want to keep everything the same. Or the odd time, a couple, not very often, maybe like something with a crawl space addition, low backfill heights. And, so they say, okay, we're going to do a 4-foot PWF, and those are probably less of a concern, but yeah, not a real popular foundation system. Interestingly though, like if just years ago around that Hannah area, there used to be some builder down there, and that's all he did. And his big claim to fame was that because they had such high sulfate down there, he was outlasting the concrete ones. But I think they've got their concrete mixes figured out. Okay, yeah, this is the incision of the wood. Yeah, you need this. That's a good thing to pay attention to. And there is it's a 04322 standard or something. The CSA should be stamped, but when you see the wood incised, that is actually pressure treated wood as to I don't know, like your deck boards, which are kind of weather resistant, So you can have a couple 2x4s, one that's nice and smooth and green, and this one here that's been incised, and this would be the indicator that this one is actually approved for use for foundations. So this is good information too. I mean, if you were to go into a basement and a pressure, I'm assuming what we're talking about, but a flag would be, say you have a house and it doesn't have a finished basement, or it's a crawl space and you go in there and it looks like, oh, they use treated lumber, and you look at it and it's like, it's not incised. And doesn't have that CSA for 432 or 4. Anyways, the CSA stamp on it. That would be a big flag that somebody's just gone to the hardware store, bought deck boards, and that's not doesn't meet the standard, or doesn't meet the code, any of that stuff. So I think they're showing us here that that being incised, they actually kind of pressure when they put the treatment material on there, that it's actually pressure forced into these incisions, which is going to give it a far better longevity than something that's just been field coated. You open up a lift of these guys when they've got the incisions in them, and it's almost dripping, oozing the treatment chemical coming out of it. So just a good thing to know.
I'll make a couple of notes just for the incised lumber. So a lot of folks, whether it's a PWF or a deck construction, they say it's pressure treated, it's good to go. So they'll build whatever structure they're building. However, as soon as you cut into that piece of lumber, it is no longer, completely intact structural member or decking, whatever it is. Anytime you cut into this lumber, it actually must be treated after the fact as well. Right. So, I mean, obviously, when they're building the foundation, you guys likely will not be able to know if the corners or if the seams were actually treated. So just something to be aware of. Also with PWF foundations and footings, footings, my apologies. They may be concrete, they may be wood as well. Again, you likely won't see that, but just be aware that it could be one or the other. It could be wood or concrete for the actual footings for the structure.
Yeah, the standard, the CSA standard, has a provision in there for a wood sleeper foundation. Again, I don't know if anybody would bother to go that route or not, but it's like a compacted gravel with a 2x10 or 12 or something plate sitting on the gravel. It's really not a great system. And while we're on that topic, again, getting back to the standard, just as a side note here, I'm just remembering things as we're talking, but when you follow the CSA standard, when it comes to the drainage, perimeter drainage around the PWF foundation, the standard actually doesn't allow weeping tile and rock. And so you're actually supposed to put drain tubes through the footing, I think every 2 feet, like a fairly good sized tube, a 2-inch tube through the footing into the basement under the slab, and then carry on with coarse rock under the slab and actually slope the under slab base to a corner or to a sump location. So it's a little more work if you were to follow the standard. So you have all these drain tubes, you got your coarse rock. You can have a membrane, and or they do make trowel on or roll on materials for the damp proofing, which you have to look into, make sure they're approved for that use. But if you, if you see weeping tile or signs of weeping tile on a PWF foundation, that might be a flag that, somebody did it themselves. They didn't follow the standard. If you do see that, though, not to say it's totally wrong to use the weeping tile, because a lot of engineers will still want that tile. So if you have an engineered design PWF foundation, the engineer may spec that, but it's not what the standard would require. So it's just, I don't know, just some info. They're a funky thing. I'm assuming this is at the bottom of a wall, possibly, where we've got some rot in here. Again, I never know if I'm looking up, down, sideways, or if this is a stud. Because if it's a stud, it doesn't look like it's incised. But yeah, I mean, if you get into opening up a wall, well, it's insulation, so we're on the outside of the building, possibly, I guess, and this would be maybe a connection near the floor where, yeah, there's signs of rot in here, possibly not the right materials being used. Another thing, if you do have an exposed basement, another flag would be if they're drilling holes in these. The standard prohibits you have to run all your wiring from the top down. So you can't do like a conventional frost wall in a house where you have a concrete foundation and you put a 2x4 wall inside of that and then drill a bunch of holes for your wiring or what have you. Not supposed to be drilling in here. And if you see hole anchor bolts or whatever, something like that too, that's a no-no. They don't want holes in any of that kind of stuff. It's one thing to cut some material around a window or something and then field treat that, but the standard doesn't want you putting any holes in any of the treated materials below grade. So I think this is just I'm guessing, Alex, this is just a sign of we've got problems because there's rot and
it's just a slide to depict that even though it's pressure treated, as you can see, pressure treated will rot, or can rot, I should say. So just be extra vigilant. And I think we'll see a slide here. And actually the next slide is likely lots of moisture intrusion. So yeah. So I guess with this slide again, if possible, and again, it's kind of your discretion for this next little topic here, but if you're noticing water intrusion, if you're using a moisture meter, a pinned or pinless moisture meter, if you're probing the actual studs, if you're seeing elevated moisture levels, or if you're seeing a sort of moisture on the polyethylene sheathing on the inside or the outside, regardless, you may want to pull it up and see what's going on. Of course, if you do that, it's up to you. You may want to inquire or get consent from the seller for that to happen. But this was an image submitted from another inspector. He actually did get consent from the seller to do this. The seller was, I think, around. So he was able to open up, and you can see, excessive moisture that was found. I like that the inspector also packs around a stapler, because if you're going to be popping things open, you may want to just make sure you actually can reset them back to where they were. But as you can see, right, the exterior clues may have alluded to the fact that there can be issues inside. So say the downswells weren't extended away, maybe they had really poor surface drainage going towards this particular wall. But good on this inspector to find this issue, because obviously this can cause rot and mold down the road if it hasn't already.
These work really good out on an acreage or out in the country, up on a nice big hill somewhere, and lots of drainage. Yeah, otherwise you can get this kind of thing. Oh yeah, well, should speak for itself, I think, right? Obviously something's failed. This is framed wrong, I can tell you that, according to the standard as well, just quick and dirty looking at it. Because you have to treat these walls basically like floors, because they are expected to take pressure like a floor does, but now it's earth pressure. So usually there's requirements to double up full height continuous studs on the sides of these windows. Again, if you go into that standard, it's much like a little code book. Well, it is. And then often, depending on the width of the window and the height of the backfill and size of the studs, you may have to double up these sill plates in here as well and build essentially a little horizontal header under these windows. So I'm looking at this saying this obviously wasn't done, and this is the result. So maybe I don't know the history here. Maybe this was cut after the fact, but these would have been continuous studs. That's a fact. 1, 2, maybe 3 on both sides. And then often there's a requirement to put a hanger in here like you would a floor joist. Just as you can imagine, to resist if you have a floor. But now you're trying to keep the, the earth pressure from pushing it away. So yeah, there's lots of little, well, I shouldn't say little, but lots of things to pay attention to on these. So this, I think this is failed construction here, and somebody did something wrong. I don't think an engineer would detail that. And I know the standard wouldn't permit this type of build either. So kind of speaks for itself, I think, but
Yeah, in this image, guys, I mean, you obviously don't need a level, but again, this is why it's really good practice to pack around a 2 or 3 foot level for these interior walls. I've definitely come across PWF. So again, nobody knew what it was that they were. Maybe the sellers did, but the drywall was significantly leaning or deflecting in the basement. So again, just really consider packing that 2 or 3 foot level for situations like this, because the potential buyer may want to know what the actual deflection amount is, and you can tell them, 1/2 inch per foot or whatever it is, or inch per foot.
okay. Oh, okay, slab on grade foundations. Well, yeah, you might see these on, my experience is these are usually for accessory buildings more so than a house. But that being said, you could work something like this into the program for an addition or something like that if if you thought it was due to financial concerns and having to excavate and all this other kind of stuff. I can tell you, like from the inspection side of things, we don't allow this on a house unless it's engineered. And I can guarantee you every inspector is going to call that the same way. Even on accessory buildings, most municipalities were going with a slab on grade up to about 720 feet. I mean, there's maybe a little bit of flexibility depending what municipality you're in, but if you get much bigger than that, the rule is to have an engineer design, and almost always involves some form of insulation around it, like the skirt insulation. Usually more than this. Yeah, okay, that makes sense. I was going to say at least 2 feet. 2 feet, 3 feet, sometimes 4 feet around here. And that's more to keep the frost from impacting, getting underneath this surface foundation, we call it as well, slab on grade. It's not below frost, right? So kind of the rule of thumb code wise, if it's a house, your foundation should be below frost. So in Alberta, that's typically 4 feet below frost. If you're not doing that, you need to have an engineer's design. But there are, I find this interesting, this moisture control. Never see this. I've never seen this detail here. So I don't know where that came from. That's interesting. I'm not saying it's a good or bad thing, but I don't know how this would work in Alberta. Just that it's not protected from frost. So if you do have, in the spring or fall conditions, it's going to freeze off. I don't know that it's going to do much for you. We're really big on having the weeping tile and rock when it's against living space, like if you have a crawl space or a basement. But when there's dirt over here and dirt over here, I don't usually see this around, or I don't know of any. I haven't seen any engineers design asking for this or anything. This all the time, insulation, some form of it. And of course, Alex has mentioned this a few times, like proper drainage is probably your biggest friend than anything. Like if we can keep the moisture from getting here. Not sure if you're going to go dig around something and you didn't find this, I really wouldn't be concerned. If you didn't see some insulation, that would be a concern. Something that happens though, we get, as inspectors, we'll get drawings come in and they'll show all this styrofoam and everything, and then nobody phones in for an inspection, and the inspector goes out and you see some insulation maybe out here poking up 3 or 4 inches above this surface foundation. And you think, okay, and I hate to say it, but I think there's people out there that aren't putting this horizontal insulation in. And that would be a bit of a concern. So I don't know. I often thought, if I was doing your job and somebody had a surface foundation, well, on a house, It wouldn't hurt to maybe dig down around the outside here to see what's going on, but just some thoughts.
Yeah, you bet. And you guys will notice too that, the edge is thickened, right? And that's just
Yeah,
provide additional structural support. And like Brad said, depending on your area, I know Alberta, they don't allow that insulating of that thickened edge, and that's just to prevent the freeze thaw cycles from moving and shifting the building. So you actually will have a lot of heat loss in this area, and that's actually designed again to mitigate the freezing. So, and of course, the insulation in the other portions will help to retain that heat loss, just again to prevent any sort of shifting of the structure.
yeah, and this isn't a bad detail how they've done this, because you don't want to have a jog here with the wall, but so just side note thing here or whatever. I mean, if it's 2 inches, you still have 3.5 inches of wall. So essentially a 2x4, like I'm just talking structurally now. So this would probably be okay if you've got a roof on here or whatever, but I don't know if I'd go up 2 stories off this, but I don't think you're going to see that. We've got some big buildings like in the county. I mean, if you go to, well, it's not a secret or anything. Back when I worked with the county, we got that Cayman landscaping out on the way to the dump. That whole shop is built on a slab on grade foundation, all engineered design with a ton of insulation around the perimeter, and and that's acceptable. Like, I mean, if we have that professional design in place, they can do it. And so I see it more though in kind of industrial or commercial or accessory type buildings. Not too many people, doing this with their houses, you would hope. Okay, so we've got, I'm guessing these are probably concrete piles, or they could be piles and piers. I better look at the notes. So assuming these are piles, this would, in Alberta, we would have to have an engineer's design for this type of foundation for a house. Again, some municipalities, if you're going to put a little porch on your house or something, like, a little roof over your steps, or, I don't want to talk out of turn here, but may allow, they might have their local soil conditions have shown that, a 10 or 12 inch pile down 6 feet is going to hold up a, an 8x8 deck or what have you. So you'll have stuff like that. But if it's going to be a building, a permanent structure, a house, or anything that's, of any size, this would require an engineer's design. And again, it's going to be based on soil conditions, which will vary, frost depths, frost action. If you got a high expansive clay, that could be a factor because it'll actually push the piles up. Sandy soils will give you different bearing capacity. It looks like an awful lot of piles, and they look awful big. So I don't know what's going on here, but I think it's going to do the job. Just a rough, dirty look at it. But yeah, again, I don't know what to tell you from your guys' perspective. You don't know what's going on, right? Like, I mean, or there's lots, it's pretty common now for houses to do their additions. When they're excavating for a house foundation, they'll go wider. They got the equipment there. It's not a big deal. And they'll do a little pad footing, I mean, it's not exactly direct comparison here, but just information point. You'll come out and you'll see these essentially piles poking out of the ground, and it might only be out 6 inches, not like this. And then you sort of wonder, well, is that some sort of pile? Should it have been engineered? What's the deal? And probably in the last 10 years anyways, it's been pretty standard practice pretty much throughout the province, from what I've seen, when they do the house foundation, they're already dug that all out. They'll put a little 2x2 concrete pad footing, which meets the prescriptive requirements of the code. You don't need engineering. And when they pour the house foundation, they'll throw a chunk of sonotube on there and pour concrete piles up off that pad footing. And that's wonderful. And they can build the deck, they can close the deck in, they can do whatever they want. It's a foundation below frost, it's below 4 feet, that kind of thing. But yeah, if you see something on this scale or this magnitude, I don't know what to tell you other than, it should have been engineer designed, and that's about it. Same with the screw piles. Again, we ask for an engineer detail design, and usually what we do on our end of it is we get what they call a pile log. So depending on the use and application, if it's a house or a structure, again, some municipalities, if it's for a deck or something, might not get too antsy, but if you're doing a big addition on a house, I don't see too many houses being built on screw piles, but more so for additions, they can be very cost effective. They can get these rigs into places that you couldn't get bigger equipment into. Some of them are set up to run off skid steers, and we should have, and again, I don't know how you would track this down after the fact, but what we like to see is somebody have put some thought into the design, usually a professional engineer, the helix size of helix, the number of helixes on here, the diameter of the shaft, and then what they go for is resistance on these piles. So this should be a gauge on this, the machine that's driving these in. So the deal is these things thread into the ground. They don't auger into the ground. So it's more of a screw than an auger. So they don't want to really disturb the soil much. So they actually go in more like a screw. That's hence the name screw pile. And when they get to the proper resistance, and they kind of have a formula where they transfer the resistance to drive those things in. That's usually a factor depending on the pile. It could be 3, 4, 5, 6, or 7. They take that, they times it, and they say, okay, this thing was 4,000 pounds of torque resistance, so we're going to give it a rating of 16,000 pounds bearing capacity. So what the inspectors will ask for is the pile log. So this guy should be keeping track of all these piles, figure out what the resistance was when they quit drilling them in. Then they usually come back, they'll cut them off, weld some sort of a connection for the beam to go on there, the floor system. That pile log should be submitted to the inspector, who can compare it against the design of the building to make sure it's adequate, and away we go. Again, this is a ton of piles in a short span, so I don't know what's going on here, but these are very popular just because they're easy to put in. I actually see a lot of these with mobile homes. Go figure. Seem to be kind of a desired way to go as well. But I don't know, Alex, you got more to add to that?
Yeah, just from an inspection aspect, you guys want to be checking for, if it's wood blocks, wood piers, any sort of rot. For concrete and steel, you want to check for any sort of deflection, any sort of leaning. Again, that's where your level comes in play. Check for any sort of water damage to the concrete. Say again, poor surface water mitigation methods. You may see spalling, may see cracking. With the screw piles, again, just check for proper bonds between any sort of plates. A lot of times you might see them offsets with no shims. Like Brad mentioned, you won't know if these are friction or end bearing concrete piers and piles. So, I mean, that's just something you have to suggest to your clients if they want to further look into it, just make sure that they were installed properly, if they're actually permitted as well. And like Brad said, depending on your area, a lot of times you will see these for additions or any sort of recreational property, sorry. And I think that's basically it for me for these 2 points. You covered the rest pretty well.
Yeah. Oh, yeah. Well, okay. Yeah, this don't usually, again, this is something you mentioned the term recreational property. This is something you would probably see at a recreational property. Like I spent a fair amount of time out at Glenford Lakes of the world and the Pine Lakes of the world, and lots of good stuff going on out there. Carefree Resort, and it's odd because you get out to like Carefree, you're not allowed to go with subsurface foundations out there. They have some bylaw in their condominium association, and I think it's because they got a bunch of shallow services running all over the place. They don't know where they're at, but surface foundations, from our end of it, usually in the code, kind of, there's some stuff, depending how you look at the code, you can go about 600 square foot type structure on there. And I'm thinking that's what we're talking about here, what I would call there would hopefully be some sort of a pad footing or something under here to take the load, and then somebody's, come back and stack something up there, whether it be concrete blocks or cinder blocks or what have you, to achieve the job of providing a foundation. I'm not a fan really of these things. And again, like this looks like a log building, looks like we got a lot of weight on here. So the flags would be going up all over, my world. I'm just wondering what the hell is going on here. This is dropping down. It almost looks like an addition onto something even that they went and maybe this was on a proper, I'm just speculating here. This might've been on a conventional foundation and someone did an addition. Boy, oh boy, you'd want to research these and see what's going on and what's underneath here and what have you. But well, I'll just be honest with you. It's just really a cheap kind of shitty way to go, I think personally. But yeah, I mean, at least you can see what's going on to know that it's a problem and it's not been hidden or what have you, right? I'd want to investigate what's underneath here and see what's going on. they might have a 4 by 4 foot by 12-inch deep concrete pad footing under there that's been there since 1952, and it might be working just fine. But when these things are out of whack, out of level, not properly secured to the structure, all kinds of issues, I think that require attention. What do you think, Alex?
Looks like a headache to me, Brad.
Yeah, well, and hopefully that's something a buyer can look at it and run the other way or get the price adjusted.
Yeah, absolutely.
Some soil contaminants. Sorry, just reading the notes on here. Okay, well, this is pretty standard requirement anymore. Like, I mean, it's kind of weird the way the code reads. It says something like unless shown to be unnecessary. So like everybody puts sweeping tile in, or has anyways, for a long time, 20, 30 years probably. You do see some variations. I mean, this isn't something you're ever going to be able to look at, I don't think, as an inspector. 6-inch tile or 4-inch, I think, is what the code requires. And then a 6 inches of rock on here. This would have to run into a sump, or a dry well is another option. So I guess if you're out in the rural areas, and that is very common, like if you're on a sloping site or walkouts in the country, a lot of people will just, they'll run these. You got to be 5 meters out from the house, about 15, 16 feet. It's supposed to go into what we call a dry well. So, and I've seen it when they dig out the foundations, they'll dig a little trench away from the house and a little pit, there's no specs on that dry well, but usually something that's, 4 feet by 4 feet by maybe 4 feet deep, and they dump some coarse rock in there. And it's at a lower elevation than the house slab. So, it's going to work preferably if you can have those on the south side of the house where you get some sun on them and the frost isn't as big a factor, it doesn't freeze off. Sometimes people will just drain them into this off the side of the hill. Again, I don't think it's a big crime if you've got good grade and the drainage around the house is good. And just when we've seen some problems, it's usually when people are trying to do something funky on the north side of a house in the shade, and you get the big spring thaw and snow's coming off the roof or what have you, and maybe not great drainage around the house and stuff like that. But there should be a sump. You'll see mostly, like definitely in urban centers, you'll have a sump pit of some sort. And then, there may or may not be a pump. Some places they might actually, depending, there's some municipalities where they might actually drain that weeping tile into a storm system. I don't know around central Alberta if we have too many. Just trying to think. Pretty standard practice to run it into a sump, though. This is pretty standard. Whoops, standard business anymore. Sometimes this will have, if the builders are a little more conscientious, and if you've got soil conditions that are a little more silty or sandy. So even though you've got this 6 inches of rock on here, but if your backfill is going to be finer materials, they might use a filter. They have a cloth that will go over the tile as well, and it'll help from this getting clogged, so I'm told. I've heard some places in BC, actually, it's a requirement where they actually incorporate cleanouts in these, which I'm not sure how, maybe on the corner of a building or something. They maybe put a vertical or something on here that you could put a snake in there, because apparently some places where groundwater issues are very high and there's a lot of migration of moisture through the soil, these things over like 20 years it might take, can actually start to silt in and fill up. And they've asked for provisions, not an Alberta thing, just a sidebar thing. The other thing which you wouldn't be able to see, and I've come across a couple times, maybe more of the do-it-yourselfer people, is this does need to go around the perimeter of your foundation, which is adjacent to your living area. And I've gone out and seen people run it up around their attached garage, not between the house and the garage. Well, that's a problem. That's moisture is going to find a way. So it needs to run around the, if you have a concrete wall that's adjacent to your attached garage, but your house foundation is 8 or 9 feet deep and your garage is only 4, that tile needs to be sleeved through the footing, run across that wall that's adjacent to the garage, and then of course somewhere run into a weeping tile or into a sump pit. And these can they can maybe pump out into an exterior drain, which sounds kind of counterproductive, but they might have a connection to a hose outside, which runs a good distance away downhill from the house, or out to the street, which will pump into a storm sewer, or this can, sometimes they'll actually have a storm sewer option in here as well. But the big thing is to have it come into an accessible sump that you can deal with it if it's a thing. And then you guys see more of this than I do. Some people are nervous if the thing's running all the time. It doesn't mean it's the end of the world. It means the tile's working. It might be an area of concern. Maybe you want to have a backup pump. That's another thing. Actually, yeah. So I don't know where this is going. This could be going out to the street or out into a storm system of some sort. But I know some people, they'll put 2 pumps in here just in case one fails. It's kind of a redundancy thing. If this is running all the time. But I don't know, Alex, you got more to add?
Sure. Yeah, I'll jump in a little bit. So I like to refer to your sump pump as like PPE, like your last line of defense. I would never recommend that a homeowner, or your clients just depend on this. It all again starts with your surface water mitigation, right? The gutters, the downspouts, and the grading. I'm going to keep hammering this out as much as I can today because you're going to be doing the same thing once you guys start inspecting. So again, I've definitely come across homes that have the absolute worst grading. Everything's just poorly managed, but there's not a drop of water inside the house or any sort of evidence. So I mean, that's just basically the weeping tile system really getting taxed. I've also seen where you have really good surface water mitigation, but for whatever reason you just have a high water table and the sump pump is always running. So what I always tell my clients is, you're looking at the image on the right. If this is something I came across, I would say, first off, we have moisture. So I mean, it's not a bad sign. It just means that we got, moisture in the area for whatever reason. Maybe we have a snow thaw, maybe we have active rain during the inspection. But when you start to see all this silt and all this gravel, all this rock that has made its way into the basin, you want to let them know, give it a clean, because I've definitely seen pumps that have been seized or clogged because of all this debris. You can clean them out. And I think in your guys' modules, you'll have an image. I don't know if it's in the structural or the plumbing, where you'll see the weeping tile is full of roots. They're actually coming into the basin, right? So I've never seen any clean outs, but I think it would be great practice if they were installed. I've attempted to do scopes through weeping tile, but generally they're not built the best, where usually it's just dead ended at a corner. You don't have really nice kickouts, no good 45s or 90-degree bends. So it'd be pretty darn hard to clean them out. But if you see any clay or mud in the weeping tile or any roots, you may want to recommend that they be cleaned out. Today's building code actually requires for the basin, the lid to actually be airtight because of radon gas. We'll talk about that here really quick. In a few slides. But like Brad mentioned, some basins, some sump pits will actually have dual pumps and dual sump pumps, I should say, and that's not a bad practice if the unit is always going. And I always tell people, consider getting high water alarms, get backup batteries as well, because I've definitely come across pumps that were seized. I've seen receptacles that were not wired properly. I've seen floats get stuck. I've seen everything really. So if you have that high water alarm installed, near the top of the basin, I don't recommend on the slab in the basement, because if the water is there, it's already too late. It's game over basically. So I always recommend, a few inches from the top. A lot of security systems will actually have that additional option for the homeowner to have that high water alarm. And again, backup batteries. When it rains, it pours, we often lose power. So if you have that backup battery source, just you're going to be hopefully, or your homeowner, your clients will be hopefully protected, while the neighbors maybe not so much.
Yeah, well, that makes sense. Okay, we'll carry on. Oh boy, clay tile. Where are you going to see this anymore? This, I'm trying to wonder, like you wouldn't see this around the perimeter of a foundation. Here's what I was talking about earlier. This is a little more of a Cadillac tile with a filter cloth or whatever on it. This is a little more of a sophisticated system, and should cut down on getting too much crap in your sump pit kind of thing, and just allow water to go through. The clay tile, I'm at a little bit of a loss. I've never seen clay. I mean, there's some old sewer systems around for sure that were clay. That was not uncommon back in the 50s and such. But do you have anything to add on the clay tile, Alex?
But so again, right, most of the time you're not going to see what the actual weeping tile is, if there is one. Typically, clay and sewer lines ran 60s to the 80s. So that's, the odd builder may have installed clay tile for the weeping tile system. As you can see, they have little gaps here, 1/4 inch to 3/8 of an inch, and that is actually what's going to allow the water to ingress into the weeping tile system. They would also generally be covered by treated paper. Again, just to help to remove some of that silt that may clog up the system. But eventually, if the system is being used, you are going to get that fine silt. You are going to get some mud entering the weeping tile system, whether it's clay or plastic. So again, just be vigilant of it, depending on how much debris and accumulation you see in the actual basin.
Yeah, okay. Yeah, I don't, you're right. You can go back a little bit, probably like pre-60s. This probably wasn't much at all in the way of weeping tile. Like, I mean, there's a lot of old homes don't have it. And they're just fine. Oh yeah, this is some nice stuff here. So this is getting into some dimpled or Delta wrap, and there's some different products out there that it's really a Cadillac dam proofing system. This would be in lieu of a spray on, bitumen type product or roll on product. And the nice thing about this stuff here, sort of can tell if you haven't seen it before, but it is what I word would be dimpled, right? So there are a bunch of little air spaces or whatever that it creates. It works pretty slick, in my opinion. Now, I don't know, like I can't say that I've personally been responsible for installing this and have no warranty issues over 50 years, but boy, the design seems pretty sharp. It should go down, like they're saying over here, like it's something we would look at as inspectors. Will come out and we'll kick this rock off, make sure that they've gone across this joint. Simple little thing, but again, it's just a workmanship thing. Why not? You've got the material, you're installing it. If you terminate at the crack here, you do have that higher potential, because this is a cold joint. This is a potential area for moisture to get into the house. Do that extra step, take it out over into the edge of the footing so that you are getting any potential moisture into the tile is where you want it. Yeah, it's fairly straightforward setup. Here's a good example. Obviously, a window well is going to be going in here. They've got some sort of pipe or tile draining down into the window well. I mean, these are things you can see after the fact. You can usually kick a little bit of gravel away around the bottom of the window well and see if there's some sort of pipe there. And that could be whatever. It could be just a corrugated pipe or PVC with a cap with a bunch of holes on it or what have you. But these things need to drain, because I do know of issues where this wasn't done and water will find its way in that window eventually. Anything else on that, Alex?
Yeah, sure. Just a lot. You have different systems out there. Some of them will have the dimples, on both sides that actually will channel the water to drain out if it does get in behind the actual drainage board. And typically you should have a cap on it as well. And of course, manufacturer dependent, you have different adhesives that will be required or fasteners to be used to when the installers actually place this drainage board.
Yeah, I mean, this isn't this is like a 1 in 30 or 40 that I see this stuff out here. I guess it depends on the builder. You'll find a certain builder likes it. I think, around Red Deer, if we're talking Red Deer, I think Sorrento uses this all the time. There's it just depends on who the guy is. And the other, I don't know if I have any examples or not, but I mean, the spray on, like Marshall Brothers and Gilmar and guys like that, they've been doing that for years and with no problems with that either. Oh, here we go. Yeah, again, these are just some other systems. This is what we see mostly. What should be done here in addition to, I don't know if this is a spray or roll on. It looks pretty thin. Can't tell. It's really hard to tell from the picture, but it could be rolled or sprayed. It seems like the spray on guys usually do just, a nicer job, just from my perspective, because it's nice and thick and creamy on there. Almost looks like someone smeared peanut butter over everything. And usually the trowel on stuff gets a little skinny. They got to really pay attention and maybe give it a couple coats. They should be tarring the tie holes as well, which looks like was done here. I don't know. Again, it's something you probably can't see, but if you're on the inside of a foundation and it's not finished and you got a bunch of signs of moisture coming through where this tie locations are, probably they didn't do these tie holes, right? So this needs to be a little more care and workmanship. So this does look like a clean out here, hey? Because why is this above? Oh, they're going to drain the rainwater in here, I think.
It's like
Guessing possibly this could be for these trough, eh?
Yeah.
Yeah, that's what that's going to be for. So and this all likely then probably finds its way into the city sewer somehow.
Yeah,
You
most
go
likely
into,
the storm collection system. Yeah, they probably don't want to tax their sanitary. Um, and like Brad mentioned, you obviously, unless you're in an area where they're developing new homes, you probably won't see this portion of the construction. But if you guys are in those spots, by all means, take a peek at them, because that's going to give you a bit of insight into how the builders are, building homes in your area, because they're all going to be a little bit different. And as you can see, we got a couple different styles here as well. You got membranes and you got the roll on or the spray on. Typically, for either system, you want to make sure that the foundation is actually fairly clean, just because if you have any sort of mud or debris, you won't have as great of adherence to the foundation.
yeah, yeah. So just like looking at this, I'm just thinking like you got bedrock homes out in Liberty Landing there. So what they do, they drain their tile into a sump, and then they've actually run another pipe out of the building, and they have to go up because the storm elevation is different, and they don't want to tax the sanitary, but they'll actually run it into the storm system out on the street. So they have a pump in there, but when it pumps, it'll pump into this other pipe, which has to go uphill a little bit, and then over into the storm system, and away it goes. So it's kind of slick and neat, and it's a little extra step there. But if you're looking in there and you're saying, well, the pipe's coming in, I get that, and why is there another one going out, and where's it going, and things like that. Yeah, I guess with these polyethylene or any of these types of peel and stick, I call them, or any kind of these types of products here, not something you'd see again. But I mean, the concern with these ones is that the backfill they use is not full of coarse rock or anything jagged that's going to shred this thing up, right? It should be clean clay or silt or sand or whatever, something like that, that'll still pack and do the job and not damage this. This stuff seems to be a little tougher if applied correctly, but yeah, it's different ways of doing stuff. Oh, right on. Yeah, this came into the building code here. Oh, I don't know, probably 2014 code, I think. They brought it in, and a little background on this, if you guys haven't heard it 10 times, but there's a Health Canada thing that got it put into our code. They used to measure it by becquerels, right? It's just the measure of radioactivity per cubic meter of air. And Health Canada for years said that, if you test your air in your house and it's 800 becquerels per cubic meter, they consider that to be acceptable and safe. But they were finding people were having lung problems or issues and things. And then when they investigated, these were people that weren't working necessarily in a high hazard environment. They weren't welders or working in, toxic environments, and maybe they weren't smokers, all this stuff. They'd test their house and they'd find these becquerel levels to be, lower, like maybe 300 or 400. So the decision was made that all of a sudden 800 was considered safe. They dropped it to 200. Well, they have records. All the health authorities years ago did tests throughout Canada, different health regions. They got people sent kits to people's houses who wanted to cooperate. I think there was about 110 in central Alberta, something like that, sent out. And then they have this little collecting device. It's a little size of a grapefruit thing, and you'd sit it on your shelf in your basement for 3 months in the winter, and then you'd send it in, and they would do the math. And the Red Deer area, so they figured 200 was safe, and they only had a few that came in over 200. It wasn't very much. It was like 10 or 15%, but kind of that way throughout the province. I mean, it varies where you are, and it's not something that one house to the next can have very different levels. It's all about uranium depletion below the soil, turning into radon and getting into your house. So they, so now the current codes are, we have to be very vigilant with the poly under the slab, sealing up as the picture shows, any gaps around posts. The sumps have to be as airtight as possible. The poly should run up along the under the slab up onto the foundation wall, and then the slab kind of seals it in there. The code now requires coarse rock under the slab, whereas before you could put sand. And that again, and then we need to also have a radon pipe that is basically a 4-inch PVC or ABS pipe that should draw from the center of your basement, usually over to a mechanical room or somewhere that's accessible, maybe under a stairwell or something. That if you get a test under your house and you come in at a high level, you can actually incorporate a low-speed exhaust fan onto this pipe, and hopefully you have provisions to blow it out the side of your house or whatever. And that just basically depressurizes and moves air from under the slab out of the house, as opposed to that air having the ability to get into your house where, the occupants are going to breathe it. So I did my house. I got it tested, 3-month test. I'm down old house in Woodley, and maybe it's good it's old house because it's kind of leaky, but I came in at about $150. But I worked with a gal at the county. She was in a newer neighborhood down in somewhere in the southeast there. She come in around I don't know, 300. So that was kind of odd. So yeah, so these is a current code requirement. So I'll say current as in 2014. But so you wouldn't expect to see this pipe in a home that was built prior to then. But there should be a pipe, usually in the mechanical room, or like I say, might be under, say you got a split entry or a stair landing or something that's someone stuck it in there because it was unoccupiable space. And it's supposed to be labeled. Probably won't be a pretty label like this. It'll probably be just a cap with someone scratched on their radon, maybe spelt it wrong, but you'll know what it is. Yeah, so there are ways to, if you do have high levels, what people are recommended to do, and there's all kinds of information CCMC has on their website, like installation of an HRV in a house or something like that. Maybe run around and, and seal up some of these cracks where you can or where they're visible, and you can do some things. HRV is pretty good way to go because you kind of have a constant air exchange in the house, and that can usually knock it down quite a bit. They did say between 200 to 400 becquerels, the caulking up the thing, sealing up the thing, maybe the HRV. And then they talk about if you get into that 400 to 800, you probably, might have to look at something a little more heavy duty. I talk to people, get people come from Europe and stuff, and this is pretty commonplace. They'll build a house and they'll pipe this thing right out of the house. They'll run it up like a plumbing stack. And they want it. Also, guys out of the central area of BC, like get into Kamloops area and places like that. Apparently, it's a big thing. There's a very high radon levels down there. So that's sorry, that's my radon speech.
Yeah, I'll throw in a couple notes. That was great, Brad. So, like Brad mentioned, Health Canada has known about radon since the 60s. It's actually the second leading cause of lung cancer in Canada after smoking. So if you're a non-smoker, this is likely where you would get lung cancer from if you were exposed, at high levels for a duration of time. There was actually a study done by the University of Calgary last few months, and they compared the 5-day tests versus the 90-day tests, and they found that 99% of the 5-day tests were actually inaccurate, highly inaccurate, whether it's showing too high or too low. So I'm not radon certified. You'll notice on the image on the left, there's the CN RPP, I believe is the National Radon Prevention, I think plan is what it is, something like that. Anyway, they're the ones and only ones that can actually authorize the certification for any sort of radon detection and mitigation. So, all right, that's all I have for this slide, and we can probably go to the next slide just to show some systems.
Yeah, so this is these are basically the components of a radon mitigation system. They should mention the rock. They have some specifications in the code with the the coarse 10% through the aggregate has to be fairly coarse. Long story short, and this pipe looks like it's capped off, but obviously there should be holes in it to allow the air soil gas to get in there. This should be a straight pipe. I've heard some guys say, "Oh, it's got to be a perforated pipe," but I mean, I've actually took the time to get a hold of the Health Canada people years ago when this came in, and it just makes sense to me. This would be a solid pipe because the point of this, so this, like I say, center of the floor slab. The intent here is if you do put a fan on here, negative pressure, this is your suction point, right? If you got a bunch of holes in here, you're going to be disproportionately evacuating the air from this half of the house. So it's not wrong. If you talk to the provincial people, they're like, we don't care, put a pipe in. But if you want it to work effectively, efficiently, and do its job as intended, this should be solid pipe. You want the central location. That's why they want it in the center. And you put this under vacuum. It should theoretically draw evenly throughout the basement, relatively evenly, and give you that equal protection. You punch this full of holes, half that house might not be getting the proper mitigation. But yeah, this is basically it. It's just a pipe. It's not a big dollar item. So the industry hasn't pushed back or anything. There's been no big revolt from the Home Builders Association. And yeah, I think it's probably worth getting a test, especially if, maybe you already have pre-existing conditions or people with, asthma and things like that. You might want to pay attention to this requirement. So, but again, it wouldn't be something that the code would have in place other than after, in that 2014 Alberta Building Code adoption. I think it came in after that. So pretty simple, pretty straightforward. I mean, like I say, it's other areas that have higher levels of concern, or this isn't enough. Like they'll run they'll have like a field of pipes under the slab. They'll have like every 10 feet you got to do, in those cases they do corrugated pipes because they do it much like a weeping tile system. But when you're limiting your system to the one intake, it should be in the center and sucking as much as it can. Okay, yeah, all right. So that's interesting. So yeah, and I guess depending on the configuration of your foundation of your basement, I don't know again if this is the center of the house or not. So they've it's interesting. So they looks like they drain us into the sump, and then so just some sidebar stuff here you might find, and I'll use Bedrock as an example again because they got some neat ideas. I think they got away from it, but they were running their radon mitigation pipe, kind of like this here. So this hopefully theoretically is in the center, let's pretend. The idea being you get your test done. It's like, oh, I got radon problems. I'll put my fan over on this little upright in here and draw it out. But you'll see it goes into the sump. And what I think it does, what Bedrock was doing in homes that had window wells, their theory was, well, our perimeter weeping tile goes around the house. We have a vertical pipe going into our window wells, which goes into our perimeter tile. So they thought it's going to cost us no more money. And it was just a little brain thing they had, was that we're going to have some passive mitigation because, stack effect or whatever you want to call it, warmer air tends to rise, that kind of thing. Or even just the fact that you've got a hole in the building envelope. And their thinking was that it's not going to cost the owner anything. And there's a possibility that we will get some passive mitigation just from any soil pressure, soil gas buildup or pressure should theoretically go into here. And when it's in here, because this is sealed, it's going to want to keep on moving. So it should go into the perimeter weeping tile and up through those window well locations. It was kind of a neat idea. And I think maybe that's what's happening here, not sure. But say that fails and you still have some pretty high levels, you still have the option to put a fan on it. And then you would cap that off going into the sump because that would be counterproductive. Plug that off, hook your fan on here, and away you go. I think that's what's going on here. I'm not sure 100%, Alex, but
I would agree.
yeah, and this one on the right here, again, this looks like it's just maybe a passive vent going out. They may have a exhaust fan, inline fan up in the attic or somewhere like that. Can't say for sure, but this does look like it's not plumbing, right? Plumbing has to be, as you guys probably know, ABS when it's above grade. So I think that's why you'll see PVC or something later gauge for this system. Are we good on that?
Yeah, you bet. Maybe we'll take a peek at the map here next before taking our short break.
Okay, this is interesting. Yeah, I wouldn't. Okay.
Yeah, we could probably actually leave it. Leave it here and just take our break so we can come back 9:15. So we just leave this map on, and then people just study it at their own leisure.
Yeah. Okay, that sounds good. So we'll just pick it up 1/4 kind of thing.
You bet. Any questions so far, guys, for any of the content we've covered?
Yeah, I have a question here. When do you consider, or let me just reply by saying that frequently we see cracks on the basement floor, on the garage floor, and even driveway. When do we consider cracks on the basement floor and a serious issue?
When are cracks on the basement slab considered serious? Is that the question, John?
Yeah.
Yeah, fair enough. So you're typically going to see cracks in the slab. So, I mean, cracks in the slab, I mean, again, they're very, very common depending on your area. Generally, they're a concern for water intrusion and also radon gas intrusion, right? So, I mean, it's always recommended that they be sealed up, but generally, the only structural aspect of a concrete slab is to actually keep, you know, the foundation interior portions of the wall from bowing. So they do offer that sort of structural support, but beyond that, nothing else really, in my opinion. So, I mean, you know, you may want to indicate them in your report just for the radon and the water intrusion concerns, but from, you know, a structural aspect, I wouldn't personally get too concerned about it.
Okay, thanks.
Okay, well, let's pick it up in whatever, 10, 20 or something like that.
Yeah, we'll do a quarter past, guys. There'll be, I guess, a 10-minute break. So see you soon.
Okay.
There was a question I'll bring up here. So this is from Andre. I'll probably let you touch this one first, and I'll kind of give my 2 cents after you had a chance to answer there, Brad. It says outwards bowing of a stucco wall above the poured concrete foundation. Is this a structural issue, and what causes this? Thanks.
Oh, sorry, just when you started talking, I had one little blemish on the audio there. Outward bowing of a stucco wall above foundation?
You bet. Is this a structural issue, and what causes this? So the outwards bowing of a stucco wall above the board.
Well, I don't know. I guess in my opinion, are you able to access the interior of the wall and assess if it's bowed? I mean, if there's a correlation between a bow on the inside and outside, something's not right. And there's some bad stucco workers out there too. And if you look at any stucco wall and you hit it in the right light, it always looks like the wall is just all wavy and bowy. Was it an addition or something? And at the addition portion, was it just maybe bad materials when it was built originally? Is it a bi-level where maybe, you know, you've got a bad workmanship and it was a 4-foot pony wall on top of a foundation wall that wasn't constructed plumb to start with? I mean, there's a lot of variables. I don't, you know, like anything, I don't know if there's a surefire way to suggest that it's a failure. We don't see too many, you know, 2x4 or 2x6 exterior walls that really tend to bow a bunch. It's usually, if it's something ugly, it was built that way. You know, wood is pretty good, pretty strong. You know, unless maybe if you had an unusual situation where you got 2 floors and a big roof and some big spans going on there, but you know, first thing would be to check the inside to see if there's a bow on the inside if possible, and then I would just wonder if it's more of was an original core construction thing that happened.
Yeah, I would probably agree with you there, Brad. It's nice to hear that safety codes officers have the same issues that home inspectors do. So like Brad said, it's I think I know what you're talking about, Andre. When you usually, this is probably found in older homes where we have the foundation wall, it's nice and plumb, and then you have the stucco that kind of bulges out. Is that what you mean, Andre? So you had the little bulge, and again, generally I would highly doubt that's, you know, a structural defect. I think like Brad said, it's just the design or the workmanship that was done when they applied or reapplied the stucco, where it kind of just has that bulge out. And I think we have some images coming up possibly in the exterior section that kind of shows this as well a little bit. But yeah, again, typically, unless you see possible indications of a structural failure inside the dwelling with cracks or, you know, any sort of sag, or again with the windows and the doors not operating properly, I would say it's probably just workmanship on the actual cladding. So yeah, we can move on to the flooring systems here, Brad. Unless, yeah, you're welcome, Andre.
Okay, so let me get my head straight here. Where are we? Yeah, okay. Well, looks like we're getting into moving up from the foundation now. We're getting onto the floor. So I think this detail here is just probably some pretty typical construction. Although, you know, probably in the last 20 years, those wouldn't be wood joists. We're moving pretty much to I-joists now. It's pretty much the norm. So, but same idea. You're going to have a column. You're going to have a beam on the column, and your floor system will either sit on top or be, you know, it can be framed into the side of the beam with hangers and things like that. So that's pretty straightforward. This is a detail, I'm assuming, of a structural column. which haven't seen a bunch of these kind of things. Or sometimes they'll encapsulate a metal column or an old wood column. Sometimes older homes, you guys probably see more than I do, but I've been around a bit and with renovations and stuff, and you'll see, like 6x6 columns or something, in the basement. And maybe they'll actually put a little concrete pier type thing that they poured in with the slab or after the slab kind of thing like that, usually after. But, it's pretty logical, right? We have to transfer loads and they go down to the ground ultimately, and then have to support the building moving up. So I think it's pretty straightforward. Well, and here's a built-up wood column that, this should be desirably separated. Some guys will do this, and usually not in new construction and for a big load, but maybe around stairwells and things like that, where they don't necessarily need a telepost, although this looks like a pretty substantial column, a 3-ply 2x6, but this should have been pressure treated, or should have had a some sort of polyethylene protection or something along those levels. And code actually requires that any wood in contact with concrete below grade, it's got to be pressure treated, or like they'll wrap poly around it sometimes, which isn't the best. But this is a good example of what happens when you don't do that, because there is some humidity there. It might not be necessarily detrimental to the house as a whole, but it's going to be high humidity, high moisture, not a lot of air movement down here, right? Because again, the warmer air will rise. So this is usually pretty stagnant down here, unless you've got some sort of mechanical system to move the air around. And guess what? You get rot. So not a great thing.
Yeah, maybe we'll just make a couple notes. So, these columns, they will range. You can have concrete block, brick. You can have steel teleposts, which often have a nice adjustable collars on them. It could be wood. So obviously the columns will transfer the weight from the beam that is likely above into like a footing of some sort, hopefully. Sometimes you'll notice that there's been some modifications done where they removed a column, and you might see just the imprint of what it was, or they may have decided to shift it over, but you just don't know as an inspector if there is a footing below it. So you may want to advise them to put it back, or find out who did the alteration. Was it just the homeowner, or was it actually inspected by an engineer, possibly safety codes officer, or a framer, right? And this image here, well, actually both these images just depict older style construction, right? So these are obviously older posts or older support post, and looks like dimensional 6x6 post on the image on the right. So if you start to see, or if you see any sort of wood touching concrete or embedded into concrete, just get a scratch awl and do some probing, because as you can see over time, because concrete is porous, it will actually absorb and allow water to be wicked through the material, and it can actually cause rot to the actual wood structural members. And with, like Brad mentioned, we're going to talk about the wood eye joist here in a little bit, but typically if the span is not too great, you don't have support posts or columns in dwellings that have wood eye joist, just because they are an engineered system. But we'll talk about this here pretty.
So we're looking at what's this, sill plates? Yeah, this isn't terribly common in Alberta. This is more down east. You'll see a bit of this sill plate type stuff. That being said, ICF houses will have a sill plate. That's pretty standard. They'll usually, the builders will bolt on an LVL plate of some sort into the top of the concrete is exposed. But in Alberta, we use what's called the ladder system. I don't know if this presentation gets into it in much depth, but it's basically, it's 2x4. They use the word ladder, so you'd have a 2x4 on each side of the top wall of the foundation, and then usually every 4 feet or 2 feet, they'll put another intermediate 2x4, making what they call a ladder. And this gets cast in place with the concrete. And sometimes they'll add some anchors, into those 2x4s into the concrete. So that is probably 90% of the foundations that you see in Alberta, well, in the last 20 years anyways, would be the ladder system. They don't do it down east. I don't know why. They still do the sill plate thing. Ladder system works pretty good because they cast it in place. It's pretty clean and quick and easy. You don't have these anchor bolts sticking up everywhere. So when you go to finish, And then these anchor bolts, depending where they wind up, sometimes they, just as luck would have it, they wind up under a floor joist or something. And then someone has to drill a hole to put the sill plate on. I mean, this is probably the superior way to go with the sill plate on there. And there should be a gasket. Did they show a gasket under here? Yeah, a mortar bed or a gasket under here. Nobody does a mortar bed. It'll be a foam gasket for the times you do see these plates go on here. But that, or what I've seen some of the builders do as well, is they'll embed a 2x4 on the flat in here as well. That's another way to do it. And they'll put their anchor bolts into this sill plate and countersink them down a little bit so they're not going to get away in the way of the floor framer. And then they'll pour the concrete wall, get it all nice, and then they basically set that 2x4 into the concrete. Just another way of doing it. But point being, you need some way to anchor your floor system to your foundation wall, and it has to be something substantial. It is an important thing. It's not just for uplift, but lateral pressure on the dirt on the house, right? So you need something that's going to be pretty good to make this connection here. So this is acceptable. A ladder is acceptable. Basically you want to try to get some sort of bolts. I think the code's pretty lenient, only one bolt every 8 feet or something. That's kind of what I can tell you on that.
I'll add some more notes here too, Brad. So you guys will notice in the schematic too, it does require a 1.5-inch end bearing for the joist to be resting on the plate there. You're actually not required the moisture protection, rot protection, if the concrete foundation, if the top of it is adequately above the grade, so typically 6 inches. But like Brad said, if it's within that 6 inches or less, pressure treated lumber works as well, or that gasket. But I mean, really good builders will use both, which is great. And like Brad said, it does allow the actual tying of the floor system or the building of the floor system, but also it keeps the exterior wall structure as well, the sheathing and the wall studs above. So there will be some images, I think, here where we see some defects to these systems. So again, if you guys see the really poor grading on the outside, if you see the downspouts, all that other good stuff, if they're not positioned properly or if they're not properly maintained, be extra vigilant once you do your interior inspection, because you might see rot at the sill plate or the rim joist, which we'll talk about here. And we got some images of ladder systems here in a few slides.
Okay. Another thing you might see, just for information purposes, is so assuming they put a ladder system in here, some builders will put plywood again on top, which is nice because it gives you a nice smooth finish to tie the floor to, but then they'll run the plywood over usually like 4.5 inches or whatever they need into the interior of the house. And then they secure their frost wall to that. So that's, again, like not everybody, but it's a real nice, clean, neat, decent system that makes everything tie together nice. And then when they go to do their interior, what we call frost wall, they've got something to adhere, screw that to, nail it to, or whatever. And it's just, you might see it and wonder what the hell it is. That's what they did anyway. So just another point. Oh, there we go. Okay, well, here's a bolt-on on a bolt-on wall. So yeah, not a ton of these you're going to see like that, I don't think, around central Alberta, but it's acceptable. It's actually a good way to do it. I can't see if they put a sill gasket under here or not, but so we've got a treated plate, nice big wide one. So you're going to get your adequate bearing for your floor joist, like Alex mentioned, and I don't know what they're going to do if it's not level, but that's what we got. And some foam on the outside here, so.
Probably the shims, yeah. I mean, that's what they'll usually do, right? They'll just kind of shim the rim joist
yeah.
or left.
This looks like an Eastern picture because we built things level out here, so. Okay, yeah, well, yeah, this is problems here. So I think without reading the notes or whatever, I'm assuming we've got some more of an envelope issue here than perhaps the structural issue here, but yeah, it is, depending how the care and attention that's gone into the exterior cladding of the building and the connections made between all the different components here. Obviously, water's getting in here, sitting in here, and causing rot. I'm not. Yeah, I guess I'm just looking at the notes here. Sorry. So they're talking about poor draining, poor grading, and things like that. Yeah, because usually this is going to be your closest to the ground area of your house, obviously, the foundation, like most, we're supposed to be a good 6-8 inches above, to get away without treated wood. There could be, like I say, poor drainage. You could get snow piled up against the house, and if the building envelope wasn't constructed properly with, adequate building paper or house membrane, something's getting in here. I mean, I think that's pretty obvious, and it's a real bad spot too, because this is where your house bears on these joists, so you needs attention. That's a fact. So I don't know. Well, that's not the prettiest ladder system, but that's kind of what we were talking about earlier. Usually when they finish this, it's a little cleaner, nicer and smoother, but yeah, this is a system. And if this is, I think it's 6 inches above or 8, I can't remember right now, but it doesn't have to be treated, but most, the better builders will use the treated wood in here. And it's just, yeah, it's embedded. So this is put inside the forms when they pour, and when they strip the forms off, it stays in here. And to be really doing a good job of this, hopefully they've got some sort of, some heavy gauge screws or something into these sides of these ladders that the concrete can tie into. I know, talking to some folks down east, they don't like this system because you can't confirm if there's any extra fasteners in here. And they're concerned down there because they have some higher wind load areas, is that these will shrink. And they said, well, once the wood shrinks, it's really kind of just sitting there. And yeah, and so we're sort of counting on the weight of the house at that point to give you your lateral support. But it's a valid point. But we've been using this for a while. It's an Alberta specific thing, which is kind of weird. It's not in the National Building Code to use this ladder. Alberta adopted it way back when, probably 1990 something or other. And when I tried to find out how it came into being, nobody had any records on it. But you won't find there's actual, it describes the ladder and how to install it and all this kind of stuff in our building code, but the National Building Code doesn't even address it. But and here's some missing parging. I don't know if this is the end of the world, but this is seeing sized lumber. That's a good sign. So my 2 cents would be it's not pretty, but the fact that this is in sized lumber is probably not the end of the world. But again, this isn't very high off the ground, so there is a potential for snow buildup and moisture to find its way in here. If this was up a foot off the ground or something, probably not so big a deal, but we're only a few inches here. So yeah, there should be an extra second plane of protection of some sort on here to keep that moisture from potentially getting in here. But it's helpful that it's treated, but not great. Parging isn't a code requirement, just so you guys know. There's no requirement in the code to have any parging. The only thing would relate to the ICFs having to be covered, and that's, I believe it's a UV protection thing of the styrofoam, not a building envelope requirement.
I believe only if cinder blocks are used, that's above grade, that's where you require parging for the.
Oh, okay, yeah, I'm not up on the blocks. No, that's a fair comment. So looks like, oh yeah, LVL, this is the world we live in. Good product. I mean, they can go great depth, lengths. That's, I guess this is just more of an information piece. This is the stuff we look at as building inspectors. So we require all these details, hopefully when the permit application comes in, but definitely before you do your framing inspection. I mean, sometimes there's just time constraints, the guy's trying to get out of the ground, and indicates it'll be an LVL floor system. So we'll ask if those drawings be provided, and then we go through and we make sure that right size beam, right designation of beams, like some of these are 2.0s or 1.55 or 1.8, they different strengths based on their what level they've been tested to and stuff like that, and all the connection details and all that good stuff. So like Alex mentioned with the 1.5 inches for floor joists, when we get into beams, the code is I think it's 3 inches or 90 millimeters, I think, actually, whatever that works out to, minimum bearing for a beam. Sometimes you'll find too there's some weird things with regards to where there's teleposts along the length of a beam, and for whatever reason, or the size of the beam or whatever, they'll have notes on the structural drawings or the drawings that come from the floor supplier for increased bearing plates on the teleposts and things like that. But I don't know if maybe we'll get into that or not. But stuff, again, I don't know you'd have that information as you're going out doing your job. That stuff you kind of have to have at the time of construction, so you can have something to refer to. But any rate, very common, very good, solid, strong, been around. Yeah, we're getting into the 90 millimeters bearing. for the beams here. So that's pretty standard business. Nice to, I guess, maybe pay attention. One of my little pet peeves is where you have a beam that ends up splicing over top of a post. You should have, and this is where you'll see they'll spec a 7-inch bearing plate, 7 by whatever the width of the beam is, because there's a joint there. And if you can imagine there being a post under this location, you have another beam coming in the other way. Maybe this beam is bigger for whatever reason, this one's lower, so that's why they couldn't go right across. You know, I would watch for that 3.5 on there. But steel beams, yeah, you see those once in a while. Should be the same idea. Should be into a pocket. Yeah, these are. Yeah, they have this little clearance in here too, if it's untreated, to allow so that you don't get that moisture transmission through the concrete that could end rot the beam. But oops, I think that's usually.
I can make some notes here too, Brad. So
yeah,
you guys may come across homes that don't actually have any support beams, and that may be okay. Obviously, you probably won't know. But if you have engineered flooring systems such as trusses, they may not be required. Also, you know, in older homes, you actually may have a load-bearing wall in the middle of the house, whether it be wood or a masonry. So again, in that case, you may not see any sort of beams because the wall would actually be acting like it. Also, you know, if you have a really small footprint of the actual structures where the joist span is actually sufficient enough not to require any sort of beams, so or support posts, just be aware of that. If you can go back one slide as well, Brad. So it's really common to see these LVLs. And just keep in mind that the actual strength is in the, I guess, vertical position, if you will. There's basically no strength when they're on the horizontal, on the flat, if you will. So it's pretty rare you're going to see anything like that, but you know, you may come across it. And we'll talk about notching here in a few.
sure. Yeah, well, we don't like this. It's not too cool. There's if you have the building code, and I don't know, you guys, I don't know if you know this, but you can access, just recently they've the provincial government has put all building codes available for free online. So if you just go to the Alberta Municipal Affairs website and you go into safety codes, and it's pretty easy to find. They'll guide you into where you can find those links. But there's some details and diagrams if you get into 9.23 that talks about notching and holes and beams and all this kind of stuff. So like, you know, like a floor joist, you shouldn't be more than 1/3 the depth of the joist. And I don't know how detailed we're going to get into it, but those parameters are provided in the code. And same with beam splicing. I don't know if we're going to get into that, not to get off topic too much, but I mean, when you do these built-up beams, we call them, when you've got 2x10s or 2x8s or whatever, ideally these will splice on top of a post or you know, in a beam pocket or what have you. You can actually have splices in these, but they have to be at what's called the quarter points. So there's a little diagram of how to do that as well. And that's a problem myself and my fellow inspectors will find, because a lot of these floor systems are engineered, and you get a young framer guy out there that gets stuck with a house. It's the old school and may not know how to do these beam splices. But this, I'm just going to say, is probably a problem. You know, without getting right into it, looking at it and getting the tape measure out and measuring it and knowing really how much load is on here. It would be something that I would want to get my book out and double check and see what's going on. Just because, yeah, you've diminished the strength of this beam greatly by putting this hole in here. That's a problem. Now this one here looks like, again, I'm just guessing because I don't know the history of this or what the background is, but looks like someone's put so many damn holes in here that they've actually had to put another beam underneath it to do the job. I can't say for certain that's the case, but there are limitations, like kind of the golden rule with I-joists. It's very liberal and very lenient. You can drill some very big holes in an I-joist, a solitary I-joist, or along a run of I-joists. You can pretty much go the entire depth of the web between the top and bottom chord. And then if you do another hole, you have to be usually twice that diameter of that hole to the next hole. Pretty loose on that. But the LVLs, they don't like you drilling holes in them. Some of the companies will have hole cutting details. I think APA, but I mean, they're pretty tiny. They're talking like, you know, 1.5 inch hole, you know, and then they got criteria where you can put those in. And usually it's just for a wire or something. But these larger penetrations are definitely flags that need to be investigated, looked at closer, because not cool.
Yeah, we'll definitely talk about engineered and dimensional like floor joists notching here in a few slides. The building code doesn't actually specifically talk about notching support beams, but it's assumed that you're not really supposed to do it.
Yeah, I think there's a little detail about if you were to do a 45 on the end here, but anyways, yeah, you're right. Yeah, that's not great. I mean, this isn't where it needs to be. Poor installation is correct. It's off center. It looks like they've put a temporary brace along here. Yeah, these are just things you'd want to look for. Like, I mean, there's just some good, I hate, you know, common sense would be the term I would use. Anything structural, should it be lining up nice, vertical, you know, straight, plumb. Anytime you put things on an angle, they're not going to do as good a job. There's a potential, I don't know if this is cast into the slab or not, but this could kick out, right? You got a hinge point here. Not great. Poor installation, good example. Yeah, out of plumb too, right? Like, I mean, you've diminished the bearing capacity of this column greatly when you going out of plumb like this. It's something we try to correct and note, and it's tough if these are cast in. Like sometimes they'll put the house foundation will go in, and then the interior footings will go in. So you'll have your 2x2 or 3x3 or whatever little pad footings, and then the columns, you know, and then they pour the slab, and then who knows, some guy with a power trowel bumps it or something, and now the floor is set, and it's the shits to try to straighten this out. Like, I mean, it's in the concrete, but you know, if you know the history of the building and say it's an oversized pad, sometimes they might grind the bottom of this off, you know, put another plate on the bottom, secure it down. It's still going to transfer down to that pad footing if it's only a couple inches, but it's definitely, this would be something you'd want to identify in a report for sure. Okay, we can. Yeah, well, that's just not cool. That's a whoopsie. Don't know how that would have came to be. I'm not sure. It looks like somebody tried to even. I wonder if this was put in after the fact, if they forgot the beam pocket, maybe. I'm guessing possibly, because it looks like there's some chiseling around here too into the actual concrete below the parging. But
Yeah,
again,
I can speak to this, Brad.
yeah, sure.
So this is a pretty common thing you guys may come across in older structures, you know, it's around the 60s era. And this is just basically the expansion contraction of the wood structural beam and the masonry foundation wall. So all it is just they didn't install a thick enough set of parging or you know, stucco, whatever they're using here. It looks like it's just parging.
Oh.
Yeah, so I mean, it is fairly common you get a bit of movement, again, more so in older structures. So obviously that's something you want to point out because this is an area of water intrusion as well as possible rot to the framing and the structural components, right? So yeah.
Yeah, it makes sense, yeah. No, you shouldn't see that. I mean, oh yeah, this is, yeah. Okay, well here embedded. Yeah, this was, you know, you're getting back into the 50s, 60s here. This was pretty standard business to embed these in here. And you kind of look at it today and you say, oh, it's not great practice, but you know, we've got that contact with the concrete and depending how high the concrete's above the ground. But from what I've seen and some renovations and things like that, they, again, if it's, you know, if everything's done right and you've got proper moisture management on the exterior of the house, they can be pretty good. This doesn't even look that old. Just kind of because these joists, this looks almost more like 60s or 70s, and just don't ask me why, but you can sort of tell when lumber was, you know, over the years how it's been milled and machined and everything like that. But maybe 70s, I'm thinking possibly. You know, good plywood subfloor. But yeah, no, we're onto flooring here. Yeah, it's not unusual to see this kind of setup in here. Does the job. Cut and knot joist. Yeah, this is something we're supposed to check for as inspectors, and that's why we like to preferably do the framing inspections after the mechanical rough-ins, and this is a good example why. Not uncommon and just whatever, it's just the way the world works. toilet works out, that's not, not where you figured it would be. And we've had a conflict with this is a toilet likely. It's got to go here, it's got to go here. So yeah, hopefully the inspector would have noted this and said, hey, you got to add another joist, or there needs to be a repair of some sort. But a lot of stuff gets done through renovations, and maybe there's no permits or inspections and people just decide to do something. There's just kind of a curious little drop beam back here, which looks to me like this was a renovation of some sort. Can't say for sure, but we have actual diagonal board flooring on here, which isn't something you see a whole bunch, and it's newer, shinier stuff. So I wonder, this might have been just kind of maybe late 70s, early 80s when we were getting away from this type of flooring more into the plywood. But things to watch out for sure. Mechanical penetrations can cause a lot of grief to a house.
When you guys come across the joist embedded into the foundation, whether it's support beam or the joist, just check for rot, just probe away, and of course any sort of watermarks.
Yeah, that's for sure. Yeah, like you saw in the previous one, if it has it starts to migrate out usually, right, and it's you get those signs, but they can be quite fine. And it's still accepted in the code. I believe there is a provision in there to do this. So don't see it too much anymore. It's pretty labor intensive, you can imagine. Poor end bearing. Yeah, this is shitty. Maybe this is a landing or something that's probably dropped, and you can end nail into here like this. I think it's like 4 or 3.5 inch nails or whatever, but or have this member here one sized up and put a little ledger under it, or hangers are the actual thing to do. But you can actually end nail this joist into this header joist. Again, I don't know exactly what's going on here because you got something framed at a 45. But yeah, it's a kind of workmanship. I mean, this is an easy fix. I mean, they could throw a hanger on here, and especially high traffic areas, you only got a couple nails in here. It might not fall down, but it's something that's going to move over time, pretty much for sure. Poor workmanship, I call that. Poor end bearing, sure. Yeah, twisted joists. I don't know, what, it's not right. I mean, I think there's a general requirement in the code. There's kind of a deviation on structural members and something. It's just kind of a vague general requirement that we stay within a couple % of plumb and things like that. So this isn't good. It would be a fail. It's not going to do the job. But I don't know if this is a 40-year-old house and life's been good. Something you'd want to point out. And really, another joist should be added, married up to this one on one side or the other to correct this. Pretty hard to straighten it. Maybe you could. I don't know, depending how it's, everything's built around it, wiring going through it. You got any thoughts, Alex?
Yeah, sure, you bet. So I mean, with the twisted joists, as Brad mentioned a few times, as you guys start getting more experience, you're gonna start being able to date or age a structure. So the image on the right, you can see once again we got the diagonal planks. So I mean, those are typically pre-70s before plywood started coming out. Obviously, it looks like we got some dimensional lumber, right? It looks to be fairly rough cut. So I mean, in this era, generally you didn't have blocking. Obviously, there's no wood eye joist, so a lot of the rotation was due to a lack of blocking, especially because they were typically 24 inches on center, the joist. So blocking never hurts. It helps to stop the squeaking of the floors and, of course, the rotating of the joists.
Right. Yeah, that's stuff you're gonna see. Oh, what the heck? They didn't finish the herringbone. This takes me back. So yeah, this was this was 80s, 90s kind of thing, and I kind of like this setup when it's done right, but these have to be nailed on the bottom. So this works, or blocking. You can put solid blocking in here. You don't see this, man. I haven't seen herring. This is called herringbone bridging, is what it used to be called. So when the framer comes and he puts his floor joists in, they have to nail these before the subfloor goes on. It's really the only way. So the framer will run across this floor system before the plywood's down and secure this herringbone at the top. Then they'll put their sheeting on, but then someone has to remember to come back and nail the bottoms. And yeah, this is not uncommon. It wasn't uncommon years ago, but it just may have got forgot or whatever. The house gets built, the guy's on to the next job, or one guy starts it, another guy finishes it, and this stuff doesn't get nailed off on the bottom. It's not doing the job. It's not going to prevent the rotation of the bottom of the joist. It stiffens the joist up. So it acts like a little truss that goes across perpendicular to your floor joist. It's pretty good, a pretty solid system. Yeah, it could result in squeaks. I mean, really good framers would put a dab of glue on here when they secure these in. I think 2.5-inch nails or something the code asks for, but it could be stapled. There isn't a lot of stress or pressure on here really, and the way they're built, it doesn't take much to get them to do their job because they're usually on a very low angle, 30 degrees or so. So they're not going to move, but they got to be fastened or they're not doing nothing. So yeah, no, this would be definitely an item to identify as deficiency or incomplete work. And it does take the balance out of the floor and strengthen it up. Excessive notching. Yeah, well, this has produced the ability for this floor joist to work as well. So obviously, this isn't going to work. I don't know how you make this work or fix it now. You need that 1.5 inch of bearing, or you can end nail into a ledger. Like I say, I think it's 4 long spikes. We don't have it here. So I don't know, there'd have to be some sort of repair to this or something. But yeah, you've diminished this. This is really, instead of having a 2x6 or 8 or whatever it's supposed to be, it's really acting closer to a 2x4. It's not great. Yeah, and that's just not doing nothing anymore. That guy, he's totally useless. Probably good they got boards for a floor system up here because it's probably doing all the work. So this should be fairly obvious that it's a fail. This guy isn't making it. Yeah, here we go. Here's a diagram. So yeah, 1/4 of the joist depth, 2 inches in each way. And I think there's another parameter in there that I'd have to look in the code book and see exactly how far this hole is from the bearing point towards the center. I think there's a limitation on that as well. But I mean, if you were to follow these, a 2-inch hole, 1/4 depth joist, that's going to be fine. I think in 99% of the times, should be good. And you have to have it. I mean, you're going to run wiring. There's going to be some plumbing going through there, so shouldn't be too bad. Oh, again, we got a mechanical issue here. This looks like a B vent. This is even worse. So somebody's really not thinking. So this was, yeah, this is a fail. I mean, depending on the span here, this could be headed off maybe and tied in, or an additional joist provided or something. But yeah, it's just a no-no. I mean, these are things that, should yell at you if you see joists cut right through like that. That's not good. Cracked joist. Well, this one worries me a little because what caused this situation, but don't know the history here as well, but it looks like somebody's taken and put a temporary support under here to kind of hold it. It's kind of near the bearing point too, which is kind of odd, but it could have been anything. It could have been substandard product when it went in. The framer didn't really examine the lumber as well as he could have and put something in that was kind of crappy, and you get a good load above up on the floor, and who knows why or what or where, but yeah, it's something to watch out for. Oh, knockouts. Yeah, here we go. Yeah, these engineered systems, and I mean, it wouldn't hurt. Like what I do myself is I have printed off some of the hole cutting guidelines from the couple of the different manufacturers, just to have them in your toolbox, if you will, or your truck or whatever. And when you go out, and because they're all a little bit different, like I say, sometimes you can go pretty much flange to flange. And then, if you look at they're proprietary, so every eye joist might have slightly different guides. And then they might say, okay, you can do another hole, but it's got to be at least twice this diameter over, or you got to check and see what the guides are. But I think what they're kind of saying here is, say you're allowed a hole like this, there's no harm in putting 3 smaller ones in that same kind of thing, or a square. And so the thinking, if you talk to the eye joist people, we look back a picture or two and we're saying, oh my God, you get a 2-inch hole in a 2x10, and that's like solid wood. And now you got this plywood thing, and we're going to cut a hole like this in there. Well, they're looking at this as more of like actually kind of as a floor truss. It's an eye joist, but it's the thinking is that the plywood is acting like webs. So I mean, their strength is being transferred. Like if you can imagine there being a diagonal web here, a diagonal web going up here, diagonal web going down here. So if we had all these little webs in here, pretend they were 2x2s or whatever, we essentially build the truss, which is going to hold the the joist will be able to perform as expected. So what they're saying is if you can sort of plant these holes that you're not screwing up with the web configuration, whoops, it's going to work fine. So it's kind of hard to get your head around because, you know, I look at some places and they'll have quite a few holes, but they'll meet that hole cutting guideline. So it's going to work. They're good product. It's a pretty well built thing. Yeah, it does come down a lot to the you know, the glue they use in here and all this kind of stuff and these webs. So it's just a kind of superior structural product than a 2x10. Although you look at it and you think it's kind of crap, right? Because it's OSB and a couple little cords, but they have some value structurally. Not so good in fire, but that's another story for another day.
I'll make a quick note. So yeah, we're going to see all the areas where they are prohibited, the notches. But it's actually the webbing that provides the structural support, like Brad was saying, right? So a lot of folks think is the flanges, the top and bottom, which should not be altered, but just some information for you.
Yeah, and they're very popular. Oh, so these have been the pink. Yeah, the pink has got a fire. It's usually an indication that it's been fire treated, and we haven't, not that I'm aware of, pushed for that in Alberta. I think down east there are some jurisdictions that's a requirement, and the concern being that they don't perform well in fire. A good old 2x10 or what have you, big solid piece of lumber. And this is kind of where you might think the opposite again. It's like, well, that's a lot of wood there. It's going to burn. Well, it will, and it's got more energy in it as far as the, you know, the combustible content of a 2x10 versus an I-joist, but it takes a long time. You know, if you can imagine taking a tiger torch or something and putting it up to a 2x10, you're going to be there a little while before that thing actually starts to burn. And when it does, it's going to take a long time to burn through, but you get OSB lit up, it burns rather quickly. And of course, like any kind of structural member with any webbing in it or whatever, if there's any weight on it, it fails quickly. So I know there were some jurisdictions down east that were saying, like, we just want them protected with this pink wood. If the people don't finish their basement, it's not thermally protected, there's no drywall, there is a fire in the basement, much longer time before that floor fails. And it was almost more lobbying was done to protect the firefighters and the occupants, because the hope is that if there's a fire and we have proper detection in the house, the people are out, right? Like they should be out theoretically, you know, rather quickly, within minutes kind of thing. Then the fire guys show up while they run into the house and the floor collapses. So there was a push to have this pink wood. I don't know if I've actually seen this very much in Alberta, or have you guys seen it, Alex, around much, any of these pink joists? Or
Yeah, you bet. I would say it's more in the bigger cities, Edmonton and Calgary. It's not a very common thing, but you know, maybe one out of a couple hundred inspections you may come across it.
yeah, and it might even be just an owner preference or something, like the builder might give it as an option. If you know, you get some clients, if Tony wants to buy a house and they're like, oh, I heard these I-joists are bad in fire. Well, we can give you these pink wood I-joists, and they're like, okay. So, but I don't think it's being mandated to my knowledge, but it's out there. You'll see some of this type of pink treated product on the exterior of houses too. But that's kind of another story for another day. And that's to deal with house to house fire spread and stuff like that. So if you go around some of the subdivisions and there might be concerns due to the distance between the houses or fire response time and stuff like that. But again, not something you would likely see doing an inspection, real estate or whatever. Okay, here's some no-nos. Yeah, I can look over to the right here. Yeah, you shouldn't be messing with those flanges. That's not right. Yeah, and your hole should be a hole. It shouldn't carry on. It should be defined around the perimeter of the edge. You know, you just like anything, you start a crack, it's going to carry on possibly. Not sure why all this blocking went in here. Must be some no-nos here. I can't quite tell from my picture, but
yeah, I can speak to that. So the image, right? So yeah, those four images were primarily, it's just, well, three of them are showing notches to the flanges, which again are no-nos. The bottom right depiction on the image on the right just talks about overcutting corners, right? So like Brad said, typically you want to just cut out what is required and no more. And the image on the left is just talking about repairs. So obviously this was done on site by someone that was not likely informed by the manufacturer what the proper repair schedule is. But anytime within engineered systems, whether it's floor trusses, wood eye joists, or roof trusses, any repairs that are done should be specified by the manufacturer or possibly an engineer, and they will say this is the actual repair schedule that must be followed. This is an unskilled repair, in my opinion, on the left.
Yeah, no, that's a fair comment. I mean, so if you do see a repair, it doesn't mean that it's a fail, because we'll come across them, right, as an SEO, and we'll see something like this, and we'll say, okay, get back to your supplier, provide a repair detail, and they'll whip something up on their computer or whatever, draw it up, and the framer will come back or whoever. But usually it involves more like a plywood, horizontal on each side, ones I've seen, and they'll want some blocking, maybe both sides they put plywood, or this one might be beyond repair just because they've taken that flange right out. I don't know, but you may see a repair detail, and it doesn't mean it's a fail. But this, this one here causes raises my eyebrows. Same with trusses. We'll have damaged trusses, and we'll get repair details from the truss manufacturer. Yeah, this is just someone needs a slap over here. I think someone looks like they just took a hammer and started beating the sawzall and really messing things up. So I don't know. Again, I can't quite see what's going on here. Maybe it's close to the outside wall, and they've just added some extra 2x4s or something like that. I'm not sure, but yeah, no, that whole cutting guideline. I mean, it needs to be followed, and that's just what we call wood butchery. Not very good. Yeah, notch flange again. Yeah, this is something we see to get that toilet in there. Toilets seem to be the tough one. Most of these guys, when they supply the floors, the smarter ones anyways, they'll have that toilet identified on their floor drawing. And if the framer, because they don't want to do this kind of thing, and the framer follows the drawings accordingly, we shouldn't have this conflict, but things happen. Oh yeah, oh whoopsie, missing hanger over here. There is a hanger going from this little LVL header they got across here. And so the guy looked at it and he said, well, I'm not going to be able to get hangnails in here, so we'll just call it a day. But no, that's not right. They need to get that hanger in there, or correct that however they have to. And a good thing to check too, that they have all the nails right in the hanger nails. You guys probably been through that, and that they're actually using hanger nails and not deck screws or something like that. There's been a movement towards structural screws now, like Simpsons, the hanger people have put together or are selling these structural screws, which are fine. But a flag for an inspector is when you go and they've stuck a bunch of deck screws in here because they just don't have the shear strength that an actual hanger nail. It's a fairly heavy gauge nail. They make the hanger nails. They have guns for them now, air guns, like everything. So, I mean, you look at it, you think, oh my God, they got to put 15 nails on some of these hangers are pretty heavy duty with the nailing, but those guys can knock those off pretty quick with these guns. But there are, in the structural screws, you can usually tell they got a little hexagon head on them. They're usually silver with a little hexagon, which will differentiate them from like a deck screw with a Robertson head or something like that. These guys came back a bit here in the last year or two with the cost of lumber and OSB. The I-joist guys weren't able to get plywood, so they couldn't make I-joist. So all of a sudden builders were throwing these back in, and depending where you are in the province, I'm noticing southern Alberta, these are kind of held some market share, but they were pretty much extinct in central Alberta. You get some pretty big spans out of these. So this is a floor truss, really is what it is. And going back to our kind of a comparison to the I-joists, you could just sort of envision how this works. It's very strong. These guys are in compression. This guy's in tension. This is being supported. These guys are pushing this up. So really, we've got a 2x4 top cord that's spanning this little 3 or 4 foot span, which isn't very much, and quite strong, very good. Advantages are they can run often. They'll run spiral ductwork through here, so you don't have to put bulkheads in for your ductwork. Big spans. Seen these guys go right across a basement. No beams. Not a bad system. I think they were quite a bit more expensive than the good old I-joist, but I think, like I say, in the last couple of years, when the lumber prices all got jockeyed around, they came back into being competitive. Top hung, yeah, that's fine. Same idea, just a different orientation for the chords, right? So these guys are up and down and these guys are on the flat, but I mean, these are engineered systems. They basically do the same thing, just designed a little differently. My preference would be these guys. Just, I don't know why, you get more bearing for your plywood, and I think a little better to work with, a little more lateral strength as well. There will be bracing requirements for these, not like a floor system. Like now, if like a 2x10 floor, you have to have blocking or herringbone bracing or strapping every 7 feet on center. So if you had a 14-foot 2x10, you'd have to put a row of blocking or strapping in the middle of that 7 feet. These guys will, you have to fall back on the engineer's requirements. So there's something been put in here. I'm guessing it's probably something the engineers asked for on the drawing. You know, same thing, might be every 7 feet or 10 feet. These guys, when they're like on the flat like this, often the bracing is a horizontal 2x6 or a vertical 2x6. And usually they run 1 or 2 of those in the middle. But again, it all comes back to the drawings. If you don't see any bracing and it's like this, you probably got to say, hey, wait a second, that doesn't seem quite right. But there isn't really a general rule to apply. You got to fall back on those engineered details. Good old lumber. Yeah, this was very popular for many, many years. Maybe this was some recycled formwork. I don't know. It's got that feel to it. Hard to say, but nothing wrong with it. Strong, does the job. Plywood, hopefully, preferably T&G plywood is what this doesn't look like T&G, but very common forms of flooring. OSB, I'm sure they should have a slide on that. Here we go. Yeah, kind of different names, similar product. Wafer board, flake board, particle board. Kind of the code word is OSB, oriented strand board.
Yeah, we'll have a slide of OSB. Yeah, there you go.
Oh, okay. Yeah, this is what you'll see typically. And these will have this. I don't think I've seen around very much on a, maybe for a, you know, like a floor under to act as an intermediary between you know, sheet vinyl or something like that as an underlayment, so to speak, as opposed to a subfloor. Now you guys have probably seen lots as well. It'll either be boards or plywood, or I'll just use the term OSB, I think are the 3 big ones. And I think they're all just fine. Sometimes they're labeled upside up, upside down kind of thing. And I've actually come across a house where the framer put it all upside down. And then I called the manufacturer and they're like, well, it's not that big a deal. I said, well, why do you have it labeled? Well, he says it'll do the job either way, but it's, you know, it's somewhat preferable to follow the rules. So the will says right on there, this side down, and the guy put it all opposite. So I don't know what was going on there. The groove and the tongue are a little bit different offset, I think. Stick frame wall system weight transfer. Yeah. Okay. Well, this just gives a good basic details for how the structure of a house is supposed to work or building supposed to work. So, yeah, we're getting down to the soil. Obviously, that's number one. Some good undisturbed, moisture-free soil onto a wall or a load-bearing wall, or this could be a post and beam, and up to the roof, which mostly, you know, we have engineered trusses, but yeah, we could have stick framed roofs still that are counting on there being an interior load-bearing wall or whatever. And I know that's something we look at when there's renovations or people want to start ripping open their, you know, the main floor and making nice big wide open kitchens and getting rid of interior walls. We'll want to poke our heads up there and see if it's a clear span truss. You know, life's pretty good, but if it is stick framed, then we might have to look at adding some beams or whatever to replace those load-bearing walls. Brick, yeah, I don't know. That's again older day type stuff, but it is out there. You can actually build your walls with brick. I don't know if we see a bunch of those. Concrete block, not so much probably in residential, but there are some industrial buildings and definitely some commercial buildings where you had fire considerations, like, you know, on the main street in most towns, you have to have some sort of non-combustible construction. So you'll still see concrete blocks or cinder block walls being built, or not so much structural, but firewalls in buildings made out of concrete or cinder block. what do we got here? Masonry veneer wall. Oh, okay. So yeah, this is an example of a wall that would be. I gotta get rid of this top thing up here. It's messing me up. Okay. Any rate, so typical stud framed wall, wall sheathing. What are they showing in here? Interior, ladder joints, civil joints. So this is just kind of a detail of some common construction. Yeah, this rigid insulation they've shown on the bottom, this is a mandatory thing. Really what we have to have is we have to have some sort of a air vapor barrier, right, on the warm side. And there should be a moisture barrier on the outside. They're calling it a sheathing membrane, which is same thing. So this could be, you know, black paper. It could be a Tyvek type product or a house wrap type product, something like that. Airspace. So again, something you can't see, but there should be here the brick ties, yeah, and weep holes. No, this is a good detail for a veneer wall. You might see rather than the foundation detail like this, you might see brick angle. So there may have been, you know, a 4x4, 4x6 or whatever angle iron that's been bolted through the wall. We used to do a lot of work on schools and stuff, and that was a very common detail. We'd have these brick angles that had to be bolted in and to support this brick that's going up. And then of course there's additional details that if you go over windows and things like that. But this is a good overview of what it should look like. Weep holes are important. If you don't see those, that's a problem. Moisture will and can get in there. It needs to get out. If it doesn't, it can accumulate. And then if you get through a frost cycle, you could have problems with the frost blowing the bricks out. And there's some, okay, there we go. There's a window where they put an angle iron. This is support over top of the window. And they've went with some vertical ones here. Just, I think that's probably more of an architectural thing. And then, yeah, this is just what I was talking about. They've got an angle on the wall, which is an acceptable way to do things, installed correctly. Wood walls, pretty straightforward stuff. These get called all kinds of things. They've got all kinds of different names. Some guys will call this the cripple. Some guys call these the cripple. Everybody pretty much calls this a header or lintel. The trimmer, some guys will call this inside one the trimmer. Everybody's got a different name. Point being though, you need a continuous stud on each side of an opening, and we'll have this trimmer in here is what's going to provide the support for your header. And usually one of these is suffice for most window openings. If you get an opening, a fairly big window or something, I think it's over 3 meters. At that point, we have to double these up. So 1.5 inches of bearing for these headers is fine, up to openings 3 meters or about 10 feet wide, at which time we have to double and provide 3 inches of bearing. Shouldn't be any splices in these. These should be continuous. Yeah, you get an idea what's going on. Again, it's all about transferring the loads down to the foundation. So we have an opening. We're now deviating from our stud spacing. We need to get that load carried at the top plate. So we have a header and some extra construction goes in here to pick up that load. Double top plate, very common. Don't have to. The code does allow for a single top plate, but then anything that's sitting on there better be like as far as a floor joist or a roof truss or rafter has to be within 2 inches of this stud below. But 99% of people, probably 99.9, are doing double top plates. And these studs are all pre-manufactured lengths, right? If you go to the lumberyard and buy them, they're usually 92 5/8 for an 8-foot wall, for example. So when you put 3 plates together, you get, 8'1" or whatever. So it allows for drywall ceiling and, a little bit of room on the floor, and then 2 4-foot full sheets of drywall on the edge. So straightforward stuff. Yeah, same with floor joists. There are limitations on drilling holes through studs as well. Now, I guess the question comes, how big a deal is it if it's not load bearing? Well, it's not as big a deal as if it's load bearing, but I'm hoping there's a table up here. I don't think we should be more than 1/3 of the, or what is it now? There's a guide or a table. I don't have it right in my head right now. This is looking like too much again to be cutting through a 2x4. So I mean, in a perfect world, this would have been a 2x6 wall, and that's what you'll usually see if there's going to be plumbing in a wall. The framer house builder will do a 2x6 wall, knowing that there's going to have to be some holes in it. Something to watch out for. Oh, party wall. So I'm not sure, Alex, what we're looking at exactly, or what is this?
Yeah, just basically a couple of different depictions of some party walls, so fire retardant walls. These are obviously masonry based, so it's not as common. And maybe out east you might see some more of the brick party walls, but you may come across concrete block party walls. So that's just typically a separation between two or more dwellings. So if you have a duplex or a quadplex or fourplex, what have you, you may come across masonry party walls, or you may see some wood ones, which I think we're going to be seeing in the next slide. Keep in mind, in some older structures, so if you're inspecting a fourplex or a quadplex built 70s or older, they may not even have any party walls there. So I mean, that's obviously a bit of a concern, not only from fire separation aspect, because now if you have a fire starting in one of the units in an attic space or one of the units, it can transfer quite quickly to the other units. But of course, safety as well, right? If you have no separation between the 4 units, 3 units, whatever it is, it's pretty simple to enter someone's dwelling through an attic hatch. Not that I'm giving ideas, but.
Yeah, no, that's right. Yeah, it's so this would be a duplex or a row house type situation or something like that. Fair enough. Yeah, this is more what we see here. We'll have a fire rated drywall, and yeah, so when we do get in those situations with the duplexes or fourplexes and they're side by side, because there's also configurations where you can have above and below different suites. But if just as a good example, just a side by side duplex, you should have well, that's not cool, but this is what you would expect to see in the attic, is that you do have fire rated drywall. Has to be on both sides. Anytime you do a fire separation. Now you might see in some attics, not to get off track too much here, but there is also requirements for smoke stops. And those are bigger buildings and usually commercial buildings. And those are just like every 300 square meters, you have to put what's called a smoke stop. And that would only be like one layer on one side. And that's just a code requirement that if a fire got up an attic, it'll slow it down enough that, hopefully the fire people can get there and, save most of the building kind of thing. But if we have a duplex or anything like that, a residential side by side or anything with a common attic, we need to fire rate that party wall up and through the attic to the underside of the roof. And it has to be fire taped. Sometimes, and I didn't have a problem with it, if they wanted to put another strip of 5/8 drywall again over top of a joint, I mean, to me, that gives you as much protection as a 1/8 piece of paper with a little bit of mud on it. But the joints have to be either taped or sealed or properly dealt with as well, because it has to be continuous element there. So yeah, if you get a fire in the one unit, it should take a good long time to get over to the neighbors. And yeah, it'll be rated type X. That's right. You might be able to see this in an attic if it's not, it won't be painted up there, obviously. Hard to tell on the main floor, but we have to assume that was done right. But no, good point. Not too much more. Steel stud. Okay. Yeah, this not a bunch of this, I don't think, in residential you don't see, but this is a little more found in commercial projects. Yeah, it's a good system. I mean, these things are straight, lightweight, cost effective. They have some limitations, like when it comes to the wiring and stuff, usually you have to run the BX. There's, we can't, or you put grommets through the, here are these bushings. Yeah. There's a little bit extra work like that. Framing in around doors and things like that. You usually have to line the openings with wood anyways, because it's pretty hard to screw a door frame to these steel studs. They're not great that way, but they'll support drywall and act as a partition all day long. They're also great and acceptable in fire separations and things like that. Yeah, you might come across them. Won't rot. I mean, yeah, they've a lot more pretty prevalent in commercial construction. You'll see this more. And there are some buildings, bigger buildings, that are required to be of non-combustible construction. like, I mean, hospitals and things like that, where you have to use steel studs. Wall sheathing. Okay, well, yeah, it's important to, I guess, note that it has to be graded. I mean, this is maybe the point of this. Here's this side down. Yeah, this is my guy. And you go out there and you look at it and you see this staring at you while you're standing on the floor. We did manage to clear that one, maybe because it was maybe oversized too, but I mean, oh, this is be exterior sheeting though as well. So this would be your roof sheeting or something like that, or your exterior wall sheeting. So it gives you the orientation, how it's supposed to be installed with the, these studs obviously going perpendicular, usually to the direction of the framing members. Not much to talk about on this. You should have a gap in here. I don't know if we get to that or not. I mean, stuff that you're not going to see after the house is built. And that is to allow for the wall cavity to breathe a little bit. You're not supposed to be putting these sheets tight on the horizontal joints. Vertically, no problem. You pretty much have to, because everything is 8-foot lengths and 16 or 2-foot centers. So you can't be putting gaps there. But these horizontal joints, they need to have a little bit of a gap in there to allow the wall cavity to breathe. Yeah, CSA approved, installed as per the manufacturer. There are, code requirements for the nailing, stapling or nailing the amount of nails around the perimeter and in the middle. I don't think you'll ever have that come up or have to see it. It is a little more of an issue. We get into high wind areas. There's actually the code got a little more sticky on some of that, wanting a few more nails put in and stuff if you're expecting wind loads, but those aren't things you're going to see in an after the fact inspection. Pretty straightforward. Yeah, there's all kinds of roofs here: shed, gable, gambrel, yeah, mansard, hip, flat, shed. Yeah, just terminology, I guess, to be familiar with. I would agree with all these words, I think, is stuff we use. Again, depending what part of the country you're in, some people use different terms, but yeah, gambrel, some people call it a barn roof, but no, that's the proper name. So hip roof, everything goes into the corners. Flat, I mean, there's no real true flat roof. It's got a slope somewhere, but you get the idea. It doesn't have a pronounced slope like a shed roof. These mansard ones, yeah, we don't see those much. Conventional roof framing. Yeah, this is what we call stick framing or conventional roof framing. So this is where somebody would basically stick frame the roof. So instead of getting a nice engineered truss, manufactured truss, you just throw it up there and put it in place. You actually start off, depending on the roof, you may need a ridge beam put in here, and then you have to physically calculate these cuts, usually 412, 312 is pretty common. 5, 6, 12 could be a thing. Proper way is to do the bird's mouth. You notch it so you get proper bearing on the outside walls. So what I would watch out for on this type of roof, though, is depending how thorough you are with your inspection, if they try to do a roof like this with a vault, what's going to change is the ridge beam. So this ridge board, if you've got a ceiling in here, the ceiling is going to hold these walls together. So it's going to structurally keep the walls from wanting to blow out. So this ridge beam is more just there to support the plywood. So that's going to keep these walls from going out. And when these rafters go up to this point, they're darn strong, because this is considered fixed. And these guys can't go down because it means the wall has to go out. But if someone tries to do an addition or something and they want the vaulted ceiling look, then this ridge beam needs to carry the load, because the walls can't. Because if you get load down on here now, it's going to push down, and when it pushes down, it pushes out. We don't have a ceiling in here in a vaulted ceiling situation. So to keep the bad things from happening, this bridge board has to be sized accordingly, and actually has to be more like a beam. And I come across this quite a bit, people doing a little addition, or they want to do a little sunroom off the back of the house or something. And not a problem, you just have to make them aware of that. And they're thinking, well, I'll put a ridge board up here and away we go. No, now you need something, maybe an LVL or whatever. It has to be sized accordingly to make sure these walls don't blow out. You can do, and there's an engineering guide Canadian Wood Council has out. It's kind of a collar tie scenario where you can put a horizontal member about halfway up here, and it can be act in lieu of having this guy down here. They've got a bit of a formula and it takes about 1,000,000 nails, but the idea is the same thing. Essentially, at that point, you're building a little truss. So I guess my takeaway is that if you've got a ceiling in here, you really don't need much of a ridge beam, as long as these rafters are the right size, which they can go quite far. Like a 2x6 can usually go about 12 feet at 2 feet on center. There's tables you can find to figure that out. If they want to do a vault, this ridge beam becomes important. So I don't know, that's my yak on that. Yeah, so okay, this is kind of just expanding a little more on what we were talking about. Stick framed again, this will be older house situation. The nice thing in this case, so we do have a ceiling in here, so it's going to tie these walls together. So this ridge board can be a board, doesn't need to be a beam because it's these fixed points. And what's nice here now, they put these collar ties in. These aren't mandatory, but what the collar tie will do, and this is still in the code, it'll essentially double the allowable span of your rafter. So what they're saying when you put this collar tie in is I'm going to put weight on this side, but guess what? It's going to want to push over here and push up on this side. And what's that weight going to be? Well, it's going to be snow. So if I got snow here, I'm going to have snow here. So it acts like a little truss. So let's say a 2x4 could go, say, only 8 feet at 2 feet on center. So this can only be 8 feet long. Otherwise, it should be a 2x6. Well, if I got a collar tie going across here, I'm fine. If I got, say, 7 feet and 7 feet above, that collar tie is giving me that strength I need. So a little bit of tricky stuff. I don't know how far you want to get into it, but and it all does make sense if you kind of take a step back and look at it. This one here looks even like they've gone an extra step here. It looks like they may have added some diagonal bracing in here. This looks like a really heavy duty roof, you know, maybe down to an interior wall. Not sure why these are here. That's good. It's strong. I guess the point being, if you got a ceiling, just make sure that your rafters meet the span requirements. If it looks like they're pushing it, a collar tie might help to correct it. And sometimes my parents' house, it was an old house, never fell down, but I went and looked at it and thought, it's not quite right. So I was able to go up there and just put some collar ties in. Cheap, easy thing to do, and you know, a little bit of peace of mind. But ceilings and flat roofs, in-nail ridge board. So I'm just trying to see what we're, okay, so this is where I don't think they've got a ridge beam in this situation. So someone's put a cleat across here, which might not be the most desirable, but I mean, the roofing is all boards. It's probably going to be okay. I don't know. Is there something I should know more on this one, Alex? Or
No, it's just talking about the two different styles of doing your stick framing for a roofing system. So you got the ridge board on the right, connecting the
right.
Joist, yeah, the rafters.
Yeah. I mean, they're both going to work, and I think they'll be structurally sound. You know, this is just personally nicer. And then ridge board, they got collar ties in here. You know, this doesn't look too bad at all. Lateral bracing. Yeah, so let's maybe chew on this slide for a second. They a lot of this is going to come back to what the supplier or the manufacturer supplier, I guess is the proper term, of the trusses are. So, you know, all these truss guides, they run off computer programs, which are engineered programs. And when they get the individual details for the trusses, it'll say on there what kind of bracing is required. And that's, you know, what we do as SEOs. So we will get a set of truss plans, and it's nice when it's a simple house. Sometimes some of these newer homes are got so many different trusses, but lateral bracing, yeah, this is part of the truss design, absolutely correct. So it'll show on the little truss detail. There'll be a little block on there, and there'll be a little note saying, you know, this might be member A to C. Let's say 1x4 lateral bracing required, you know, on this member. So you want to see that's in place. Kind of a rule of thumb, and it's really loose. And I wouldn't quite maybe swear 100% on it, but when these compression members, so anything you've got that's usually that's where the bracing is required. So this guy, because there's going to be snow load coming down on here, he's in compression. There's pressure on him. This ridge is considered kind of fixed because our walls are tied together. this is going to have a hard time going down. He's not going to be able to go down. He can't, because if he tries to go down, only if these walls go out. So this becomes another fixed point. So this is pushing up and this is pushing up. These guys are compression members. This guy here is in tension. So we keep transferring these fixed points, we'll call them, up to here. This is solid. Now this guy is actually being pulled. So he is actually, this is considered fixed reasonably. And now this little fella becomes a compression member because he's tied down here to here. So you can put weight on him and you can put weight on him. And of course the top cord of the truss carries through. So you'll only ever see the bracing on the compression members. I'm not sure why there'd be one there. Yeah, I don't ever see them there. But anyways, they'd be on these compression members. Sometimes the truss drawings will call for T-bracing as opposed to lateral bracing, which would be a 2x4 or 2x6 nailed in a T fashion onto that member. And that's usually more where you got a funky roof that's every truss is a little bit different due to the roof design. So it's impractical or impossible to run a lateral brace across like this. This is easy, right? Like, I mean, they're all the same truss. You go along, you nail this bracing on, but sometimes this guy goes here, this guy comes up at a higher angle, this guy goes up at a higher angle, a little more of a complicated, sophisticated roof. But that's it was really tough as an inspector to know that that has been done proper. On a simple roof, if I'm doing your job and you've got something and it's over 7 feet, there actually is a code thing, compression member over 7 feet, and there's no brace on it, I would flag that and say, I think you need a brace on it. Usually pretty easy fix to do. Like, I mean, the hardest thing is getting lumber in the attic, but not expensive. These are gable bracing, I think is what we got here. And this is something you'll see on the, as a generic truss detail, just about every truss supplier has it. So at least one end on a simple roof, I'll call it, just a gable roof, common trusses all the way across. There should be one of these diagonal braces on each end. And that's just to keep these guys from wanting to sway either way. I think once everything's tied in and the roof is sheathed, but they will on the truss drawings ask that you put a knee brace, some guys call it whatever. Sometimes you'll add another little 2x4 brace on top of these cords more realistically, is what I would do. So if you had a 2x4 sitting on top of these guys, so it's not in the way of the drywall, and then a 45 brace down to that, it makes a little truss on its own, a little L-shaped thing, because this ceiling is tight. This guy has a potential to sway one way or the other, and that brace up there just makes it all that much more stiffer, but it's just some bracing details to be aware of. Yeah, so we're getting into some little more complex stuff here and some stick framing. So don't know if we have to get too wild and crazy on here, but again, it's kind of like a floor. You have a roof system, and we're going to actually put an opening in it, which will be a dormer. And you know, we just have to follow the appropriate span tables, make sure these usually have to be doubled up, double header in there, you know, valley, you got some valley framing in here. It's pretty explanatory stuff. A lot of stuff these days, though, will come out as part of an engineered package. So you might not see stick framing, or it might have most of this is engineered, and then maybe there's some infill framing to do a little bit, but should be fairly self-explanatory. And I mean, you have to go and see if it's a big, huge shed dormer like this. Well, hopefully there's, you know, there's a wall picking up that front of that shed dormer usually, rather than this front end of this shed dormer sitting on top of the roof system, which is going to be a lot of weight. Usually that shed dormer lines up on top of the main floor wall, usually, but
yeah, the schematic on the left there just kind of shows you guys once again, when you have, I guess, different roof profiles, kind of like if you're installing an opening into an exterior wall, like a frame wall, where you'd have the double rafter, the double header and whatnot, right? So it's just kind of give you a bit of understanding that there's quite a bit of process and thought that goes into these little projections here, obviously for the dormers. And we're going to be just chatting about different styles of dormers here as well. So some can actually be functional dormers for, you know, like an office space or a storage space. Others are just for aesthetics, as we'll see here in the next slide.
yeah, so this, I'm just, yeah, sorry. This is more just architectural is what you're saying? For
Yeah,
looks or what?
aesthetics, you bet.
Yeah, yeah, you'll see the or fake dormers or whatever. I don't see too many with actual windows to the inside like that, but okay, sure. Okay, this is the lookouts you call them, or ladders on the end. Sometimes guys call them or whatever. So there's a couple different ways to do these. Yeah, you might see them notched in. This would usually be this section where I'm circling here would normally be a truss. And, you know, this is okay. The Cadillac way is what we call a drop truss or drop gable, which would be more like this. So if you envision this being a truss, the truss guy, you put a little more extra care into the truss package, and they have all these trusses coming across, but the gables, they've left them, they've designed them to be 3.5 inches lower. So you can frame these lookouts across here to pick up your fascia. That's a nicer way to do it. This works too. I just find it to be less good. It is kind of nice too if you're doing this because they didn't get a drop gable. If you kind of make these notches in where there's compression members in the gable, but none of it's wrong. Here's a little bit, you can see the notch in there, but you need something. If you go out, and I don't know if you can see this, but it's pretty tough after the fact, but if someone's just nailed a block on over here to here, that's definitely no good. I mean, this thing's going to flop in the wind, you know, unless you had a big heavy duty ridge that went out to the front and this acted as its own little rafter. But no, those are fair examples how to do that. Now we're back into the truss again here. So yeah, I guess I'm kind of getting ahead of things here, but this was what we talked about earlier, being a compression member versus a tension web, right? So kind of talked about this already. I don't know if we need to revisit it, but very simple. This used to be called the W truss, right? And the ones with king post truss was when they had the post down here and then they went out like that. Very simple, strong, wonderful design. So yeah, so someone's bitched these. I hate to use the word, but they've cut these open to get themselves some storage room up here. They thought that was pretty cool. And definitely a no-no because we're pretty confident these are compression members that they've cut out of here. So, you know, it might not fall down, but, you know, there's definitely a potential for things to move around, ceilings to crack, you know, worst case scenario, an actual failure, which is possible. But yeah, it's a no-no. That needs to be fixed. Split framing. What am I seeing here that I'm missing here? What's going on here, Alex, on this right one? Or is this a damaged truss or something?
Yeah, just a split truss there.
Okay.
It's right
Yeah,
above.
and that can happen, right? And again, often these things can be fixed fairly easily with, you know, repair detail from the supplier. Yeah, that's concerning because that tells me that wasn't made in a plant. You can buy these gang nails, they call them, and you can make your own trusses and do things like that. But I think I could be maybe not 100% correct, but I'm pretty sure to be actually certified as a truss manufacturer, part of their quality management plan and their protocols. They have to apply X amount of force on these when they connect them. There are some controls in place to make sure these gang nails are in good. Possibly this could have been something that came loose during transportation, but I'm sort of wondering if this wasn't a homemade thing, which will work if they install them correctly. But yeah, it's a scary thing. They're doing a lot of work, these gang nails. And you think, well, what a crappy little piece of thin metal. But when they get into those connection points on the trusses, there is a lot of force. These guys here do a lot of work, especially these tension ones. There's a lot of pull on this gang nail here. So it's quite amazing what they do. So you might see a homemade truss or something and they put a plywood gusset over here and they put some nails in it. Not uncommon to see a homemade truss, older buildings or garages or whatever. And they work. But from my understanding, these little pieces of tin on here are about 10 times stronger than the plywood truss. Plywood truss or gusset, sorry, will do the job, but the gang nail is shown to be superior. More damage, yeah, needs some fixing up here. Yeah, something happened here, some damaged sheeting or something. Someone just blew over it with some paper and kept going. Decks. Oh, we're jumping over to decks. Well, there's a bunch of stuff on decks to be paying attention to. This could be its own presentation. But I mean, really, it's just an extension. It's another floor that's outside the house. So similar concept. We have to have a foundation. Column is usually involved, beam, and joist, and then flooring. So one thing that, we look for on our end of it as safety code officers is that connection to the house, whether it be to a ledger board, which is pretty common. And one big thing is having the continuity of the moisture barrier, the building paper or house wrap or whatever behind that. You see problems often with people deciding they want to put a deck on after the fact, and they'll they'll rip a little bit of siding off, and they'll just screw something on the onto the rim ply or rim joist of the house or whatever, not really have that continuity of the water barrier behind there, and then it ends up being a rot spot kind of thing. So I don't know how far you want to go into all these here, Alex. I mean, a lot of this stuff is, at the 900 millimeter. I guess a point to know on this, in the last code that came out, the old National Building Code, they call it now, of Alberta Edition, 2019, we never used to be able to allow these, what do they call them, balusters in here, spindles, whatever you want to call them. The 4-inch opening is still in play, but it was always a no-no to have these, what they call climbable. So essentially no horizontal rails, and or more on the inside where some of the ornate designs would incorporate acorns and little circles or spindles or whatever, some sort of architectural detail that you could get a toe hold on, I guess, to keep kids from climbing them and jumping over. But they did a big 180 in the last code run. I don't know who lobbied for it or how it came in, and they just got rid of it. So now you can have horizontal rails on your house. So it's an interesting twist. I don't really have an opinion on it either way. I mean, you watch TV and you see a lot of places in the States where they got, high tension cables and fancy places doing the rail. Still have to have the 4-inch opening, but if it's climbable or the design is such that you could put a foot hold on there, as long as the openings aren't over that 4 inches, apparently to keep a child from getting his head stuck in there, it would be deemed compliant. Shouldn't be a problem. So
yeah, I would like to spend just a bit of time on this.
Yeah,
because the decks, when it comes to structural structures or structures that require some thought, decks are probably the biggest area of concerns. Just because a lot of homeowners, they'll go watch HGTV and they'll think they're the next like home. So I mean, I can definitely chat about this if you like. Now, this is also, of course, jurisdiction dependent, because some areas will have more stringent or less stringent requirements. But generally, again, we start off with the footing. So typically, depending on your area, again, you want to go below the frost line, unless of course you have a certain type of granule bottom base, or I should say, for the post. Some areas will also allow concrete blocks to be used, as long as you have, again, like a 2 foot by 2 foot concrete pad that would actually disperse the weight of the block. This is, again, of course, for decks over 2 feet in height or that have more than 3 risers, as you can see at the bottom there. So, and then like Brad mentioned, so a lot of, we're going to see about, probably 5 or 10 pages of defects here, but then you want to start looking at the support posts, making sure that, there is no rot with them. The fasteners for the joist and the ledger board, again, really common issue. So you're going to see a lot of fastener defects coming up here. If you look to the top of the schematic, it actually talks about the guard height requirements, so your handrails and your balusters. So again, typically if it's less than 2 feet from now, I believe the NBCC actually talks about the underside of the joist, while the Alberta Building Code talks to the floor. But again, this is kind of your call. What
I think it's underside for both, I believe. For what are you saying? Sorry, for the what was for the when you need to have a permit or when you need to
protection, the guard protection, the height.
Oh, over 2 feet. No, it's 2 feet to the surface, the walking surface.
Exactly.
Anything over 2 feet. Yeah.
And the NBC actually talks the underside of the joist, not the decking. So that's just a slight variation. But again, as home inspectors, you guys are not required to know these numbers, but again, they're here for your knowledge. So as you can see, if it's below 2 feet, again, underside of the joist or the decking, not required, but you may still want to recommend that the home buyer or potential home buyer install them in case they got young kids, or say there's snow that may cover the near the decking, so someone may not know that there's going to be a ledge. Typically between 2 and 6 feet, 36-inch handrails are required. If you're over that 6-foot mark, 42 inches is required. And then, yeah, we can just kind of burn through some of these defect photos because, again, I think there's like 10, 15 pages.
Just a real, and then the, not to get, some people get confused as well a little bit because the guard height, so if you go inside the house, that 36 is still okay at higher than 1.8 meters or 6 feet, right? So you need the 3-foot high guard basically from 2 to 6 feet. Higher than 6 feet, you have to have the 42-inch, but inside the house, 36 is fine. So you could have an open area to the bottom of your house kind of thing, a 2-story house, and a 36-inch guard would be compliant. They have a different rule inside for some reason. And then when I talk to you about the horizontal guards or the climbable guards, I do think they get back to non-climbable, but I think it's got to be a 12-foot difference between the surface and the ground level. So anyways, just some stuff if you are bored and want to go look up a building code, it's all in there.
Yeah, and then a couple last things as well, just for the guards and the footing. So again, jurisdictional dependent, but some areas will require footings if you have a roof, like a covered deck, or if it's over 600 square feet. So again, just maybe make a call to the municipality, just find out if you can get some building code requirements for decks, just because again, this is a very common area. We're going to spend quite a bit of time looking at defects.
Yeah, so this is the thing too, like, right, so you got a pile, you don't know, is it down on a pad footing, or is it 12 feet down, or is it 2 feet down? And yeah, I know most people have gone to, even for the smaller decks, to get it onto a pad footing below frost. And being that there's a strong likelihood that someone's going to buy the house and they're going to want to close that in, right? So what might be good for what we call a floating deck, or a non-enclosed, or a deck with no roof, and it'll work fine and everything's great, but people will assume that that's a better foundation maybe than what they have. So people are, but again, you guys are going to be looking at stuff that could be how many years old. But yeah, we can get going on defects here for sure. So it's just a rotten cracked beam, I'm guessing here, Alex, or what does?
Yeah, you bet. Just really common rot points throughout the deck, I think, is where these slides start. So typically any members that are horizontal, your beams, your joists, the top of your guards, that is often where you get the snow accumulation, as you can actually see, I think, in this image on the right, and any sort of rainwater. So typically if you're gonna roll up to a house that's 15 years or older and it looks like the fence or the deck, they're original, just be extra mindful, because you're going to find a lot of areas where they just slap 2-3 buckets of paint on it and hope for the best. And you'll see some images here.
Yeah, that's fair. Yeah, more rot, broken balusters. I might just kind of move a little quicker on these because I think they're pretty obvious, right?
Yeah, you bet.
Let me know if you want to slow up on anything. Yeah, ledger boards. Those are all problem spots. Stringers, yeah, there's code requirements we won't get into for that, but it should have 90 millimeters effective depth here. These shouldn't be more than 36 inches apart if there's no riser, stuff like that. But yeah, it's just, and they're a maintenance item. I mean, no matter, if you treat them, and you can even do things not bad, but they have a lifespan. So I'm concerned with sometimes it's like a notch stringer in here. They're nice, they're Cadillac, but again, that's going to create a rot potential there too. I know they're pointing out this here, but as opposed to a notch stringer, right? This looks like it's routed in, which is good interior. I don't like them outside because and especially if you go and buy treated lumber for this and then you notch these in here, you cut out all the treatment unless you retreat it. And it's another place that doesn't breathe, right? These sometimes are better because they can breathe a little bit, but they all can rot. Yeah, well, this is right. You don't know what's down here, and it's at least they used incised lumber, but yeah, not cool. Yeah, we're supposed to go 2 feet on a 2x10 and 16 inches on a 2x8. So, but that is weird too. And they played with that in the code a little bit. It's still a good way to look at it. Because the way the code reads, it's like if it carries a load. So the way that the code kind of was lax on that is that, well, people are saying, well, I was, going to put a wall on there and a roof. I'm not doing nothing but people load, but there really isn't great tables for this, but it's sure good to stick to that, 2 foot with a 2x10, 16 inches with the 2x8, but this is excessive at 40 inches. It's gonna sag. Yeah, that's pretty crappy, not cool. I mean, it might work, but and we come across stuff too sometimes, even where they've put we know they put a pad and pier foundation, say on the rear of a house to take up a deck or whatever, and whatever the math was out, and they'll have a 6x6 post, and it might not be perfectly, like this is pretty shitty, but I mean, if it's a little bit off the post, we kind of usually the rule of thumb is if you got a good 16 square inches of bearing on there, again, you have to kind of site by site, case by case, see how much load it's carrying, but is it worth ripping everything apart in the world if you can confidently say it's going to hold 10,000 pounds, it needs to hold 5. Well, this isn't cool. Should be straightened. Bad. Yeah, what's even going on here? Yeah, so who knows? They got it looks like a chunk of wood under here with or put some money into a hydraulic jack. That's pretty funny. Yeah, some bad joists, damaged joists. Poor connections, yeah. We need to, but there's a nail hole for a hanger, like a place to put a nail. It needs a nail or a hanger nail or a structural screw. Like to see guys. I mean, you can put basically 2 spikes per joist for these ledger boards, but lag bolt is always better. Or GRKs are getting popular now. Those things are awesome. They have really good shear, very strong. Kind of 2 per joist kind of thing was not bad. He's got lag bolts here. That's, that part's good. Oh yeah. Well, this is, you got a Duradeck product on top or something, and they didn't put a drip flashing or something on the outside. So water's found its way back under, caused some rot. Yeah, that's a problem. Deck tears. Yeah, I was going to say floating beams. They should shim that. Poor shims. Yeah. Poor shims, yeah, really poor shims.
So generally, plywood is not a preferred shimming material. Like plywood always be, all those engineered woods generally shouldn't be used outside and aren't really rated for the exterior. Best practice, of course, to cut the lumber to size, but of course things happen. So I mean, steel shims are a good alternative. I mean, wood blocking again, I would recommend pressure treated if they're going to run that way, but I always just prefer steel shims.
Cedar's good. You don't see people doing it, but yeah, riser heights. Yeah, drip flashing. Whoops, none there. Kind of got lazy around the door. Yeah, it shouldn't be more than 8 inches, and they should all be the same. I see this all the time. They go by some, the steel stringers, from the hardware store, and they're fine. But rather than regrade the land around the deck or something like that, they'll have a 6-inch rise on the bottom and a 9 on the top one or whatever. They're supposed to be the same, and no more than 8 inches. It's kind of where we got to be. 4, yeah, too wide. 4 inches is required. Somebody would actually have to build this, which is worse because you can buy these things pre-made and they won't be more than 4. Yeah, handrails, there's always issues there. Yeah, well, see this, well, you can correct me more. Yeah, that's just stupid. Anyways, I don't know why you do that, but that's it's correct. Kind of wonder if they went over an old step or something that was here. I don't know. It looks like maybe somebody's covered over. See that once in a while where they'll have a rotten old concrete step. This isn't that picture, but I've seen where they've just kind of built a wood deck over top of it rather than get rid of the concrete one. Yeah, this is a no-no code-wise. It was for years, and then I don't even know. They kind of went away. Like I think they were making some pre-manufactured blocks, and I think those guys got kind of run out, but they're still around. And then my question, I guess, is if I was from the seat now up 36 inches, they might meet the current codes if these weren't more than 4 inches. But yeah, it's noteworthy.
Question,
Yes.
can you go back a couple of slides?
Yeah. More?
More, one more. Right there. Pretty sure the deck has to be a 4-inch minimum below the door threshold.
I don't think there's a code requirement that'll tell you that. There is some stuff for if the door swings out in a commercial building and you want to avoid having it blocked due to snow and things like that. But I don't know of an article. I'm not saying I know everything, but I mean, we have landings in front of houses and stairs, and usually we try to keep this fairly tight. But I mean, I'll tell you what, I can take a look and see if there's something, and I can send Alex a note about that.
I've always recommended that in this situation that they always keep that area clear, of course, in the wintertime, because a lot of snowbirds, they're gone, and that they'll have a pile of snow there, and then it just melts in the spring and right through the threshold and ruins.
Yeah, it's probably a good idea. I'm not saying it's not a good idea, but I'll have a look and see. I'm pretty sure I don't know if there's a code requirement. It might be a good thing to suggest or, consider, but often the decks are kind of married up to the floor system of the house. So you're kind of limited, unless you reduce the, the depth of your deck joists and things like that. You don't end up being too far down, but not a bad idea. I just don't know if there's a code article that speaks to that, but and then there's products like Duradeck and stuff that have done right can be, basically you could have that threshold sit right on top. But I'll take a look, to be fair, and if we come across something, I'll send it to Alex if that's of value.
Thank you.
Yeah, there's, like I say, some people say, oh, well, code. I said, I don't necessarily want to build the code. It's a minimum set of standards. And it might not fall down or blow up, but I think I want my house a little above code. But yeah, missing handrails, yeah, and guards and incorrect and all that stuff. Again, I guess you could argue if it's not more than 2 feet, do I even need them, right? So those are things to consider. Yeah, this is bad. This is the worst place this could happen. We hear a split, so no good. Not sure how they got this connected in behind here too. Usually there's some sort of plywood's more desirable, which runs right up to backside of this. And looks like I don't know how they got that connected there, but it's something to pay attention to. Poor construction. Interesting, these steel brackets. I've seen some of these, again, off topic a little bit, but some of the builders are using these. I've seen them in garages. Like you talked earlier about worrying about slab cracks and garage slabs and basement slabs and things like that. And some builders are getting a very modified version of this, maybe only down 2 feet and maybe out 6 or 8 feet. And like on single attached garages, I've seen them bolt them inside. I don't care because it's not a building code thing, but you're sticking them in there as some form of insurance against the slab moving around, or they don't want to spend the money on compacting the fill, or and under sidewalks I've seen too as well alongside of a house. They'll bolt them on the garage foundation, smaller version again, just to kind of give them a little more insurance when they pour that sidewalk along the garage going up to the house. It's just kind of a weird thing, but yeah, this is really crappy construction. I think we'd all agree. It's like, what, come on. Improper supports, floating stringer. Yeah, well, yeah, that needs to be fixed up. Yeah, these aren't cool. I mean, it's nice. There's connectors out there. You can, there's T connections and things like that. For Simpson or any kind of framing connectors, you can, if the, again, it's not mandated by the code, but cheap little bit of insurance to install something like that onto a beam to a post connection to keep this rotation from happening, or maybe it was built like that. This guy's totally out to lunch. Oh yeah, well, that's a good point. Yeah, this gets back to this again. No, that's not approved for a joist hanger or roofing nail. No, I don't see a lot of roofing nails. Deck screws is my little pet peeve, but because those things have no shear strength, but it should be a hanger nail, and you can always kind of tell they got a little fat head on them, and You know, they're usually galvanized, dipped in they're galvanized nails. Or those Simpson screws are becoming a little, for the homeowners, right? Because they don't want to bang your thumb too many times, pound those in there. Those screws are good. Ah, yeah, there's my deck screws. Yeah, don't like those. Plus other issues, obviously, with some envelope problems potential coming. More screws. Phillips even, not even, looks like a drywall screw. Huh. That's interesting. That's not doing nothing. Yeah, these are, yeah, I could see you guys could get tied up on some decks, especially home built homeowner ones. Yeah, all bad, bad, and bad. That's messy. Yeah, don't really care for that. You know, if we came out and as an inspector, and again, I'm not saying I would never want to bless anything like this, but I mean, if it's a small span or something, maybe a through bolt or something, or a through bolt, not a lag bolt, but no good. Needs attention. Yeah, you should be the width of the beam, the column. Technically speaking, if you want to be a code purist, I mean, if you look at the building code, columns are supposed to be 6 by 6. The only reference to wood columns is 6 by 6, but I think there's been enough information out there, and the Wood Council's put some stuff out there that, you know, a 4 by 4 post is going to hold tons of weight, but you know, it really should only be holding up a 2-ply beam. More floating beams. More rot. There's that same blue screwdriver. Yeah, risers again, probably a pre-engineered steel riser, stair stringer, sorry. Yeah, that's not cool. Like, I mean, a little bit off maybe, but no. It's nice that if they pour a bigger cap, and that can usually kind of, it's good insurance, but yes, workmanship, that's just crap. Yeah, rot. Huh. Carpet. Yeah, it's terrible outside. Beam separation. Yeah, so here's a splice, right? And again, there are requirements for where these splices are. They're supposed to be at the quarter points, and maybe if you don't want to get into the math of that, because maybe it's a bit of a fuzzy thing, but you know, it doesn't hurt to take a look at these beam runs, because I've been out and I've seen, like, in between the posts, there isn't one member that gets across there. So that's no, but I mean, they spliced it all up, whatever, offset all their splices, but you need to have, you know, just to give you a quick thing, at least half of them required beam members. So if it's a 4-ply beam required, or in this case, a 3-ply, you know, at least half, so 2 have to get across, 1 can splice, and it's supposed to be what they call a quarter points between the columns. There's a little formula, but you know, while you're looking at the decks, like especially homeowners, they're notorious for, you know, having all their splices in between the columns, and yeah, it'll hold. It might hold for a long time, but eventually it's gonna start to say, well, that's definitely done. More rot. Yeah, and here's the thing: most smart people are using treated lumber for their decks, but again, if you're more than that, whatever, 6 inches or 8 inches off the ground, I think it's 6. You don't have to, which I think kind of silly, but this looks pretty light and weird, and who knows what's going on here. It's whatever you found or fell off the truck, maybe. Yeah, you want to, you know, again, work from the ground up, and everything should be loading properly and either sitting on beams or hangered. Well, I don't know if I hate this one, but it probably isn't maybe code compliant, but that might be there after I'm gone, but it's kind of neat. But some funky stuff over here. I don't know what's going on. Mobile homes. Okay, well, this is not pretty. Oh, the end. Was there much, so it's on mobile homes, was there more to talk about on those, Alex? Or
Not a whole ton. So we're gonna be wrapping up here for lunch, guys, in a couple minutes. But this slide is just talking about if you are doing mobile home, modular home inspections. A lot of times the older style units will actually just have wood blocks, which again, some mobile parks, they won't allow concrete piles or steel piles. So I mean, this is obviously the worst situation that you can see, where it's untreated, just simply on earth. You know, one recommendation, if you come across this, will be to tell your clients that, you know, get a concrete pad, if they can't pour footings or install footings, but just get a concrete pad, get a polyethylene sheet or any sort of vapor barrier to mitigate any sort of absorption through the pad into the wood blocks, which of course would be pressure treated, rather than untreated. Because as you can see, what's going to happen is the structure will start to settle and shift and crack.
Yeah, there is actually, as code does reference what is it, the Z240, CSA Z240. Unfortunately, that's not free online, but they have a pretty good, some pretty good information. And maybe, I don't know if you want, I could send Alex some stuff there. There's a couple little detail sheets that are kind of nice on how to do this kind of installation. And there should be poly ground cover. There should be ventilation, on the opposite ends of the unit, kind of like you would a crawl space, 1 in 540 square feet, 1 square foot. Access under there and things like that. And the blocking, I still see it. People still do the wood krebs. You can do the pressure treated wood blocking, and it's allowed. I mean, they're on a frame that's supposed to resist deformation, so it's and tie downs. They've gotten a little stickier on tie downs, so I don't know if you guys are the code's evolved on that, and I think it's ground anchor, like a helix anchor or equivalent. I mean, it's not a problem if you've got screw piles or some sort of foundation below frost where they can tack weld or a U-bolt or something to the frame of the trailer, mobile home, I should say. But I think it's 1 in every 40 feet of trailer frame. So often it'll be 3 anchors on each side. And it used to be limited to the higher wind areas, like more in southern Alberta. And I think that if they've changed that standard now to apply throughout all of Alberta, maybe it's an ass covering thing, but we're having more wind events, in central Alberta and stuff like that. I don't know if I'm going to sit here and say there's trailers blowing all over the place, but I know the insurance companies are asking for it, and I think the standard, the installation standard for mobile homes has now included that as a requirement. So, something to look for if you're called out to look at a mobile home. And love that beam. That looks pretty good. So I guess it's lunchtime, Alex, or what?
Yeah, you bet. So we'll come back, let's just say 22. So it gives you about 35 minutes. And we'll just, if you have any questions, by all means, bring them up here in the chat box. And we'll see you guys in about 35 minutes.
Okay.
Were you saying something there, Brad? You're on mute there. And we may as well get started there, Brad, for the exterior portion.
Yeah, okay.
Were there any questions about the structural module that we discussed from earlier today, guys? Sounds like a no, Brad, so I'll let you take it away there.
Okay, well, I'm not quite familiar with these slides, but this would appear to be a house. And looks like a stucco house, so we'll
we'll just go back to that first slide, so I can definitely speak to it. So this is just talking about the levels, folks. So generally when you do an inspection on the exterior of a structure or a house, just be aware that your proximity to the actual structure is going to reveal various things. So generally, some inspectors may start right up to the structure, to the dwelling, and start looking for small cracks, there's small deficiencies that you cannot see from afar. I'd recommend that you consider at least 2 or 3 different levels: the far, the intermediate, and the close-up. Because obviously, if you're really close to a structure, you're not going to be able to see the possible issues from afar, and vice versa, right? If you're obviously looking from afar, you won't be able to see the close-up deficiencies. One other thing too is, a lot of inspectors, they'll do the exterior, they'll wrap the house once, and of course they'll go on the roof, hopefully. But a good point is to actually retrace your steps backwards, because you may not see things from a certain angle, and until you might come back from a different view. maybe the sun will hit in a certain way, or possibly, if you're busy on your phone, you might get distracted. So having, a couple laps one way and then one a different way around the structure is a good idea. And if it's a very complicated structure like this house, it's got a lot of different things going on, you may even want to do a third lap as well, or again, if you've been really busy on the phone.
Shit. Can you hear me, Alex?
Yeah, I can hear you. Yeah.
Okay, I lost sound there for a second. Sorry. Get my group in a group here.
Yeah, we'll just go to the masonry brick veneer slide. That'd just be the second one there.
Yeah, there we go. All right. Yeah, so I think this was sort of touched on in the structural section, right? A little bit about the airspace, the cavity, I guess, the sheathing membrane. Obviously, weep holes are required. Base flashing. This is one that sits on top of the foundation. But I guess it's pretty obvious on the right. We've got some obstructed weep holes, which isn't good. So that be an area of concern.
Yeah, and with your masonry brick veneer walls, these act as rain screens, guys. So even though we have mortar, we have the brick, water will still get through it, and that's why you want to have that 1 inch space, as you'll see right behind the brick veneer wall, to the actual sheathing and the membrane. Obviously, as inspectors, you won't be able to actually see the design of this, but the schematic shows you what good building practice is. So again, you have your wall sheathing, you have your sheathing membrane, whether it's roofing paper or the house wrap. You want to make sure that when it was installed, hopefully they actually draped it over the flashing, which you'll see will drain out of the bottom. And that 1 inch airspace in the back allows any water or any moisture that has actually permeated through the brick and the mortar to actually drain out. So as you can see, you will come across brick veneer walls where the homeowners, they thought there was some missing mortar, so they'll go ahead and just put some styrofoam or caulking, whatever it is, which of course is a really poor idea, because now water that has migrated through the rain screen can't actually get out. So any water that is trapped can actually freeze and cause damage to not only the brick veneer wall, but actually can make its way inside the structure as well.
Okay. So I guess, yeah, just some examples of some issues here with settlement, with the detachment. Obviously, this one on the right wasn't tied to the house appropriately, or something's come loose. Maybe the the anchors, the straps were screwed into just the plywood, not the studs. That can be a problem. This one over the settlement one's a little concerning, because if it's tied to the foundation, not good.
Yeah, when you're walking around the exterior, some inspectors are really hands-on. They actually like to touch support posts. They like to touch stone walls, masonry walls. It's up to you. I mean, it never hurts to give them a gentle push. Obviously, the image on the right, I probably wouldn't even bother pushing that, because you can clearly see there's a big gap at the top and smaller gap at the bottom. So if you push it, you might crack the mortar, you might cause the wall to buckle. So something to indicate in your report. But again, if the system seems to be intact, I'll give it a little push just to make sure that it is in fact, sitting where it's supposed to be sitting.
Okay. Manufactured stone. Okay, well, again, I mean, there's a lot of similar principles in place here, other than we don't have the airspace with the stone. I don't know how much to really get involved with this. There's been some from the code side, I guess. There's been concerns raised over the years that there is an overlying code requirement that everything that goes into a house that's been regulated by the code, and cladding is, the product should be CCMC approved. And a lot of these products, they've come out so fast, or from overseas or what have you, don't always or necessarily have gone through CCMC approval for. So there was a few years back in the mid 2000s where every municipality, not every municipality, but there was a lot of variation on how municipalities would accept these manufactured stone products. They said, well, if it was CCMC approved, no problem, you just install it according to that. If it's not, there was actually some people that were saying, well, if it's up to 4 feet around your house, like just a little bit around we saw previously about the brick around the garage doors or corners, and some places were saying they wanted to have like a third-party engineer, and so different companies would hire some engineer who would print off, a bunch of sheets and put addresses on them. I'm not trying to, cause stress or, or insult the engineering profession, but there was all kinds of different ways to get these things approved. But the concepts at the end of the day are all pretty much the same, right? Like, I mean, Alex was talking about you have your first and second level planes of protection. So, yeah, the stone is kind of doing the work up front and center, but it's not necessarily going to be 100%. There might be some moisture that wicks through there, or gets find its way through there, or migrates, or what have you. Hopefully, it's dealing with 90+% of the water that's going to reach the house, and then then we've got the what comes back to the the whatever kind of weather resistant barrier or whatever we got on there as far as Tyvek or building paper or what have you. So. Some of this stuff is proprietary and depends on the manufacturer of the product, how it gets installed. But what they're showing here is good industry practice. And I mean, realistically, I could go out and get field stone and use it as my cladding on my house, and the code seems to be okay with that. But as soon as we call something a manufactured stone, it got a little more sticky. But there have been some problems and some failures and stuff like that. But I think if the practices are followed, it's going to work just fine. I don't know if there's any big flags to be raised if you're out doing your inspection, because this is like, now we're getting into face brick too. I don't know if this presentation covers that a lot, but there's a lot of people have gone to the, it looks like brick, but it's really essentially just a different form of a manufactured stone. It's just a real thin brick veneer that basically gets glued on. I'll use the word glue onto a mortar bed, the same as you would manufactured stone. So a lot of this stuff comes back to that, that second plane of protection. Personally, is what I'm seeing and thinking. But I don't know if you want to add to that, Alex, or.
Yeah, just that the earlier systems. You'll see some slides of them here in a few. Okay. They are prone to failure, even with these guys, just because you don't have that nice big 1-inch air gap like you would with a brick veneer wall. Mm-hmm. It's only a 1/16 of an inch, and that generally occurs. So you'll notice in the schematic, you have your sheathing, your wood sheathing, then you have the 2 layers of like a weather barrier, if you will, or resistant weather barrier. Typically that would actually, once the mesh, the diamond mesh is installed, and then you have your first scratch code. Once that scratch code occurs, it actually allows that small room for any water that has gone through the first plane of protection to drain out. That that's kind of the purpose of it. So again, with manufactured stone, just be really mindful. Like some of it can be styrofoam. You'll see some photos here. Like I said, shortly, some of it is actually a rock that's been taken, crushed, and then actually mixed in, and then kind of recreated stone, if you will.
Okay. Yeah. There's lots of stuff out there. So I guess this is some pretty obvious examples. You got loose panels. You got color loss. And that's probably again goes back to the manufacturer of the product. Wood siding. It's still some wood siding around. Not too many people are doing the wood siding anymore, but there's houses that have wood siding, and if it's maintained or kept up, and you got to kind of keep whatever kind of a protective coating on there, whether it be a stain or a paint or whatever. I've seen houses very old that seem to be doing very well with good old wood siding, but and they do have the 6-inch requirement to keep it off the ground. Proper sloping obviously is important to management. Managing the moisture around the house always is a thing. Kind of keep cruising here. Oh, good old vinyl siding. And they say vinyl is final. And that's what the vinyl industry people will tell you. And it seems to be one of the, well, just from what I've seen and back with dealing with some moisture issues with the province. It's cheap, right? It's fairly easy installation, and it's not too hard to install, and the failure rates are low. It's not very good, obviously. Siding can be a problem. Installation, if these fasteners, it's supposed to hang loose, right? So these fasteners can't be nailed tight because the stuff is plastic, and it's going to expand and contract with temperature changes quite a bit. And you'll see problems with houses that have improper installations, the oil canning they call it, or whatever, buckling boards, things like that. Still very common, probably one of the most common products you guys will see out there. But I know, like in central Alberta, it keeps the siding guys busy because every time it hails, it seems like there's about 100 houses need fixing. So it does have its drawbacks from a durability perspective. So, okay, I got a little lesson on nailing siding. Yeah, starter strip, interlocks, away you go. Got the weather resistant barrier. Yeah, those, they should be centered in there. And again, the nails are in there as such to allow for that board to move a little bit with the temperature changes. Yeah, they shouldn't be pushing them over to the side. If you do one on the left on one slot and you do one on the right on the other slot, well, they can't move, right? It should be able to move around a little bit. Yeah, utility trim, yeah, sure. And then they've got a, yeah, the punch lock system, J channel at the top. Yeah, again, these are just the products and parts and pieces that go into the siding installation. That's all pretty standard stuff, I think. Sometimes these boards, if they hit on the lap at the top where the J is, that utility trim they have identified there isn't going to work. And there is another tool out there that will put a little bit of a twist to the bottom of the track over here that'll kind of give it a little better connection. It'll hold in there, but another trick, I just know lots of siding guys, they'll put a few dabs of silicone in this bottom one if they don't have this utility trim in there. Just again, it just depends on the house and the boards. If you get to where this fat part of the board's going to try and squeeze into that utility trim, it might not work. It's because this is kind of designed for the skinny part of the board. So sometimes, yeah, you look around your house and you see these boards falling out. Well, they haven't done anything to make that work. The old trick way back was there's also weep holes in the bottom of these boards. Again, being that it's the first level of plane of protection, it's got to be able to drain as well. So every so many inches, you'll see a little hole in the bottom, and that's in case any moisture gets trapped in the bottom of that lap portion. Another trick guys used to do is they would take, back when they used fascia nails as opposed to screws, they would actually drive a nail or two through that weep hole up in through the lap board top of this other board, just to make sure it wouldn't fall out. But anyways, that might be something you see your board falling out. But so heat buckling. So this again would be people in proper installation, not allowing the siding to move, fasteners too tight or not centered in the slots. That's really quite bad. You know, it might keep the rain out, maybe. I don't know. I wouldn't want to own it. Oh yeah, this is very popular too. People just don't think, I guess, or maybe aren't, think they got wood siding or stuck over something and they go stick their barbecue up against the house. And very common issue.
When you guys are doing your deck inspections or exterior inspections, if you see a barbecue that's against you know, vinyl siding, do pull it back, because a lot of times you're going to find out the seller is probably trying to hide the oopsie that they had. So just give them a little pull and check for any sort of heat damage, because again, it is really, really common.
Or just, could I kind of see stuff too, but or sometimes it's different color a bit because they've replaced it, but you know, the siding on the house is faded and they go to find the same siding, and sure, they can maybe find it, but it's not, the color is a little bit different. So they've done a little fix like that. Again, it probably won't leak, but it's just something to watch. Yeah, well, this is like anything. You should have a good 6 inches no matter what under here to, you know, it's just not a good practice. You're going to get moisture issues there, and stuff will get trapped. Those little weep holes in the siding won't be able to work properly. So that's just bad business. Yeah, this is another tricky detail under the windows as well. If you can put those finishing sills or whatever they call it on the under there, that's great. But well, this is just plain simply too loose. So this isn't into the J, obviously. You can pull it right out. So that's a workmanship issue. The installer didn't you know, leave enough board when he notched this board out for this window. Not very good. And there's little tricks the siding guys do under here as well. Sometimes, like depending where this board hits, it can be sitting in there floppy. You know, some of the more conscientious guys might take the piece they cut out, turn it upside down, nail it into that J, and then when they slide this in there, it'll make it a little snugger and tighter. Something you might not notice readily, but I mean, if you can put your finger in like that, or if you get, like you say, if you're going around the house, kind of touching and pushing on stuff like that, if that's sloppy underneath that window, probably not a really good install. It might make you want to look for more stuff. But wood shakes and shingles. Yeah, I see a little bit of this stuff. Very pricey. I think we're kind of back to, you know, falling back on the first and second level of protection. So they do a starter strip, I think. What do they got here? Double undercoursing, they call it. Yeah, and it's really kind of the same thing as roof shingles or any other kind of shingle where you've got to, you offset your laps and it's really not too scientific. This is usually cedar, obviously. Um, Pretty straightforward, I think. We've got the same thing. We've got a plywood exterior sheathing of some sort. Um, the underlayment, yeah, it should be no more than just building paper, a little heavier felt. And then of course the appropriate nails in here. I think there's a requirement, galvanized nails. I don't know. I think that should be maybe a no-brainer, but if you see bleeding on here or something, probably an indication that someone hasn't used galvanized nails because the nails are starting to rust or whatever, and more of an aesthetic thing. But I mean, they will fail and rot out eventually. But yeah, pretty solid system. Like, I mean, they last forever. I mean, they'll discolor and fade and all that kind of stuff, but very good longevity. Fiber cement shingles. Oh, okay. Yeah, well, again, older homes. I haven't run into too many of the fiber cement per se. Like, we're seeing hardy board and board products now quite popular, but these asbestos guys are around, that's for sure. And again, it's like any other siding product. You have to have it lap, think like a raindrop, as they say, and all that kind of stuff, keep the water out. I think they work just fine. But it's something I think you would be remiss not to identify or raise as a concern, just from the fact that if the person did want to eventually reclad the house or do something, it can be pretty expensive if it contains asbestos. There's the companies that have to do the work have to be certified, and there's quite a few OH&S hoops to go through and all this kind of stuff. But do you want to speak to that, Alex?
Or yeah, you bet. So like Brad mentioned, hardboard and whatnot, that obviously, well, should not contain any asbestos. But if you're inspecting a structure that was built 20s to the 70s or so, just be aware that if you do have these, cementous tiles, shingles, or tiles, I should say, for the cladding, there's a really good chance that it may have asbestos. So like Brad said, if you're doing the inspection, you see this stuff, you may want to point out to say that there's a chance it may have asbestos in it. Just by looking at it, you won't be able to know unless you actually send a sample to the lab if you're certified and have the training for it. But the big implication is make sure that potential buyer or the homeowner doesn't sand any of the paint off. If it is in fact asbestos containing, because now you're just releasing all the fibers into the air, which of course is a pretty big health hazard. But the bigger thing is typically when you find this stuff on older homes, you have older windows, older doors. So when there is any implications of any renovations, that's when we really start looking at the bigger picture, where now we may be actually opening up some walls and possibly disturbing some of the fibers that may be embedded.
Yeah, and I guess it's just general stuff with like you talk. Probably you guys go through the vermiculite insulation in attics and the possibly asbestos floor tiles and houses and things like that.
Yeah, you bet. One other thing. So if you just go back one slide there. If you do see this product, just be really careful not to jump the gun and say, yes, it's, possibly has asbestos. Take a look underneath, because it actually just may be a cementous covering on top of wood shingles. I've seen it before. So just take a quick peek, make sure that you're not, calling something out that shouldn't be.
Okay, we're on to stucco, I guess. So yeah, kind of same concept again. You've got our first and second level planes of protection. So yeah, this is interesting topic actually. I don't have any issues with this detail, although there was lobbying done, turn of the century, now I'm feeling pretty old, to get away from the brown coat, right? So the old codes used to always have 3 coats, but there's a lot of stuff in Alberta, and it was deemed co-compliant with 2 scratch coat and finish coat, very common. And there has been some issues in the mid 2000s, and I'm not saying it's because I went to the 2 coats. There's all kinds of other things with improper flashing installation and mostly workmanship. But one of the things with the 2-coat stucco system, and I forget exactly, but there was a requirement for the minimum thickness of each coat to kind of compensate for not having that 3rd coat in there. When they went back to some failures, they were finding this was often, the coats were too light, things like that. But I think it's sort of industry sort of corrected itself, but there was a pretty good stretch of time in there. And I'm going to say around 2000, probably 3 to 2006 or 7, where there was some problems, and maybe it had to do with the, the economy of the province, and, everybody with a cell phone was a contractor and that kind of stuff. But I did some stuff for the province. We went down to Calgary and looked at a bunch of failures, and just some interesting stuff. And like I say, usually it was missing flashings, different siding materials, and poor transition between the two. You might have brick and then stucco, and just the way they transited between the two, they didn't have proper flashings in between them. And it doesn't take much, like water will find a way. Like, I mean, this stuff needs to be paid attention to. Interesting thing we came across, and I think industry's kind of taking care of it. Some people were just using standard Tyvek house wrap under stucco installations, and the concrete cementitious stucco was acidic, and it was actually eating the Tyvek. And one of the places we went to, they had ripped off sections of this stuff. So there was like these 2x2 and 3x3. It was coming off in squares, chunks off this building. And all you could tell to see that there was even paper, like house wrap, sorry, under this was a bit of the lettering. The color, the dye from the paper had kind of transferred onto the backside of the through the wire onto the backside of the scratch coat of the stucco. It was pretty amazing. Tyvek makes a stucco wrap, like they have a product that's designed for that, but I don't think at the time people were paying as attention as they should have. But most people are putting on what I see, 2 layers of good old black paper is kind of the industry practice now, and that's just kind of been proven to work and be good. Another thing, we don't do a lot of inspections on envelopes during construction. It's hard, like not that it's physically hard, but it's just logistically hard. Contractor will go in and they'll paper and wire and scratch coat a house on a weekend, eh? So there's sort of a trust level there that has to happen, but hard to tell as a house inspector, what's under there. That's for sure. But I guess things to be aware of.
And also notice that it is an 8-inch clearance to the ground versus your other types of siding. So this is a pretty common issue. And you'll see here in a few slides, just quite a few failures in stucco.
Yeah, and this type of wire, that's one style, and the other style that sometimes we will see this stuff during construction. Just happen to be on site doing whatever other inspections, but some of the probably won't help you out a bunch, but just some background info. Some of this product comes in like square instead of octagons, and then they have a dimple in the wire isn't just flat; it's got a little bump in it. And the proper way to install that is the bump against the paper, and it's to push that wire out a little bit to allow actually a little bit of better bonding for the scratch coat. So that's just an installation thing that probably wouldn't be more of a, if you're after the fact or doing some destructive investigation or something like that. Stucco again. So this is just drainable house wrap. Yeah. So
just talking about the different types of ends that you'll find. So perfect whip screed versus the kickout flashing. So
okay. Yeah. I see what you're up to there. Yeah.
Yeah. Go ahead.
No, I'm sorry. There are some kind of I don't know, it really didn't take off, but there was kind of another product out there for stucco. It was kind of like a Delta wrap, but it was a plastic, kind of a dimpled type of product too, with the intent of letting that breathe a little more better than conventional stucco installation. But no, these are good examples of why and where we need flashings for sure. Flashings are so important.
Yeah, and the image on the left, so the casing B, that's more common what you'll find here in Alberta, but you'll also find that people actually seal the gap between the casing B and the kickout flashing. So whether with mortar or silicone, and of course that's very counterintuitive, right, counterproductive of what it's actually supposed to do, which is to allow any drainage that is accumulated through the cladding.
Yeah, the old bottle dash stucco. So yeah, very labor intensive. Yeah, they basically put they have the scratch coat on, they put another coat of stucco on, and then they have a big kind of a flat piece of metal, like almost like a painter's easel thing or whatever, and they basically dash it, throw it on the wall. It's I've seen it done. It's like no one does it anymore. That's probably why. It's kind of different. Yeah, but again, again, if it's installed correctly, it probably does the job. Yeah, and this is that a different style of wire that I was referring to over here. Now there's been damage. Obviously, somebody's hit this or been some sort of a problem. So that's not cool.
Yeah, I'll speak to those two slides. So when you guys are doing inspections on older homes, typically 40s to 60s, you will run across, or chances are you're going to run across as bottle dash stucco. So the implications with that is, again, when you are inspecting older dwellings, there's a really good chance that in this bottle dash stucco that there's asbestos in it. So just the same conversation to have with your clients as if there was, the asbestos fiber cement shingles. Same story, right? Any sort of additions or renovations to windows, or even changing out the cladding, whether you put it on top or you remove the existing stucco, should raise some concern that there may be asbestos. And the image on the right, don't really know what's going on here, but there's a chance that if there was no proper flashing installed between the stucco and the actual foundation or the frost wall, wherever that is, this may actually cause the water to accumulate below the stucco, freeze, and then actually bulge out.
Yeah, it could be. I wasn't aware of the bottle dash having asbestos potential. That's something I learned, so that's interesting. But yeah, and this I learned though is I think this is coal in here. These little pits. Someone told me that one time. And you find it with beer bottles broken up, put in there sometimes too. It's kind of funny.
Yeah, Pepsi, Cola, and 7-Up, generally the colors.
Yeah. Okay. Well, yeah, moisture damage. Well, yeah, this just looks like kind of not a great design. Whatever this cap on here and whatever it's doing. Looks like maybe it's a chimney chase probably, but yeah, like why this wasn't over top of this band, I don't know. Just a recipe for disaster again. Problems. This one on the right, don't know what caused that, but must have been something not draining or getting out of the wall or something getting into the wall, and don't know, but obviously problems. Maybe it's poor flashing above or something, and the water, just couldn't get away and froze in there, got trapped.
Yeah, if you guys are doing your inspections and you see, poor designs, and I think we'll have a few more as well during the roofing section, but if you come across chimney caps like that, where it's not actually covering the stucco and there's no water damage yet, it will be damaged down the road, right? And with that other image on the right there, possibly, like Brad said, some sort of moisture accumulation likely. It would be fairly strange if it was flashing, but maybe a hose bib may have burst. It seems pretty longitudinal, if you will.
If I can add in here, I think sometimes it's a settlement or lateral movement of your foundation too.
It does seem kind of linear, right? It seems seems to follow a pretty straight line or something, or something.
I know a while back you were pointing out that beam punch, that's often because the beam is too tight and it'll pop out through that thin coating too.
Yeah, you bet. Or like say they apply too thin of like parging coat on top. I've actually asked a couple structural engineers about that, because again, it's fairly common. They don't have concerns with it. Again, it's just you want to seal it up. But you're right. I mean, this may be some shifting in the structure.
Yeah, it's kind of weird. It looks like it actually broke the wire, like something's did some force on there, like it's not just falling off. Well, they're calling this one moisture damage. I don't know the history. It looks like a pretty darn heavy finish coat on there, but it's no good if it's not staying on the wall. You can see some of this wiring is telegraphing through here, so it doesn't look like much of a scratch coat, but hard to say. I mean, this stuff, at least you can tell readily it's a problem, right? It's not hiding. EFS, okay. Oh yeah. Yeah, this was a bit of a thing when it first came in, and I think industry's kind of getting it figured out right now. It's another one of these systems that's kind of you're going to do it right. It's going to last really good and a long time, but there is a lot of potential for problems with it. It's exterior insulated finish system is what it stands for, EFS. So this gives you the basic design of the system. So it's not, people confuse it with stucco, right? It's not stucco. It's meant to look somewhat like a stucco, but it's just basically a chemical that's put on over top of styrofoam, essentially. Um, let's see what they got in here. The channel insulation board. This is usually some sort of styrofoam product on here. Base coat. They were for a while. I don't know if they still are, but they were used to this insulated channel board used to be installed with screws with big like 2-inch or 2.5-inch plastic washers on it, and then they would kind of fill that in to kind of level it out. And there's been all kinds of variations of this system over the years, and maybe we'll just move on. But it looks really good. You know, it can go on nice, neat, clean. You can do all kinds of funky build outs and stuff on it. And, you know, I think, again, if it's installed correctly, shouldn't really be a problem. But there were some problems in the past. And I think a lot of it was just lack of education or, you know, training of the people doing the work and not following all the procedures, not using insulation that drains, things like that. That kind of stuff. So
You want to go back one slide, Brad?
yeah, just wondered if there was more on this, but
Yeah, it's just one way to tell, you know, whether it's stuck or not is if you just give it a tap, you're going to hear kind of a hollow sound because it is just styrofoam in the back. So it's not very strong, as you can see. It's very prone to mechanical damage. Birds love making nests in this product, so just kind of be aware of that if you're up, you know, on a roof line or maybe at the peak of a roof and you have an eave system that's been installed, there may be some nests in it.
yeah, and there was just a side thing here too. There was a period of time where, and I think they've gotten away from it now, but some people were liking this look or whatever. So they were going and they'd have a conventional stucco house and they didn't like the color or whatever. And they were going and throwing a coat of EFIS, call it stucco or finish or whatever you want to call the product, over top of their conventional stucco. And I don't know what the long-term effects of that were, but I know lots of municipalities were kind of flipping out. And I think they had good cause too, because this stuff, I don't think breathes, you know, like conventional stucco, being a cementitious product. It will dry out, you know, because it's not that airtight. It has some permeance to it, but this EFIS stuff, it's basically kind of a plastic type coating on here. So you really need that drainage through that insulation in the back. So I don't know, just you might see something, you think, oh, it's EFIS, but like Alex said, you go and tap it, it'll feel like concrete, but it may have been coated over or something with this other product. And not to say it's a disaster or nothing, but it just was a concern there for a while that it was going to get rot in the walls. But this is very common, no matter what kind of cladding you have. There's always challenges with trying to get something through it. So, I mean, some smaller stuff, it's usually just a matter of some caulking. You know, now we've got a little more sophisticated with some of the flashings for things like meters and, you know, exhaust vents or intake vents and things like that. When the industry has gone to installing some flashing above and below, try to seal those things up. But yeah, I see this on new houses all the time. You know, they'll punch gas line holes in holes like this, and then you gotta, you know, get after the builder. It's like, come on, someone needs to go back and seal these things up. It's going to be problems. So settlement, shrinkage, weak point in your wall, the face of your wall, right? Anytime you got a hole, it's like the concrete basement kind of thing. It's not good. I mean, if this is properly reinforced, most stucco guys are going to add extra reinforcing around these windows because, you know, it's a weak spot. So that probably wasn't done here. Can't say for sure, but so whether it's, you know, whether it is shrinkage or the building's actually moving, I'm betting probably shrinkage, but can be some workmanship things as well. Another thing, I don't know if we're going to get into it, but and I don't have that at the top of my head, but control joints are not a bad thing either. And I apologize, I don't know off the top of my head if there's actually a code requirement for it, but if you get some really long flat walls, there should be a control joint in there because it is a cementitious product and there's a likelihood it'll crack. And if you can incorporate some control joints, and they make them for stucco, it's just a little metal piece, basically looks like a little piece of trim or something that they attach to the wall, and you stucco up to each side of it. It doesn't look bad. It's, you know, it's usually a galvanized material or something that's impervious to moisture, and it should reduce that ability for cracks and things to happen. back to my house. I had a stucco house. I took all the cladding off it. Halfway on each side of my house, I had a crack. And when I took the stucco off, the conventional stucco, probably 3-coat, it's an old house. It cracked, moisture had gotten through, and there was probably about a 1-foot strip of plywood that was starting to rot on it. And I don't know if a control joint would have helped that, but it does crack. I'm not sure. Looks like we've got an issue here where, again, we talk about different exterior finishes. So this is really crappy if somebody's just kind of blew some brick on top and, kind of stucco down close to it. But it kind of looks like we've got a scratch coat with a finish coat possibly. So this, again, this screams flashing here would be required. Not good. I mean, something's going to get in here, stuck in here. Something's going to be a problem. Masonry failures. Well, have a slope sill on there, which is probably a good idea, but I don't know what just what happened here, workmanship, or there's no real reinforcing or base for this to tie to. I don't know if they just kind of put a form on here and pour it in a like a slurry or a stucco mix or something and thought it would work, but it didn't. So not cool. Yeah, well, this doesn't look, I don't know what they're doing here. Is this flashing pointing up, or is there a flashing? I can't quite see.
Yeah, it's upside down there, Brad.
Yeah, it's pointing the wrong way here. So yeah, boo on that one. That's a lot of work for nothing. These are a little tricky, these end dams they brought in, and I have my personal opinion on that. I don't know how good they are, but really, you should have a flashing right between your dissimilar siding products to kick that water out. It's just kind of a good common sense type thing. This end dam being here or not, I don't know, but it is a code requirement. This obviously is no good. And this drip edge, I think what's going on here is they pushed it down at the back. Well, it wasn't long enough. So the base of this didn't extend past the cladding. So they probably went and bought it off the rack at the hardware store. And they should have got something custom made, is what I'm guessing. That would have carried out over this barging. And you would have had that positive drainage away from the building. So you're just going to trap water there. So that's just really lazy, crappy workmanship. Better they would have put that thing, lifted it up and kept it flat and pushed it out a little bit than install it like that. That's just bad. Not going to work. I don't even see a drip edge here. It says improper drip edge protection. Is it referring to the lack of, or?
No, it may be hard to see, but right above the actual brick veneer wall, you'll notice that the lip actually points upwards. It's supposed to be a 6% slope away from the structure, but here it's actually acting as a catch. So,
Oh, is there actually metal right along where my thing
yeah,
is?
you're right on it. Yeah, you bet.
Oh, I can't even see it. Okay. Huh.
Yeah, so I mean, drip edge flashing, really small items, but they can cause, a lot of grief because you got your whole face of the exterior wall, water's hitting it, it's rolling down. And when you have these flashing that's improperly installed or missing, what have you, it can just bring a lot of moisture inside a structure.
Yeah, it should extend. I don't know, maybe it does if it's pushed down. Maybe it does get past this brick, but no, it's not working. No. Oh, sunrooms and solariums. Okay. Oh, was there something more on this? I don't know that.
Yeah, I can speak to that. So
yeah,
a lot of times if you come across these additions, be extremely vigilant because it's typically a DIY or possibly the homeowner hired a handyman that also was not very well versed in proper building construction. So if you see these sort of additions, I would strongly recommend you let your client know to inquire if any permits have been built, because again, you have a roof overhang here. It's pretty big sized addition. In the crawl space, if there is one, I mean, you probably won't be able to determine what kind of footings that they have. I think that's basically it. Yeah. Oh,
yeah, that's a good point. I guess when you're on this, this is an older style, obviously, and there's so much nicer looking stuff now that's more, shed roof with walls and some pretty sophisticated sunrooms that are going on out there. But they should be not tying to the overhang of the roof, right? They should be either going back to the underside, onto the wall, or depending on the design, if it means removing this bit of overhang and tying to the above the wall or what have you. not really good business. There are some details, some municipalities accept that if you were to rip the soffit open and do some reinforcing, and if it's not more than a 16-inch overhang, you can bolt to it. And it's probably works based on past performance. But yeah, no, it's important to see how these things have been put together. And I've seen a lot. And sometimes another thing, Alex, just to add or whatever, they'll just throw it on an existing deck, right? And they won't really consider what's going on. And depending what it is, it can have a lot of weight to it as well. And the deck might not have been designed for a second story or proper foundation. So no, if you see these things on here, definitely pay attention to them. I shouldn't say call them things, because some of them are very nice, but yeah, if homeowners could do maybe not do the best job, but there are some professional people out there doing real nice sunrooms for sure. But it's like anything, I guess you got to pay attention. So drip edge, yeah, okay, here we go. This is kind of like almost out of the code book per se. Like, I mean, we have to have the flashing. It should be a 2-inch, I think, up leg they call it, which will be going in behind here. And this was the challenge when the code changed to kind of make this not look too ugly with the with these legs on here. It's a little tricky. To be honest with you, vinyl is one thing, and this looks okay, I think, in that they've got it between the window and the band. And again, up here, and assuming this goes up behind the siding, life should be pretty good, I think. On stucco houses, I see a lot of stucco guys, they adamantly refuse to put this end dam on here. And I have a hard time arguing with them, because I think it's creating a potential crack in the stucco. Like, I mean, it really is. You're going to put that little slice in there. It's kind of like, overcutting your hole in an eye-joist or what have you. And from what I've seen in building failures and issues with building envelopes, that hasn't been an issue with stucco. But again, I'm a little surprised on the end dam. You won't find these end dams. I think this came in 2006 code. So there's lots of homes out there won't have end dams on the drip cat, but it is required now. And then I'm just looking over at this detail here. So the other thing we would need, which they don't show here, maybe have it on another slide, is like a reverse flashing for the window over the siding. Now, that isn't required so long as you have a sill. Now, you're not going to see a wood sill. This looks like wood anymore, rarely. But they do make windows where the bottom sill would be probably PVC product these days. As long as it's been designed to slope away and extend at least a 1/2 inch over your siding, you don't have to, I mean, you still have to have some sort of trim to seal it off and finish the siding, but you get away from what they call a reverse flashing under here. Otherwise, there should be a flashing that goes up, out, and then down again. So any water coming off this window is going to get kicked out. And the thing is, it doesn't look like it makes sense, because you got to nail it, it's upside down to the drip flashing above, but it's got to slope away. And that's really the only way to install it. It's really kind of a goofy thing, but the bottom of those windows, we'll probably get into it. I'm maybe jumping ahead, but it needs to extend past the siding, whether the window be designed for it or a flashing provided, one way or the other. Maybe we won't, but yeah, I don't know. This doesn't look like it's really doing a bunch of recessed drip edge. Maybe it's just my screen. I don't even.
So some jurisdictions will allow, if you have this recess of at least 1 inch.
Oh, yeah, yeah.
Oh, yeah, you can speak to Brad. No worries.
No, I'm sorry. I was expecting to see an actual drip edge there, but so this is kind of getting back to something like I was saying about the windows. If the cladding was to extend past the window opening far enough, it should do the same thing. You might get a little bit of water, but by the time it should be dropping off. Gravity should kick in. But so there isn't actually a physical flashing here. And you can actually, even in the code, it does talk about, say, when we're doing different types of cladding, if the upper cladding, laps over top of the bottom cladding, you don't basically need a metal flashing in those situations. But so no, that's another option. This window coatings. Okay, well, this is not my area thing. I did learn a little bit about argon back in the day, but the gentleman, he was an engineer, building envelope engineer, and he was kind of tongue in cheek. He said, the way they test for argon, he says you have a spacer or seal inside a double pane window, for example, and a hole on the other end. He says they stick a little tiny tube in there and they blow the argon in. And then when the argon's detected on the other end through the other tiny hole, they shut the thing off, seal the holes up. And this gentleman that I was talking to had concerns that the argon, the quality control on the argon installation, he didn't feel was very high. But I don't know. I think, hard to find a window that doesn't have argon in it, like for housing anyways, or and then especially with the energy codes that came in here in the last couple code cycles with the, the higher U values and energy code ratings, almost seeing more in the new homes anyways, triple pane are getting more common, and definitely high quality double pane. But I guess you want to get into the coatings on this, Alex, or?
Yeah, sure. You bet. Do you mean myself or you?
Oh, you go ahead. I'm not an expert on the coatings.
Yeah,
Sure.
no worries. So just kind of go back a few points like Brad mentioned. I believe building code right now is still double pane windows, triple are not required, but obviously they provide more comfort and more R value to the occupants of the dwelling. So like Brad mentioned, there's typically two types of gas if they are installed, so krypton or argon. And I believe argon is the cheaper one. Krypton is the more expensive one. And basically the gases, they just reduce the amount of convection that occurs in between the panes, which, the less the air moves, the better the R values, just like insulation and attic space, right? You're trying to reduce the convection of the air because that's what's going to allow the loss of the thermal barrier. And then with the emissivity coating, so that basically blocks the amount of sun UV rays that actually go through the window. So you can have various ratings and whatnot, but yeah, that's basically it. You generally they would install it on the inside panes, and again, depending on which way, or I guess which side of the house the windows are installed. And if you're trying to gain more heat, say in the winter time, you may want to reduce the amount of coatings that are inside the window, and say sorry, I guess that'd be for the summertime. You want to have probably less heat getting in the summertime, and possibly more heat getting in the wintertime. So the designer would choose whichever windows would suit best depending on the way the house is oriented. We're going to look at a few slides here as well, where we actually have failures in the glazing and the seals as well. And one really easy trick to determine the number of panes is if you have a flashlight, just simply shoot it at the window, and depending on how many reflections you get, that's the number of panes in the window. Generally, yeah, I'm sorry.
Oh, no, you did mention that the triple pane aren't code, but there is now, like I say, since 2012 code, I guess there is this ER requirement, a minimum ER 25 or a maximum U value of 1.6, and that's the U value is like it's the inverse of R values. So the higher the smaller the U value, the better the window. And it's a metric way of measuring the thermal resistance of a window. So 1.6 is what you have to have or less. The other option is this ER of 25. So there are two double pane windows that will make that grade. So, yeah, just some info on the codes and that. But window defects. Well, this is one I haven't seen. What do we got going on here?
Yeah, this is again a failure of the actual glazing, the emissivity. So I mean, here it looks like little cauliflowers or barnacles on the window, and this is actually on the inside pane. So again, just poor application and just a loss of the actual the coating. So sometimes you may come across windows that look almost metallic or gold or shiny, and that just again is just the amount of emissivity, I guess, coatings that they may have placed on the actual window.
Right.
Typically, your double pane windows will last about 30 years or so. So if you guys are inspecting homes in the mid 90s, early 90s, just be extra vigilant to look for any sort of failed window seals. And I think we got it, like I said, a few slides coming up here just to show some examples.
Well, some drip edge issues here. So yeah, this isn't working. Obviously, you shouldn't be able to see through there. This is on the interior. So what's going on over here? Something's got into this. Moisture is getting in here somehow. So something's failing is what I'm thinking on this one. I don't know.
Yeah, so most likely water entered below the window. I mean,
Yeah.
probably the same window. So Obviously, there's no silicone, there's no caulking, there's no drip edge flashing, and it also looks like the bricks are actually horizontal as well, flat, if you will. So I mean, best practice is actually having them slope in the way, right? That way, any water that can shut off. And as you can see, this is just an image showing what can happen over time, right? So again, if you come across a structure or a dwelling that doesn't have the flashing, that has all these openings, if you don't see the water damage, as you know, as we see on the image on the right, it's just a matter of time that you likely will. And of course, we don't know what's going on behind the wall. There may be more rot, mold, more rot to the actual structural members for the wall itself.
Yeah, it's kind of interesting. We did some of that stuff. We went to a bunch of buildings in Calgary with all these envelope failures, and some were apartment buildings and stuff. And went with the city inspectors, and there was another envelope engineer, and they found that same kind of workmanship and same kind of defects on buildings, but it would be they'd get away with it, like on the south side of the building and the west side, or anything exposed to quite a bit of sunlight, to get that drying ability for everything to kind of dry out. It'd be the north and east sides that would fail. So I mean, it was just kind of funny, and they're ripping walls apart, total mold and rot and everything on the north side of a 3-story apartment building. And yet the south side, built exactly the same way, was doing just fine. But it's kind of interesting. Again, yeah, this isn't going to make it. This isn't going to work. It's got to get out there, and that's part of the problem too. I don't know if the industry or the suppliers have kind of kept up with some of this stuff, with some of the different products we have out there. And people are sadly lazy. They'll go to the hardware store, and if it's not on the rack, they'll use what's on the rack. And if it doesn't come out long enough, well, you get something like this. Lots of companies out there will bend you up flashing. I mean, and that's what has to happen. Yeah, slope again here. They got it pushed down, bent the wrong way.
You can go back one slide there, Brad. So the image on the right also shows another thing too. So typically you actually want to have a clearance below, especially stucco and brick as well. You'll notice that the stucco is embedded right into the flashing, or vice versa. The flashing is embedded right into the stucco. Yeah. So again, any moisture that is going to be hitting that stucco, now if you don't have that little gap between the stucco and the drip edge flashing, it can get stuck and trapped, right? So again, just kind of be vigilant of that. It's a really common thing to point out. So again, you don't have to make a massive fuss about it with your clients, but just let them know that not the best installation practice. I mean, here it looks like it's even sloping upwards, and looks like we got a bunch of vegetation above the.
It's growing something in there, yeah.
Yeah, so definitely not draining water as it should.
So yeah, well, obviously water has been getting in here somehow, some way. I'm just kind of confused what the red stuff is on the ceiling over here has got my attention, but yeah, no, obviously this is an issue with some water getting into the place. Never good to have water stains, and then it's a matter of trying to figure out where it is. But obviously around the window, it's probably a flashing drip problem.
Generally, when you see issues during your inspection, it's typically a cause and effect relationship. So, maybe you missed the flashing defect outside or something else, or maybe an opening in the actual cladding. If you missed that, hopefully when you're doing your interior inspection, you're going to see, the actual effects of the lack of, workmanship or the poor workmanship, and vice versa. If you're outside and you notice these issues, just be extra mindful when you're doing the interior portion to go, okay, well, I see poor flashing here. I got to be extra mindful to check this area, or, we got a really poor grading or lack of downspout extensions in this corner. I really have to be extra vigilant, in the basement when I'm inside the house in this area.
Yeah, it's an odd framed thing here too. It's just a little weird. It almost looks like it was a renovation or something. But yeah, these show up pretty. These don't show up sometimes on a hot sunny day though, right? These failed seals. You might not see that all the time. Just my own personal experience. You might have to get a cooler, more humid day, or some humidity in the house or something like that. But yeah, that's exactly what it is. It's just the seal between the panes of the glass is no longer doing its job. And yeah, moisture is getting in there and doing its thing, condensating, fogging the windows up. It's not a good thing, not a cheap thing to fix. The window has to be essentially changed. I did hear of a company one time that apparently could try and fix these things. You ever hear anybody do that, Alex? I don't know, that they would drill a little hole somewhere and they could do something to make that fix better or no?
All they do is just remove the moisture and then they plug the holes. But the thing is the integrity of the seal has failed. So it's just a matter of time before the warm air from the house or the outside hits the cold air from the house or the outside. They mix, they condense, and then we get the fogging. So
Yeah,
a few other notes. So like Brad said, it can be difficult, I should say, to spot a failed window seal. A lot of times you'll typically actually see the formation on the bottom portion of the window. So, the bottom end. If you don't see the condensation, as it's quite obvious here in the image on the left, other things you may see is actual streaks. So if you can't rub the streak or the condensation on either the inside or the outside of the window, that just means that you have condensation in between the panes. Another thing too is if the spacer bar is metallic, you'll actually see a bunch of rust inside. So I mean, those three things, the condensation, the streaks, and the corrosion, those are just the dead giveaways for a failed window seal. You can also help induce, I shouldn't say a failure, but to recognize a failure in the seal. And that is just by increasing the thermostat or the air conditioner. You drop the AC, of course, temperature inside the house, because the condensation is created once again by the thermal variances of the air inside versus the outside of the structure. So if you can make a bigger gap, that's really going to show you, or it's going to help show you a failed seal.
right. This one on the right's kind of interesting, and yeah, it's going to cause problems all over the place with the drain ports. Obviously, this is I'm going to say it's obviously a PVC window type of issue, but I just brought back something I've come across, which is kind of a weird thing, and I don't know how often, hopefully not too often, but dealing with an issue with a house back when I worked for the province, or a window, several issues with the house, but we went and had a look at it. It fixed windows, so they weren't opening, and the contractor put them in upside down. And so the drain ports were on the top of the window and the bottom, and it was not, it was, I could see how he did it, because it was really, the window looked the same either way, but didn't pay attention to where those drain ports were. And window went in upside down, and it was facing the west where a lot of rain hit on it. And yeah, it was causing problems. The water was getting back into the house. It's a kind of probably one of the tiniest things on your building envelope, but it can cause major problems.
That's a really good point, Brad. If you actually just go back one slide, so that little area right below that 1-800 number, the 467, that's the drain port. And I mean, I've also seen windows installed upside down, even sideways. I've seen single hung windows, which we'll see here next slide, installed as a slider window, right? I mean, it's pretty obvious where you have the sash balances pulling it back. But some folks, I don't know if we have slides that will actually glue or silicone shut these drain ports. I mean, that obviously.
Oh, really?
Yeah. In your own house, you may want, if you have PVC windows, you may want to clean the ports. You can just open up the window, just pour some water, because you actually have openings at the bottom of the window that are tied into the drain ports. And of course, you can just flush them out, right? It could be an annual thing for you.
I saw one really badly done reno, and the guy, he changed the orientation of the window and he drilled his own ports in. Couple holes. Oh yeah, crack panes. I mean, those are going to be obvious. The only thing I guess to be concerned there, not only thing, but was it something that the house moved and caused the crack? Was the window put in too tight? What's going on there? Did some baseball get thrown against it? Or again, this is pretty obvious. This is, I don't know if this is it's a double hung window. I don't know if it's this, has a spring assist to it or anything. If something's give out on that, or the hardware, something's probably failed on this. Usually they got some sort of way to help you lift them. Yeah, in these corners, water tends to want to sit in there, and it can be a rot point. That's a good point. This looks like an older style wood casement, possibly. Yeah, bubbling here. So again, the moisture is getting in behind, and kind of the paint is acting as a little mini vapor barrier, I think. Can't say for sure, but something's got in there and it's causing some problems.
You can see by the image on the left, guys, that there's been a nice, fresh coat of paint put on. But again,
yeah.
You always want to just probe the frames of anything wood, like your doors and your windows, just because, again, homeowners love to save money, I guess, when it comes to selling their house.
Do you see any capped ones? Like just back years ago, people would have windows that would get rotten, so they would have a guy come in there, his cap with tin. It looks really good, and they caulk it all up and everything, but then you've got this rotten wood frame underneath there, but just, I don't know, something maybe to watch out for.
Yeah, and that's why you want to pack a really good flashlight. So like if you just, yeah, thanks, just go back one slide. Yeah, thank you. If you pack a good flashlight, I personally like the Phoenix brand. They have really good tactical flashlights. They're very, very small, about $150 or so, but they put out about 1,000 lumens minimum. So
Wow.
they're definitely going to be able to show you any sort of patches that were down below windows. Right. And like I said, in a few slides, when we're going to talk about water intrusion into the dwelling, they really just help to show any sort of water damage and watermarks in basements. So me personally, it's probably the most important tool I could bring to an inspection is a good flashlight. Thermal cameras, of course, would be a second best, but for the price point, I would definitely recommend to invest in a really good flashlight.
Well, they're getting into some hardware issues here, I guess. Yeah, those are, I think, things that would be pretty evident, I guess. They all start to go. I got 20-year-old windows in my house, and I've got a couple that need hardware repairs. Defective locks, cranks, yeah. Yeah, well, what's going on here? I don't know. It's maybe a little bit of some maintenance issues for sure. Really bad failed seal, looks like here.
Yeah, that failed seal image, guys, that's just that rust I was telling you about, right? So again, you got that humidity hitting that metal spacer bar, and it's just causing corrosion. And you may or may not be able to see through your screen too, but you actually can see the little streaks right above the section of rust. So again, just some of the ways to determine failed seal and.
Oh yeah, age. I think we talked about this morning a little bit. Yeah, you might be able to find how old the windows are in there if you're curious about age of the house or age of a renovation or something like that. Yeah, rot. Well, yeah, this is a spot that will, yeah, rear its head. So basement windows. Okay. Well, there's a few different ways these go in, obviously, but what you're talking about here basically is a rough opening for the window, caulking, blocking, and the slope to the exterior. Well, that'd be nice, but I don't see too many basement windows where they've sloped the concrete outside. It would be nice if they did. Seen a few, not a whole bunch, very rare, but there's some precast basement systems I've seen. Superior wall systems, I think they're called. They're pretty slick, and they come in big panels, precast, and they have a way to, they can do some grouting between the panels. And long story short, they slope all their window sills out. And I thought that was one of the smartest things in their basement windows. But I haven't seen this in conventional construction in Canada or Alberta, anyways. But oh yeah, you got to have the egress window requirements. Yeah, no, I deal with this fairly regularly. So these are the dimensions and the requirements. So yeah, you should make sure these are, if you have a bedroom window, where it gets a little fuzzy though is from our perspective, the house is considered to be code compliant if it was built to the code in effect at the time of construction. So this window requirement's been in at least 1985. I don't know if it was in 81 or not. I have to check, but you get back into houses built prior to 1980, it's not actually a code requirement. So like from an enforcement issue, like if there was an incident or somebody was complaining, about maybe it's a secondary suite that was built in the 60s and the guy renting it says, hey, I don't like my bedroom window. It's really hard from a building code perspective to make them change the window because technically it was built to the code of the day. But that's where like Alberta Health, some of the health inspectors, when it deals with rental properties, they can do something there. But it's very good information to know, and it's very good to have this in place. Problems we have, sometimes people want to do basement developments and they give you a basement development permit and we mark up the drawings and we provide them all this information. And it's like, hey, you got to have these windows. If you're going to put a bedroom in there, at least one window or door to the outside works too. And you get out there and they haven't done it and it's real shitty. Because usually it means concrete cutting or something like that to get the proper window. But yeah, this very detail here is out of the building code. So it is kind of silly, I think, in some ways, because this one here is only like 15 by 36, and a big guy like myself, I'd get out of there maybe if, there's a fire in my butt, pretty tight, but I could have like a 20 by 20, which I would prefer to go out of. And 20 by 20 doesn't meet code, too small, but these are the requirements. And it has to be an unobstructed opening as well. I think that's important too. So it can't be an awning window or something like that where you got hardware in the way. So a big slider, you'd almost need twice this window size kind of thing. Crankouts usually work pretty good unless the hinge side of the crankout starts moving in as the window opens, which they do sometimes. So anyways, code stuff.
Make a couple notes too. So you may notice that in some homes in the basement, it might be 6-7 feet to actually get to an egress window. So if you notice that your clients or potential buyers may have young kids or elderly folks, you may want to suggest that they either have a desk or a built-in shelf or even a ladder system that they can actually exit out of the window, the egress window, should there be a need for it. And also note that you may not come across this in your times, but homes with sprinkler systems are not required to have egress windows either. I've only seen that I think once or twice in my time. So
no, that's right. That indicates the requirement for an egress window if the house is sprinklered. And just recently, I've been getting around the province a little more, and there's I was at a high-end subdivision outside Calgary built on a golf course, and part of the subdivision requirements are that all the homes be sprinklered. It was kind of different. So yeah, in those cases, windows out. At apartment buildings and things like that, if you ever get into those situations, you might go into a sprinkler building and you think, well, I can't even open the bloody window, or I can only open it 4 inches, which is another code thing that we won't get into, but it's because it's sprinklered. The furniture idea is a good idea. It's not a code thing, but it's a recommended thing. Absolutely. Yeah, well, this is just all bad. Don't know what's going on here. Hopefully they're not done working on it. But yeah, there's no flashing, no paper. And it looks like someone's probably just infilling an old hole and not doing it right, basically. Poor installation. Yeah, again, I don't know if this was a renovation or what have you, but got to have that flashing, got to have that drain away, got to have the slope in the proper way, got to have things sealed, all those kind of things.
Brad, if you can speak to, when homeowners decide to upsize to an egress window and then they hire, a handyman and they bring a concrete saw and they just start hacking up the foundation. As a safety codes officer, what would you do if you start, seeing a massive renovation for a window, more from a structural aspect is what I'm getting at?
Well, there is a requirement in the code that if you have an opening in your foundation greater than 4 feet, you're supposed to provide reinforcing like rebar around that opening. So if they're going to want to cut a hole in there that's greater than 4 feet, we want to take a good look at that. But to be fair to the homeowner, there's also other parameters such as backfill height. So say you've got a raised bungalow or something like that, and the backfill height's only 4 feet. Well, the code also says when you only have 4 feet of backfill, we don't even really need lateral support for that wall. So I'm not trying to overcomplicate things. Long story short, we'd want the details. How big a window? How big is the backfill height? And usually, it's not that big a deal. Are they going to, cut that window out right to the underside of the floor system? How are they plan to reinforce the floor system? If the window opening is parallel to the floor system, it's really not load bearing. It might have some wall load on it from the main floor walls, those kind of things. But basically just, we would ask that we get the details for how they're going to do it. And the other thing, I guess, when we're talking about it is if it's going to result in a window well going in, we'd ask that they drain that window well to the perimeter tile, those kind of things. Those are the considerations. And then the type of window there's some debate over. The code doesn't really get into types of windows. It just talks about minimum unobstructed area of the opening. So like really when that window is open, as long as you got that area, you meet it. I don't have a problem. There's some windows, kind of a reverse awning, if you want to call it. They swing to the inside, and the hardware design is you can swing it inside up and it'll latch in the open position. Usually not the highest quality window, but they're, CSA approved. And it'll give you that required area. And the nice thing about those is they don't take up a huge amount of room because you're getting maximum area for your window opening. Pretty much that whole window is going to turn into opening, as opposed to a slider where you only get about half, right? The crankouts are problematic as well, depending on the hardware. Awning window to the outside, the scissor hardware on the bottom, that doesn't work. I've seen recently a couple, is it Scan XL, or there is a really neat window out there, and damn if I can remember the manufacturer right now, but it's set up as a slider, but it's very simple. You use one set of hardware, and it's just normal slider back and forth, and then you use the other hardware, and it opens like a book. It's like two like hinge, like a double set of doors, and the window will open to the interior. Both sides open up. It gives you this huge opening. There is a blurb in the code about special tools or knowledge, but I don't personally think that's special. I mean, if you've got someone in a bedroom, they should be able to know how to open their window. Like, it's not a bunch of, it's not much harder than most windows to have to lift a lever or open a lock or whatever. So those are the stuff we want to look at, that it's gonna meet the intent of the code, and yeah, hopefully that's got it figured. Okay, so yeah, we're getting into the window well. So yeah, again, code of the day. I think this came in, I can't remember now if it's 06 or 14. I think it might have been 06 code. I have to check. At any rate, it was 550 millimeters for many years. So 22 inches, and now it's closer to 30. So I don't know, if I beat somebody up, if they had a house built in the 80s or 90s, and they got a bedroom window and they have a 22-inch window well, that from our perspective met the code of the day. Somewhere along the way, the code people said, hey, we should make this bigger. Okay, great. But we don't go back and make people change all their houses now, right? Same with, like smoke alarm requirements and things like that. A lot of these things tend to get a little more restrictive, or it's more stringent or what have you over time. It's not retroactive, the code, but these are good examples and good things to consider for sure. I mean, if you have an outswinging window like the middle one, and you have a 760 window well, but you don't have that 760 as shown in here, you're not going to get out, right? I mean, this is the whole point of this, is we need a means of egress. And yeah, I think these are all going to make good sense. This one here talked about the inner swinging window. That's just fine. So yeah, just a good thing to pay attention to is, so anything, don't remember exactly what code data was, and I don't know how tight you guys get on that. And when you do your reports, if you want to have the date of construction as a point of reference to see if it met the code of the day. I think builders have got onto this pretty quick, right? But there are people that renovate and stuff. I've had to go out and be a dick, and some guy, he's went through the cost of cutting a hole in his basement to put a bedroom window in, and I go out there and he's got a 550 window well. And I'm like, well, we wrote it on your plan review. We noted it on here. We communicated to you, you need the 760. Not a real big, huge deal. Like, I mean, but he's going to have to dig that 550 out now and put a 760 because that's what current codes require. So it is something to pay attention to, I guess. The other one, I don't know if you get into it, and is a deck over here. Does this come across this in this, Alex? I don't know. I don't want to jump ahead, but there's a bit of a concern and a bit of disagreement amongst different code people. And this would be more for not a window well situation. So let's just assume where I'm pointing here is ground level. And then let's say there's a deck over top here, and nothing in the code really speaks to it. Kind of what the inspectors I know, we kind of look at is, as long as you've got a good, 30 inches to 3 foot, you can crawl out and it's not too ridiculous. But I've gone to some places and they put lattice around their deck, or they've closed it in, or maybe the deck is even higher and they want to, they end up putting a storage thing under there. So if there is some sort of construction built over these windows, the intent is somebody getting out of here can keep getting away from the house. Just something to think about. It happens. It's kind of a strange situation, but So, yeah, a little more detail on here. Yeah, most window wells, I think now are the pre-manufactured corrugated metal, but nothing wrong if somebody wants to use some treated lumber or something like that. Something a little more architectural. I've seen on some high-end homes, precast ones. It is kind of strange. You get on some real fancy high-end homes and they got the 9-foot basement and they got a big egress window down there, and you look at it and you say, how is anybody going to get out of this thing without a ladder? But no, it meets code. And then you go upstairs and you walk around the house or outside, and it's like a 4-foot deep window well with no guards around it. And the code's fine with all that. And I'm not suggesting it's an issue myself, but it does seem kind of weird the way our codes are written a bit, because anybody wandering around in the nighttime could fall into that window well and you're going to break your leg. But just one of those things. Again, a code is a minimum set of standards, and might not want to have a house built to that. So these are all pretty accurate details, I think. Stored items. Okay, yeah, no, we don't want to do this. It's kind of bad. Yeah, uncapped. Someone's going to stuff something in here. Plus, it's too high to actually function the way it is. Should be. And also, this might sound crazy, but something I check for when in new construction is they haven't piled a bunch of gravel in here. You can't open the window. Seems kind of odd, but you think somebody would figure it out pretty quick. But stuff does get thrown in here, piled in here, blow in here, accumulate over years. The bedroom hasn't been used by anybody or whatever. It's a real quick, easy thing to check on and make sure it functions as intended. And yeah, these are kind of common sense things. Window well common defects. Oh, I get this. Is this a suggestion here that we should have a window well in here of some sort, even though it's close to grade? Yeah, that's not right. There really isn't a minimum for that to be. I don't think there is. I guess you can look at it possibly like wood frame construction, 6 or 8 inches. But yeah, that's just poor. I mean, snow will pile up against here and water will get in. That's just really bad. I don't know what happened here, but
Maybe I'll just speak to these slides.
Yeah, if you could.
Again, jurisdiction dependent, and of course, safety codes officer dependent. So it depends if you got Brad on your side or not. But like Brad mentioned, there is no strict and hard rule in the building code that requires window walls, certain depths and whatnot. But generally, it's assumed that if it's within 6 inches of grade, because we don't know what kind of framing, if it's pressure treated or untreated framing around the window. If it's untreated and then you have, the topsoil or the grade within 6 inches, there's a chance now with snow accumulation or any driving rain, you may get some ingress. So it's a good rule of thumb. Now, even if you had a window well here, because I think in the next slide we do have that image, but if you don't have that clearance, regardless if you have a window well or not, that's something you want to point out as well, because again, you may have a window well, but if it's full of soil right below the actual below the window, it's not doing anything anyways to keep the moisture out.
Yeah, well, that's all makes sense. Oh, wow. What the hell? That's interesting.
The image on the right was actually a brand new home, just so you guys know. So like I've spoken to inspectors and that have found, non-egress windows too small and whatnot, and obviously got improper windows and whatnot.
Yeah, it has to work as intended. Yeah, actually this reminds me of my guy with my 2 small window wells. Well, he put a nice crank out in there, and the 550 also impeded this thing from opening. So it's just things to pay attention to. Well, I don't know what they're gaining there. Well, this looks like it's probably something that happened after the fact, maybe, right? Like it's not right, obviously, and it's an issue. It's going to be an issue, but you have to think or hope or wonder that maybe somebody did some sidewalk after the fact, or who knows? Or maybe they built that from day one, but it's not going to work too well. Yeah, well, these are, I don't see a bunch of these. I don't know if because maybe they're definitely not there when houses get turned over. I'm not sure if a lot of people are doing them, but they shouldn't be on egress windows, I guess, let's say. I don't know if I have an opinion on them otherwise. I don't know what you guys' thoughts are on these. I mean, it's a piece of plastic that's kind of acrylic that's stuck on there, I'm guessing for energy savings and maybe what else, I don't know. But not to be put on egress window for sure. Watermarks, well, yeah, okay, this is just, I guess, some more evidence of some moisture getting in through somewhere. Something to be paying. Yeah, you don't want this. And if there's a plant sitting here or something, okay, maybe you can say that's probably what's going on, but probably not. Exterior doors. Okay.
I have a question on the previous slide. Okay, for the watermarks on the window, how can we explain the source of that water?
Yeah, I can speak to that, John. So I mean, it's gonna be pretty difficult just because we don't, I mean, chances are you may not know what's causing the moisture. So you'll have to kind of do some investigating / inspecting. So I mean, if you're on the outside and you see, the grading going towards the window, there's no window well, you can, I don't want to say presume or assume, but I think it's safe to say that you may be getting some water intrusion from the exterior. If you notice that there's window wells, there's good distance between the bottom of the window and the soil, and possibly it's a newer house, maybe they've been closing their their window blinds in the wintertime, which may actually cause lots of condensation buildup, which I think we'll discuss in building science on Friday. But it's really hard to know. You can try to trace where, any sort of watermarks or any water damage up the actual frame, right? If you see any watermarks up top, well, again, that may be an indication of lack of drip edge flashing or improperly installed flashing, or maybe a defect even in the envelope. But I think it's pretty hard to say definitively what is causing it. I think you kind of have to rule out some issues that may not be causing the moisture. Like it also could be something as simple as people having a plant that they overwatered, right?
Yeah, I saw one like this recently. Above the window, there is a shootout extension. And I was just wondering how can water could have gone there, but I just think I couldn't find a solution.
Yeah, no, that's fair enough. And like I said, after you've kind of ruled out some options, if you still can't figure it out, you just want to let your clients know that there's some watermarks noted. You can always suggest that they ask the sellers if they know what caused the moisture or the watermarks. They may not know. Usually people don't really know what's going on with their house. But at a minimum, just report it, let them know to keep an eye on it, and at least you've done your due diligence. So you're not required to figure out what is causing an issue. You just want to make sure you at least point it out and report it in the report.
Yeah, for sure. Thanks.
Okay, so moving on to doors. Okay, yeah, so basically a detail of a door installation in a typical house with some siding on it. I think most of this stuff should be probably fairly straightforward. Pretty much every door, well, for quite many years now, they're all pretty much pre-manufactured, with aluminum thresholds and such on them. Just trying to see if there's anything exciting in here. I mean, we saw pretty common construction stuff. I think probably move on here. But then rot points, yeah. So trying to see what is in and what is out. Looks like it's outside on the right. So somehow, some way, water has gotten into the side of this door, looks like, and causing. Well, here's the seal. So it's an in-swinging door. So that's the weather strip portion of it. This is the jamb. I don't know where the water is getting in. It's kind of hard to tell from this. I don't know if you got any background to this one, Alex, but obviously it's rotten. But I guess just pointing out the fact that in the jamb, the bottom corners, is a potential high frequency rot spot.
Yeah, you bet, Brad. So it doesn't matter if it's a basement or main floor, deck, or what have you. You definitely want to check in these corners, not only of the actual frame, but also the door itself. The image on the left, you could have rot where we see the rot, where they actually removed the that little foam gasket. That inside face of the door as well, again, often rotted out. And then on the image on the right, you'll see the exterior, well, the face that is facing us, that also can have rot with it too. So just be really mindful in the bottom portion of the door to check for rot, just because again, you have water and snow accumulation there. And of course, if you have that moisture, the wood will simply just wick the moisture. it's not uncommon to find rotten, even 5-6-year-old doors, depending on how much weather it gets.
Okay. Well, it's a screen door without the closer, I guess. Deadbolts. Yeah. Well, it's a code requirement to put a deadbolt on an entry door to a house. That's a fact. So interesting. There isn't one on this one because it looks like it's a manufactured door that you might see that on. I don't usually see that on manufactured doors. They're usually prepped for it, but I think you can buy slabs or whatever, or doors with just windows without the doorknobs cut into them and stuff. But no, it's a code thing. Resistance to forced entry is what they call that. Same as you're supposed to have a door viewer on an entry door. If you don't have a door viewer or a clear piece of glass, that would be non-compliant. I see that sometimes on new buildings. It's kind of odd.
Brad, would a side light allow for circumvention of that requirement for the people?
Yeah, you would actually. Yeah, no, the intent is that I should have said that if someone's ringing your doorbell, you should be able to identify who it is. So they do speak to window in the door, side light beside the door. Either of those, if you don't have them, you should have a door viewer. It's getting common now for the doorbell cameras. And I know some places like on high-end homes where they got the $3,000 front door and it's all opaque glass and they just do not want to have a door viewer or any clear glass in there. Some places have accepted the doorbell viewer in lieu of that. And I'm kind of got mixed feelings about it. And I guess it's just, if you got somebody coming, not a nice guy, or more, you can, the ex-husband's coming or whatever, you don't want to open that door. And if you can't see who it is, it makes it problematic. So to me, a door viewer isn't a big deal, or a little piece. Most of the guys you'll see, the manufactured window guys, even when they do their fancy glazing in the, if they got glass in an entry door like this or something, usually they'll often have a little triangle in there of clear or something, or they've thought it out a little bit better, but you still see people wanting to do their own thing. But it is a quirky little code thing that's in there that not everybody's aware of. Yeah, these will wear out over time. I mean, there's no, unless you've got an actual physical, half round or some sort of a door stop on the bottom. If you've got a flat one, the sweeps are going to wear out. That's for sure. That's just a wear item, I would argue. More deterioration of weather stripping. This is when the ex-husband couldn't get in. He kicked that door real hard. I don't know. It almost looks like a forced entry thing. I think it probably was. And then they put this extra heavy duty combination latch set deadbolt thing in after the fact. But yeah, someone's it's been damaged, obviously, and something to be aware of. Yeah, more damage. Again, probably same thing. I don't know if it's the same house or not, but could be. Yeah, missing fasteners. That's not, that's kind of a thing. So there should be like a 3-inch screw. I mean, that's kind of hard to tell when you do your inspections, when you, on these entry doors as well, like going through the, through the door frame into the framing around the door. And is it 1 or 2? I'd have to look again, but there should be, I think, at least 1 screw per each hinge has to be like a 3-inch. And usually when these doors come out, they leave some of these open. I think it's 1 per. They'll leave a 1, they'll have this already pre-hung and screwed to the thing, but there'll be 1 missing. And so who knows why or what happened here, but missing fasteners, good point. Overhead doors, okay. We have a situation here. This is the, the laser eye or whatever you want to call it, the sensor to make sure the door doesn't come down and squish your pet or kid or whatever. The door shouldn't even work with that thing on the floor like that, but that would tell me that it's probably been hot wired or disconnected maybe at the door opener itself. But yeah, it's not a good thing, obviously.
What's note about testing the sensors? So I mean, I definitely would recommend you guys test the laser eye and the pressure sensors if they're equipped. Most doors, even dating back 50, 60 years, will have them. Some inspectors may use a block of wood or whatever to test the pressure sensor. I would definitely not recommend that, because if the sensor is faulty, you might be buying a new door. So I mean, simply the force of your hand stopping the door should be sufficient enough. And if it's not, or if there's no laser eye sensor or one that's active, I would definitely recommend that they be installed or adjusted if need be.
Corrosion on the spring.
So generally, these springs should be
Damage, I mean, these
lubricated
are
every
things you
6
can see.
months, including the rollers. The damage on the vehicle door, not really a defect per se, as long as it doesn't impede the actual operation of the door. But it's more of an aesthetic comment that you can make to your clients, the buyers, just because, again, some people might be really fussy and they may not want to see any damage, and it can be difficult to see the damage either the inside or the outside, depending on the light, which again is why I recommend investing in a good flashlight that's going to show a lot of these defects.
Oh, this is, are these self-closing doors, are we talking?
You bet, the man
Looks-
door.
Looks like a spring hinge here is what this is, so. Yeah, that's code requirement, so any doors between the house and the garage, attached garage that is, they have to be self-closing, so this is pretty much very common, at least 2 of these usually, top and bottom. It's just got a little spring-loaded hinge thing with you stick a nail, you tighten it up and then tighten a screw, but it'll make the door close. They did have some doors for a while. They were terrible. They had a little halfway up the door, there was a chain went in there and it went back into the door. It was just, I don't know, for a couple of years they run these things, but thankfully they got rid of them. The little springer with the chain would break, or the spring inside would break and they'd fail. And so you had a door that didn't work. These hinges are nice. They can be adjusted. If they do fail, they're easy to change, those kind of things. But it could even be a hydraulic closer would work as well. Not very often you see that, but this is kind of the norm, you guys will see. So bypass sensors. Oh, this is back to the, is this not the same as the laser sensor, or what are we looking at here?
Yeah, you bet. You can just see homeowners bypassing the safety.
Oh,
measures.
bypassing, I'm sorry. Yeah. So they just rigged them up together. Yeah, it's cheating, but okay. Not the intent of the manufacturer of that door, not doing much good up there. Poor installation. Well, yeah, I'd be surprised if this is going to open too many more doors. Heavy corrosion. Garage common door defects. Oh yeah, well that's just going to be it's a visual thing. That's moisture in there. I don't know if this guy was using his garage as a wash bay or something, but not very good. Kind of got me on the watermarks here as being a garage door or garage interior. I'm sorry. Okay, so that's plywood right down on the ground, OSB. Not a good idea to start with, but I don't know what's going on in this garage, or if there's been some exterior issues with drainage or any of that kind of stuff.
Yeah, more just kind of be mindful, guys, whether it's a detached or attached garage, that if you see watermarks on any sort of like bottom plates or drywall or OSB, plywood, whatever they have, just be vigilant again. So typically, whether you start on the outside or the inside, again, one usually affects the other, right? So if you're doing the inside portion, you see watermarks. Well, when you go outside, just try to find out what's causing it. Is the downspout not being extended away? Is it poor grading? Or if you're starting on the outside and you see just siding embedded into the earth, or again, cracked downspout extensions, just be extra vigilant to look in these areas once you're inside the garage or the house, whatever it is.
Yeah, that is just a thing I see too, as well as even people building garages. Slab on grade is a common garage type of construction, right? And they don't raise that pad up off the surrounding ground very well, or improper drainage, or they don't use treated plates on the bottom of the walls. And it's always desirable to have your framing off the ground somewhat if you can. Concrete driveways. Okay, well, this is getting away from me on the code stuff for sure, but unfortunately I've been that guy on the rake a few times, and it's no fun. But let's have a look and see what they got. So they're reinforcing this. That looks pretty good. spalling. Yeah, well, that can be a couple things. Um, often it could be a bad mix. It could be throwing water on top of it after it dried out too fast for you. So the surface of the concrete is a lot weaker than the bulk of the concrete. It started to cure on the people, so they in order to get a decent broom finish on it or level it out or whatever, they threw too much water on there, and now the surface is weak and chipping off. Could have some issues with, I did have some experience with concrete in the past. It's not code stuff per se, but there's lots of things can go wrong or be issues with concrete. And, it could even be in some driveway locations, salt and things like that, chemicals, things like that. I don't know if you want to chip in, Alex. I mean, one thing
No,
about concrete, it does show the problems usually can become evident fairly easily.
yeah, there's a lot of reasons why spalling may occur. I mean, honestly, there's quite a few reasons. Big thing is just let your clients know whether it's spalling or cracked. Settling, of course, is could be a different concern. That likely is because that's usually not due to the actual concrete mix or the
Right.
or the pouring process. But I would still recommend that you point it out just so they're aware of any sort of defects, because who knows, maybe they looked at the structure of the driveway when it was covered in snow, right? Or maybe it was nighttime when they viewed the house. So if you see the spawn, just let them know. It's a very common thing though.
Yeah. Well, and very expensive to change or fix if you want. It's one of the problems. And so the settlement sinking one here too, I don't know. It looks like there was some ties or something. I'm just curious, but a good industry practice would be to actually dowel in some rebar and epoxy it into, if there's a concrete slab or foundation here, which there likely is. Some guys will put dowels in, but they don't epoxy them in. And then those dowels can actually, if they're not epoxied into the existing concrete, they can pull out. I mean, you put them in by hand, they can pull out by hand. So there's a multitude of things that can be going on with concrete, but this I really know nothing about. Or did you want to talk to that, Alex, at all? I mean, you see them a little bit, I guess, but
Yeah, maybe just from the inspection aspect, we won't talk about the design of it here.
Yeah.
We're trying to stay on time, or we'll probably just burn through our slides here as well, just so we can get out at a decent time. But
okay.
with asphalt driveways, if you guys see any sort of heavy cracks, any sort of vegetation, any sort of poor grading, or even you may see where they've resurfaced the driveway with asphalt and now the siding is embedded into the asphalt, you want to point these items out. Right, any sort of crack should be sealed, vegetation removed, and again, try to keep the grading slope away. And we're going to really hammer this pretty quick here.
Okay. Walkways, a couple different types, I guess. Concrete, wood, obviously. Again, back with spalling, settlement, same as your garage driveway type issues. Handrails, guardrails missing in situations like this. Moisture at the anchors. Yeah, these can be bolted on, or sometimes they fall away from the house. Settlement. Frosty, yeah. So this is pushed up, obviously. This is staying near the house, so you're hinging up this way. That is definitely a frosty indication. Ties not cut off. This isn't good just because it's a moisture, another breach through your exterior. Cracks falling. Poor design. Yeah, that's just kind of crappy. Someone's trying to do something funky here and really creating a tripping hazard of sorts and guards, the rest of it. Yeah, this is really shitty. Needs some work for sure. Guards, rails, handrails, all those other kind of things. Improper foundations, probably due to the height of the decks. This is not sure, but this eavesdrop's going to find its way back inside, I think. Not
Yeah,
properly.
I can speak to that. I think we actually have a slide as well coming up, but it's really common to see the downspout extension being terminated right at the front landing or the rear side landing, whatever it is. So obviously you can see over a few years, the soil has been eroded by the water because all the water from the roof line is going to be taken down through these downspout termination points. So you may come across homes that actually have footings for, say, the front entrance or even the deck where the downspout is just aiming towards the actual the footing support. So I mean, I've seen it myself where the water has actually damaged the concrete footing during the freezing cycle. So yeah, I would just recommend if you guys see this kind of stuff, just let the clients know that you recommend that they terminate the extension somewhere else besides, you know, the front landing or the side landing, whatever it is.
Basement entrance, yeah, I think this one has a drain, is kind of nice. That's important. This, I don't know what's going on here. Hopefully that ties into something, but yeah, anything like that, you're gonna want to have way for water not to sit, I think.
Yeah, what I'd recommend you guys do is actually test the drains as well. So obviously these two images, you may want to recommend getting some guards for the image on the left-hand side. You want to have handrails on, you know, for both stairs. If the stairs are wider than I believe 48 inches, you are required to have two handrails, right? That way it's almost like a dual traffic entrance. And like I said, 60 to 80 liters is what I would recommend you guys pour down the actual entrance drains. Because if you want to go to the next slide here, Brad, you guys will see.
Yeah,
some
they
images.
did take away that two handrail requirement a couple code cycles back. It's a house, it's only one now, one handrail. But if it serves a house. Yeah, obviously the drain's not working. Yeah, no guard, no drains, no handrail. Bad. Yeah, not high enough. Arguably climbable, but that might not be as big a deal with the current codes. Too big a step. Yeah, I did kind of take a look in about this height here, and they said something about not more than, you can have this down not more, it's not supposed to be more than 6 inches, but no drip here. Obviously, we can see wood framing underneath here. Something's not pretty. Water mitigation, I think this is just a title slide, I think. So getting into gutter stuff now, I guess. Nail pops on trough, clogged gutters, I think obvious things.
And once again, guys, this is where the surface mitigation starts, right? The actual roof line. So if you notice the gutters are clogged, again, kind of be extra vigilant once you get to the interior of the structure, because there's a good chance if the gutters are clogged, the water is actually going to be cascading over the eaves, which again is really common. Nail pops. They don't typically use these spikes anymore. They usually use wood screws, which is much better because they actually can screw into the fascia. One of the causes for the nail pops is, you know, if the gutters are full of ice and snow in the wintertime and then the water expands, you can start to pull away from the actual structure. And of course, there's no one to recess them back in. And over time, those holes can get quite a bit bigger through the movement of, you know, the freeze thaw cycles. So just something to keep in mind, because eventually, if this can persist, you can actually get a complete collapse of the system.
Yeah, so I guess this one refers to the, you know, going down onto the roof, which isn't really a great thing. I don't know. None of this stuff really is really well dealt with in the building codes, right? They talks more in performance requirements insofar as making sure the water gets away, but there's no code saying you can't do this. But I appreciate it's not desirable. You can burn a hole in that particular part of the shingle or whatever. Tree damage.
I've definitely seen quite a few times where we actually have water intrusion due to the fact that the gutters are open-ended or the downspouts simply terminate in one area. Because you have to imagine, especially in the colder climates, once you start getting ice blockages with these in these areas, you can get ice damming forming right underneath the shingles, which we'll talk heavily about in roofing, I believe, on Friday. So again, not required. A lot of shingle manufacturers will actually void the warranty if they see this kind of work, just because, again, you're taking that whole all the volume from the roof line and you're putting it into these select portions, right? What I always tell my clients is, you know, the water made the Grand Canyon. They can do a lot worse to your shingles. So
Yep, you can go through concrete with water, you betcha. Crap in there, obviously, no trough. Well, that's not great. You know what I mean? Like, I hope you got some good drainage away from the house on that one, but. Oh, I see. Okay. So they're going into another trough down below, it looks like. So this is better than running it over the asphalt. Yeah, well, here you go. This has caused premature wear of the roof system here. Missing extensions. Oh, yeah, okay. This isn't getting away from the house. Might have been a pipe that just wasn't hooked up. Yeah, okay. Well, this is obviously pretty bad. Might work for a while.
So if you guys see those areas, right, like all these slides we're looking at, if you're noticing these defects, that's where you really want to pay attention to, because like I said, we're going to be looking at some water intrusion here.
Yeah.
Go ahead, one more slide, you bet, Brad.
Yep. Yeah, well, again, no good. Rain barrels. Well, I don't know. This one, if they thought it out a little better, maybe you could get some garden water out of that, but problematic.
Can I add to that?
Sure.
I've come across a lot of rain barrels recently, and there's no overflow mechanism. So I always make sure that the buyer is aware that once that rain barrel is full, it's just going to overflow beside the foundation. So always make sure that they install an overflow mechanism to move that high water away from the home.
Yeah, the ones you buy that I've seen, I've used them, but off my garage, for example. But then they'll have another an outlet, towards the top of the barrel. You can actually put a garden hose on or something, and then run it off into the alley or whatever. But yeah, it's a good point. Yeah, I don't say the water's not going to get far once those are full. Yeah, this is bad. You moisture around your foundation. You can have frost issues. Clogged drains, obviously a problem. Yeah, and you don't really want it on your sidewalk, I don't think, where they set that up. It almost looks like a pop bottle on the end of it or something here, but I don't know what that's about. Damage, yeah. Yeah, this is really bad. I mean, this is obviously a recipe for disaster. It's when you get flooded, wet basements and such.
Yeah, these are really good photos to show you guys again, right? During an active rainstorm, this is where the water goes, right? So, if you're doing an inspection, you see this, just be extra vigilant once you go downstairs. And like I said, right, pretty quick, we're gonna look at some really great photos.
Yeah, same thing, draining over the shingles. Not sure what the plan here was, but it looks kind of cool. Grading, that's what we're getting into. So yeah, this all makes good sense. Yeah, so this is sloping back to the house, building, whatever, bad on all levels. Same thing again. I mean, this is just a recipe for disaster. Watermarks, yeah, moisture's getting in. More moisture issues here. Yeah, oh, for sure, it's not good. It's dark and probably is some form of mold, yeah.
I'll speak to these. So here in Alberta, so again, guys, only 2 provinces actually regulate the home inspections industry in Canada currently. In Alberta, you are allowed to actually lift up the carpet, to look below, as long as you don't cause damage to the fibers, of course, in the baseboards. But again, if you are noticing any of the stuff that we've been talking about for the exterior water mitigation, I would recommend, if you can, lift again without causing damage, take a peek, because you'll be surprised how many areas actually have possible mold and water intrusion. And again, the reason why it says possible mold is unless you actually test it, unless you are certified to take the swabs or the tape lifts, whatever it is, and send it for analysis, you don't know that it's mold. But again, you'd be surprised how often you'll find areas of thick new paint on the baseboards. But if you were to pop the carpet, it's just all the the smooth edge is just completely shot.
More examples, I guess.
Yeah, absolutely. I mean, if you speak to the insurance providers for home inspectors, this is one of the biggest loss areas for them, just water intrusion, whether it's surface or cracks in the foundation wall. But again, right, if you're able to just to kind of pull back the baseboards a little bit, you can see possible growth here, right?
More of the same.
Yeah, and you can see, just fresh paint, right? But if you pop up the carpet, it tells a different story. So
Okay, well, this is not good, but check the neighbors. Oh yeah, I suppose. Oh, we're into retaining wall issues. Yeah. Yeah, well, there's, yes, there are issues around retaining walls, and obviously these are staring at you as problems, right? Cracks, leaning walls, wood ones with rot in them. They're supposed to be draining, if they're properly done. There should be like essentially weeping tile on this side on the opposite side of any retaining wall to move moisture away is one thing, but keep that hydrostatic pressure down. This looks pretty light just looking at it, right? And obviously it is because it's leaning.
Did you speak to just what the actual design code requirements are for?
Yeah, I just was thinking actually, it's we have a standata the province has issued on retaining walls, and okay, if it's not more than 4 feet in height, I don't know that we regulate it, but I'd have to go through and read the standout. It's kind of complicated. It's a few pages long, but basically, if it's not what they've determined at the provincial level, if it's part of the landscaping, I guess just to kind of give you the Reader's Digest version, they put different parameters on it. But if it isn't to do with the foundation of the house, and I think they use a 45-degree angle kind of scenario. So if I have a retaining wall and it's 4 feet away from my house, and if I go on a 45-degree angle from my house, which they're saying is basically soil should be stabilized at that point, we don't regulate it under the building code. So if it's something that's required, so say I have a fairly high retaining wall, 6-8 feet high, and I'm on a sloping site and my neighbor's property drops down that much, and my house needs to be, that retaining wall is there to help maintain the structure of the house, then it's going to likely require some sort of professional design. But if it's not to do with the